Welcome to the complete JavaScript course. This course contains more than 30 different JavaScript topics. After almost any topic, you will solve a code challenge or you will create a small game project to practice what you have learned. During this course, you will solve more than 30 different code challenges and you will create 7 different game projects. This course is built from more than 50 different independent videos that I have created during the last 15 months. Sometimes I may mention another video, but don't worry, you already have watched it earlier in this course. So you will not need to search for separate videos to continue learning. At the beginning, you will see 2 short videos on how to install Google Chrome and VS Code. I will also show you how to download files from GitHub because all the code from this course is stored there. So if something does not work in your code, you can download my version from GitHub and compare it with your code. After that, we'll start learning JavaScript. You don't need any previous programming experience for this course. This course is designed mainly for complete beginners, but it is also suitable for people who only know HTML or CSS. There will also be a few small HTML and CSS videos because we need some HTML and CSS for our JavaScript projects. If you already have experience with other programming languages like Python, Java, C# or Go, this course may feel a little slow for you, but you still can follow along, just you can skip some explanations and go directly to code challenges and projects. But I highly recommend to complete all practical parts. If you're a complete beginner, I recommend you to study only 1 or 2 topics per day. Your brain needs time to create new neural connections and understand new information, so don't rush. Consistency is much more important than studying many hours one time and then stopping for a month. Even 10-20 minutes every day is much better than 10 hours once per week. I also recommend you to create a small timetable and follow it consistently, but do not make schedule too difficult. If you feel overwhelmed, reduce the amount of time you spend coding every day. For this course, I decided to use game projects as the main way to learn JavaScript. Programming should be something that you enjoy doing, and game projects can really make the learning process much more interesting and motivating. One small warning before we start. I have been working on this course for a very long time, so sometimes you may notice small grammar mistakes or slow explanations. But during this course, you will see how my English improves together with your JavaScript skills. Now let's get started. How to download Google Chrome easily. First, find a Windows button on your keyboard and press it. Then write word edge, E-D-G-A. Press button enter. Then write the word chrome.com, chrome.com. Press button enter. In the center of your screen, you will see a download Chrome blue button. Click it. When Chrome setup will be downloaded, click Open File button. Then click Yes. Google Chrome starts the installation process. After the installation, you will see a Google Chrome browser open up. How to download and install Visual Studio Code. First of all, open up your browser. I use Google Chrome, so I will open up Google Chrome. Then write Visual Studio Code download and press enter. The first link should be from the official website. There should be https://code.visualstudio.com. Click it. You will see different choices and you need to install the program on the platforms that you have. For example, I use Windows, so I will click Windows button. Download starts automatically, so you need to wait when the installer will be downloaded and then you can open up it. Once the installer will be downloaded, you can click on it, or if you don't see, you can go to your file and downloads, and here you should see the VS Code user setup. Here you can double click on this icon. Or if you don't see any files in your downloads folder, try to use the direct link below. Or maybe you use antivirus programs that you need to turn off or add the Visual Studio Code in the exceptions to access the download. When you open a setup file, read the license agreement and click I accept the agreement. Click Next. Then choose the folder where the Visual Studio Code will be on your computer. If you like the default folder, you can just click Next. Then you can click Next. Here I like all checkboxes by default, but if you want to create a desktop icon, you can click Desktop Icon checkbox and then click Next. Then click Install button. After the installation, you can click Finish. The Visual Studio Code will be opened automatically. How to download GitHub files and run it in Visual Studio Code. You don't need to register on GitHub to download any files. All what you need to do is to find a repository that you want to download and then find this beautiful green button, click it, and the last option will be download zip. It will download all files from repository. But if you want to download one single file, you can click on the file. Then next to the raw icon, you will see download raw file. Or you can click three dots and here you will find download button. I want to download all files from this repository and run them. So I will go back and click download zip. In the right top corner, you will see the files that have been downloaded successfully, or you can find it in the downloads folder. Then you need to extract the folder. This process might be different depending on the tools that you are using. After extracting the files, open Visual Studio Code. In Visual Studio Code, in the left top corner, you should find File button, hover over Open Folder, and choose the folder that you have downloaded. Then click Select folder. Now you can modify and save the files from the folder. A great thing about JavaScript that this is built in our browsers, so we can start coding from our browser. We'll use Google Chrome browser. Open a new tab and write about blank. About blank. Press enter. It will open a new blank page. Here, if you right click on the white zone, you can see inspect property. Click it. It will open a DevTools. They might look like a little bit different, but the content would be the same. We have Elements tab, but we need to find a console tab. So maybe you don't see a console tab. For example, your window is very small. So you need to find this double arrow icon, click it, and here you will find console. Then you can a little bit adjust these tools. For example, you can drag this border. Also, you can find a settings, and in settings, in preferences, you see a theme, and you can choose a dark theme. Next to the gear, you see three dots. If you click it, you will see dock side, and you can choose dock to right to have the same position of the DevTools as I have. Okay, cool, but why we need it? So you can start to use JavaScript, for example, for calculations. Yeah, JavaScript has built-in calculator, so we can choose our blank line. I zoomed in to better see the consoles that we have. And here I can write any number, for example, 59. Then I can press tab. And what it actually does, JavaScript gives me back the same number. Okay, it would be the same as write in the calculator 59 and you will return the same number. We have the same operators that calculator has. For example, I can start to sum two numbers with plus sign. And you start to see a placeholder with the result. I didn't even press enter, but I already see the results. If I press enter, it will automatically save these lines and open a new line. Okay, you have the same operators with minus and with multiplication and with division. You might see that symbols a little bit different, but the meaning is the same. So, okay, it's cool. You have a calculator and now you have JavaScript and you can do the same things. But what actually JavaScript can do, but calculator can't? JavaScript can assign these numbers to memory in our computer. It might sound a little bit complicated, but look, to better understand how memory works, I will show you this image. Like, these blocks are cells in your memory that might be with some data. In our case here, number 50, here number 5, or they might be even empty, like this cell, it's empty. There are different blocks, and JavaScript can take data from one cell and take it and give it to another. Or, for example, take it from one cell and copy to another. This is absolutely possible. Or I can take and replace some data to another. From this point, you start to see the difference between calculator and JavaScript, that calculator don't have too much memory. It may be save only one number, last one result, but JavaScript can save a lot of different results. And also, it not only works with numbers. For example, we can have dog and kiwi in our cell context, because JavaScript can work with different data types. We have numbers, this is first data type, but actually second data type is string. String is common text, as here we have dog or kiwi. This is text that we understand like people. But let's return to our JavaScript. How to make this drag and drop in the JavaScript? First, you need to write a keyword let to get access to a memory. It actually says to program that, hey bro, I want to take a memory with empty space. Can you give it to me? And the program would reply that, yeah, I can give you this empty cell, but you need to write an ID, some sort of name for this cell, because in the future, you will not be able to get access to the same cell with keyword let. You need to write this ID, this name, and it should be unique. So I can write label 1. Here we have some restrictions. For example, I can't write only 1. I need to use English letters and I can combine them with numbers. Then I need to put another space and write equal. So all the information that we will write after equal sign will be saved to this cell. Let's write 50. Now we saved our 50 to label 1. So then I can press enter. So, and now program returns undefined. It's nice. Now, how to get access to this data? We actually need to write a name of our block. In my case, this is label 1. I will type label 1. And then press enter. In this case, you see that the program returns me a number 50 that I put on this label. And now, how to change the data? To change the data, I need to call the name, then put equal sign, and then I can write new data. So it would be the same line as we have with let keyword, but we don't need to use let keyword, because let keyword means that you take an empty cell from the memory and you want to give some information to this cell. So let's write label 1 equal, and for example 40. In this case, program return 40 as a number. And if I write label 1 again, we see 40 because we replaced the previous value. Now label 1 can't give you 50 anymore. We took the last data, deleted, and wrote a new number instead of that. If you understood these basics, please subscribe on the channel and press like on this video. Now let's solve your first code challenge. You need to take an empty cell, give it a label of cell 1. Then you need to give a data of 40. And then you need to change this data of the same cell 1 to data 20. So if you will write in the console log cell 1, you need to see the result of 20. Pause the video if you want to solve this challenge by yourself. But right now, let's solve it together. First of all, I write keyword let, because I want to take an empty cell. Then I write a cell 1, because this is the name of our cell. Then I put equal sign and I give the 40. I press enter. Now, if I write cell1, I should get 40 as the result. Cell1 gives me 40 as a result. But now I need to put another data to cell1 and it should be 20. So I write cell1 equals to 20 and I press enter. And if I write cell1 right now, I have 20 in the console. How to run a JavaScript file in browser from Visual Studio Code. Then you need to open a Visual Studio Code. Here we need to choose our folder where we'll have our files. I will click open folder right here, or if you don't see a welcome window, you can go to the files. Here you can find open folder. So choose this option to open a new folder. Then you need to choose the directory where you will have your folder. For example, I will choose this lesson 2 and then I will click select folder. It will open a Visual Studio Code in a new window where you will be able to see the name of the folder that you have chosen right here, yeah? So next to the name of your folder, you will see new file icon. If you click it, you can write script.js. You can write script.js to create a new JavaScript file. The first part of this name might be whatever you want, but it should be ended with .js to create a JavaScript file. Now we created our file, and as you remember, we can write something like 60 minus 10, and if I save the file, I will not be able to see the results, because the result of this file is not automatically connected to the terminal or console. Our first step would be to add additional line that will connect the result with the console. I will delete this line and I will write console.log. Console.log. Now I wrote console.log with parentheses, and inside of the parentheses I can write whatever code I want. For example, again 60 minus 10. If I save the file by Ctrl+C, I will again not be able to see my results because now the results will be in the console, but we didn't actually have access to our console. The easiest way how to get access to our console is to actually connect your JavaScript file with browser and look at the console in the browser. We will use live server extension to show our JavaScript file in the browser. On the left hand side, you will see a bar with different icons. The last one should be extensions. Click it. Here, write live server. Live server. So you should find one created by Ritwik Day. You can press install right here or click somewhere in this area to open the full version of this plugin, and then you can click install. After the installation, you will be able to see Go Live button in the right bottom corner of your screen. Let's choose our JavaScript file and then click to Go Live button. It will open a JavaScript file in a new blank page in your browser. In my case, I use Chrome. Here I can do right click, then find inspect property, and you will see if I choose the console, we'll not be able to see our results. This is because actually JavaScript can't be directly connected to our browser. Our browser requires HTML file to understand the JavaScript file. So to fix our problem, let's create HTML file. I will go back to the Visual Studio Code, and on the left hand side, the first icon will be Explorer. I will click it. Here, the same as I did our JavaScript file, I will find a new file icon. I can click it and write index.html. It will create a blank HTML file, and to fill it you don't need to have any knowledge about HTML. You can just type an exclamation mark and then press enter, and you will see the basic HTML file where we need to add only one line. After title tag, press enter and write script column source. Script column src. So script column src for source. Then I can press enter and it will generate the line for me. Inside of the quotes of source property, I can write the name of our JavaScript file. In my case, this is script.js. Script.js. So when I save the file by Ctrl+C, it will connect the JavaScript and HTML file together. Now I need to reload our connection to the browser. Now in the right bottom corner, you will see that Go Live button have been changed to port 550. Click it to disconnect your previous page. Then you will see again a Go Live button. And now, very important thing, to choose our HTML file, not a JavaScript file, but HTML file. And then I can click Go Live. It will create a new blank page, and here if I choose Inspect Property in the console, I will see our results and the line that live reload enabled. Learn basic data types in JavaScript. Here are some suggestions how to follow along with this tutorial. So at first I will introduce the topic, then I will explain using different images, and then you will be able to write the code on your computer. And also at the end of the video, you will have a code challenge that you might solve by yourself, and then we will solve it together. In this video, I will use Visual Studio Code. Let's start from numbers. But at first I want to clarify what means double slash. This means notes or comment, part of the code that people uses to understand what is written in the program, but the computer actually ignores these lines and process the following code without these lines. So they are just notes. We can write numbers as a title for our first section. Let's start from the example 50 minus 20. As you remember, if I save the file by Ctrl+C, I should expect 30 as a result. But to actually see the result in the console, I need to write one additional line. It calls console.log. Console.log. And inside of the parentheses, I can put my equation. In this case, I will write 50 minus 12. If I save the file, I still won't see the results because we need to connect our JavaScript to the browser. I will use HTML file and live server extension from my previous video to connect JavaScript and browser. In the HTML file, I will press Go Live button that is in the right bottom corner. Then you will see a blank page in the browser. I will adjust both these windows, and in the browser I will do right click, then inspect, and here I will find console to see my results. As you see, we have 30 at the result. So because in the JavaScript file we expect 30 from this equation, all it works as intended. In the JavaScript file, I will press Ctrl+B to hide the file explorer. In this way we will have more room. Right now let's create some variables. Let's start from variable number1. Let number1 equal 10. So I use let keyword to create a new variable where I will store the value of 10. If I save the file, we will not see any changes in the console, but let's change num1 to something more interesting. For example, num1 equals to 10 minus 2. In this case, we understand that the result is 8. To actually see the results, let console.log the num1. Log num1. So if I save the file, we'll see 8 in the result because num1 equals 10 minus 2. So let's create more interesting example. Num1 equals to num1 plus 92. So in this case, we can't immediately get the result because we see that one number is 92, but the second number is not clear because this is a text. So we need to understand what the number behind this text. And as you remember, num1 is equals to 10 minus 2, so to 8. Console.log num1 will be 100 because first number equal to 8 plus 92. To better understand how it works, I will show you this simple example. So this is our memory. And as you see, we have memory cells with name of 50 and value of 50. The same as 12 and 12, 2 and 2, and so on. So because we actually can't write let and name with number, because all numbers as name is built in JavaScript and have the same value as the name of the cell. If you write 2, so it will go to the cell 2 and take the value of 2. But as you see, we can have cell num1 that equals to 8 and actually cell 8 that equals to 8. So in different cells, we can have the same data. And what happens if I write num1 equals to num1 plus 92? When I write num1 equals, it means that JavaScript should find the cell with num1 as a name and create a copy of that to change the value to a new one. I will create a copy and then the initial data will be empty, but we can't actually leave this as num1 equals to nothing, because as you see, we have two cells with the same name. But as you remember, we can't have two cells with the same name. We need to calculate the results, and the JavaScript will automatically replace an old one to a new one. When I write num1 equals to num1, it will go to our previous cell and find the value that contains in this cell. In our case, this is 8. So it will add 8, and then I write plus 92. So it will go to the cell, find the label of 92, and get the value of 92 from the cell. Now we see that result of this calculations is 100. So JavaScript will take this cell and replace it instead of old one. So I can delete our old one memory. And now we have new num1 with 100 as a value. So after this line, num1 will not be equal to 8, it will be equal to 100. If I will write let num2 equals to num1, I will see that num2 is equal to 100. Console.log num2. And if I save the file, we see 100 from line 15, what is right here. So we see that num2 is equal to 100, not to 8. Finally, let's create one more interesting example. Num1 equals to num1 minus num1. What will be in the console if I write console.log num1? It will be 0, because it will take num1 that equal to 100 and then subtract the num1 that also equal to 100. So if I write num2 equals to num1 and console.log the result of num2, I will see 0 again. Right now, try repeating the same code by yourself from the memory. Let's talk about strings. I will start from one example. So I wrote word zebra, and as you see, it enclosed in quotes. This means that this is a string or common text. If I write in the console and save the file, you will see zebra as common text in the console. Let's have one more example. Let's animal equal to zebra, and if we console log animal, it will get zebra in the console. Now we have two console logs, and they both return the same word of zebra. So right now I created a variable of my pet that equal to animal. And if I save the file, what we will see in the console? Will it be animal as a word or zebra as a word? The right answer is zebra, because as you see, animal is not enclosed in the quotes. So it means that it refers to some cell that contains the value, and in our case, animal refers to the cell of animal that equal to value of zebra. Let's look at our memory. We have two different cells. One cell animal contains word zebra in quotes, so it means that this is a common word. This data type is string. But the second cell is my pet, contains animal word without quotes. So it means that this refers to the cell that calls animal, and take the value from the cell and copy and paste it. So we will have value of zebra instead of animal here. And right now we actually have two different cells in our memory that contains the same value of zebra. Right now I wrote animal2 that equals to my pet, but as you see, my pet is in quotes. So if I save the file, we will see word my pet in the console, because this is not a reference as in our previous example. This is the final data of my pet, just common word. As you see in the memory, we have animal2 that contains word my pet enclosed in quotes. It means that this is a final data. We don't need to refer to any cell that calls my pet. We don't need it because we have quotes. Right now, feel free to pause the video and write the same code by yourself. The next data type is undefined. You might see two keywords of null and undefined. Null means nothing and undefined means I don't know or nothing. They are both very similar. I created a simple example of undefined value. So I created a cell with the name cell that not equal to anything. And if I save the file, we will see undefined in the console. Let's look at our memory. When I write keyword let, I means that I want to take a one empty cell. So JavaScript gives to me an empty cell, but it waits the name for the cell. And I can write cell as in our code. But then I just finish the code and show in the console the result of cell. But as you see, we didn't change initial value, that was 0 or nothing. So we see undefined in our console because the initial value was empty. Right now you can pause the video and write it by yourself. And our final data type is Boolean. Keyword true and false are actually Boolean data types. And we will use it to say yes or no, or to toggle different values. For example, let is rain equal to false. So is rain implies that this is a question that need to be answered by no or yes. So we can write no or false, and if I console.log this result, we will see false in the console. I toggled the value is rain to true, and now if I save the file, we see false from our first console and true from our second console. Boolean data types are actually very simple, but you will see them all over the place because you can always easily use them if the question needs to be answered by yes or no, true or false. Pause the video and write the following code in your computer. But right now it's time for the code challenge. At first, create the variable with name is lightning and don't change the initial empty data. Just console log it. It should return the undefined in the console. Then change the value of isLightning to false and create a new variable of energy with initial value of 0 and energy amount with initial value of 5000. Then console log all these values. You should get false, 0 and 5000 in the console. Then change the value of isLightning to true and change the energy by increasing it with energy amount. You need to take initial energy that is 0 and increase it with energy amount that is 5000 and then console log both these values and you will get in the console true and 5000. Then you can toggle back the value of isLightning to false and don't change the energy, so just console log it. You will see false and 5000 in the console. And finally, toggle it back to true and increase the energy by energy amount. In the console, you will see value of true and 10,000. Right now you can pause the video and solve this challenge by yourself. But let's solve it together. We start from keyword let to create a new variable that calls isLightning. Then I just console log this value. So if I save the file, you will see undefined in the console because I didn't change the initial value. I just created a cell with name of isLightning. Then I need to change the value of isLightning to false, create energy and create energy amount. isLightning equals to false, create energy that equals to 0 and create energy amount equals to 5000. We will not change this value anymore. Let console all these values. You can actually write 3 different consoles or you can write them by the comma. In the one console, you will see the all results in one line. I write all these values in one line and I see them all in the console as false, 0 and 5000. Then I should toggle isLightning back to true and increase energy by energy amount. Let's toggle isLightning to true and change the energy to energy plus energy amount. If I console.log these values, you see that isLightning equals to true and energy equals to 5000 because energy equals to 0 and energy amount equals to 5000. So if we sum 0 and 5000, you will see 5000. Then I need to toggle back isLightning to false and console both these values, isLightning and energy. Let's toggle isLightning to false and console isLightning and energy. So if I save the file, you see that we have false from isLightning and 5000 from energy because I didn't change the value. And finally, I should again toggle back isLightning to true and increase energy by energy amount. So let's change isLightning to true and energy equals energy plus energy amount. So if I console isLightning and energy, you will see true and 10,000 because previous energy equals to 5,000 and energy amount equals to 5,000. Learn if statements in JavaScript. Imagine that you are on a road with only one path that you can choose. You can, for example, choose to code or to watch Rick and Morty, and you know that if you choose one option, you will not have any time to another option, and this is a perfect example of JavaScript if statements. Quick note before we start, this notation marks means comments, the same as double slash that you can use. I just prefer to use these marks in order to separate title from common texts. So you still can use double slashes, but you know that this is the second way how you can put comments in JavaScript. Let's write our first if statement. This is one branch choice because we have only one row to choose, and you must start with keyword if. Then you should put parentheses, and inside of the parentheses, you should put the condition, your choice. In our case, it might be true or false, so let's put true. Then you should put curly braces, and I can open it with enter. And inside of the curly braces, I can write the action that I have chosen. For example, watch Rick and Morty. This is the path that I have chosen. So I put this in console log. If I connect it to the browser using HTML file and live server extension, I put go live button. We will see a new blank page where I can inspect it by right click and find a property inspect. And here I can choose console to see any changes in the console, and you can reload the page if you have any errors. And after that, we see that we have a line watch Rick and Morty. The condition in the parentheses might be also false. If I put false and save the file, you will see nothing in the console because it means that we don't choose this branch. If I don't choose this branch, if I don't choose this road, I want to show the program that I want to choose the second road, and in this case I can write a keyword else. After the keyword else, I should also put curly braces and then enter to expand curly braces. And right now, else statements means that if I don't choose first road, I choose second road. This is the rule, it always works. If your if statement is false, it means that you choose else statement. So let's write console log.toCode. In the console, we see learn coding from line 7. That is the line where we have console log. And you might see that there is small difference, like the program, JavaScript, try to show you the way that you have chosen. So you see that transparency of the line watch Rick and Morty is a little bit darker than the transparency of learn coding. And if I change false statement to true, you see that we have watch Rick and Morty in the console, and you see that our else statements are a little bit darker than the watch Rick and Morty. If we use true or false inside of the parentheses, the JavaScript can say you what branch you have chosen. Let's write one more console log, but after both these branches. Now I wrote independent action, I'm hungry, and you see that it goes after all these branches, and we see the result in the console. So we see our first choice, watch Rick and Morty, and after that, I'm hungry. And this is independent action because if I change the true value to false, save the file, you see that our first line have been changed to learn coding, but our second line is independent. It not depends on your choice. So whatever you choose, you can learn coding or watch Rick and Morty. After that, you will be hungry. So it's independent action. Independent actions you can write after if statements. So you see that whatever choice I do, I anyway see independent action, I'm hungry. One more note that actually else statement is optional. So I can delete this, and now you see my choice is false. If I save the file, I don't see this line, yeah, console log watch Rick and Morty. I see only my independent action. If I put true, now I see my line watch Rick and Morty. But again, if we have false as our conditional statement and we don't have else statement, our program just skips these lines. So this is the same for our program as comments, and it will only print the line that is independent without if or else statement. Not always we use explicit true or if statements inside of our conditions. We can write some variable, for example, my choice, and I can declare this variable a little bit above. So let my choice equal to true. And after saving the file, I will see this line because my choice works as true in this case. And I can also write false. And you see that I have only independent action in this way. It works the same as to write false right here. But the difference that if I write false, explicit false, you see that JavaScript immediately understand that this line will not be printed. But if I write my choice, even though that my choice is false, JavaScript don't actually show any clues that this line will not be printed. Most of the cases we use variables inside of the condition statements because we want to change them. But in this case, don't worry if JavaScript don't show you immediately what the action have chosen. Let's look at another example. Imagine playing a game where the player must choose one of the locations. Player might choose a farm or a dungeon. Let's choose a dungeon. And after that, the player have new choices that depends on the previous choice. So in this location, in the dungeon, he might find a treasure or he might be killed by a monster. And the same thing on the farm. Player might choose the farm, and here he can find apples or he might meet a villager. This action depends on the location. In this example, player can't be killed by zombie on the farm. Also, he can't find apples or villager in the dungeon. So what if we want to write these dependent actions? How to do it in JavaScript? So let's start from our first branch. I write if keyword. Then inside of the parentheses, I write true, then curly braces. Let's say that true means go to dungeon. I write in the console log, you found a dungeon. And after saving the file, I can look at the console. We see a message, you found a dungeon, because our condition is true. I can write else statement right now, but let's finish with our branch. Let's write this branch that if I have chosen a dungeon, we can find a treasure or be killed by a zombie. Inside of the if statement, I create a new line and I write new if statement. If, let's put here true, then curly braces, and I expand them with enter. And right now, let's say that true means find a treasure. So I console log find a treasure. We see two messages. You found a dungeon and you found a treasure. But if I change first true statement to false, you see that we have nothing. Yeah, we see nothing in our console. So it means that when you write nested if statements, like in our example, we wrote if statement inside of the if statement, this if statement, yeah, second action, starts to be dependent on the first choice. So if you don't choose a dungeon, you will not be able to find a treasure or be killed by a zombie. So this is how we realize this in JavaScript. I will return back this to true. And let's add some variables. Instead of the first true, I write let my choice as in the previous example. So, and I put my choice instead of true. It should work the same. I control it with console and I see that, yeah, I see both lines. So it means that our first line, my choice, equals to true. Yeah, equals to true. And let's change second line to something like luck or lady luck. I change our second choice with lady luck. So it means that not our player choose what to find in the dungeon, but it's some kind of accident choice, yeah? Right now, of course, we can change it. So for example, to false. And if I save the file, we found a dungeon, but we didn't find a treasure. I changed them both to false. And let's write our else statement. I write else statement for our first choice. So instead of the dungeon, I choose a farm. So I should find this yellow brackets. They might be with different color, but find that there depends to the first if statements. In this case, this is our last curly braces that has the same color as the first curly braces after my choice. So this is very important. And right here, write else. Then new curly braces, they're with the same color as first curly braces after my choice. I can expand them. And right now, what means else? Else means that we have chosen the farm. And inside of that, we have two choices: to find a villager or to find apples. So I start write new if statement. Here I can put true. And again, let's say that true means find a villager. I console log that you found a villager. I wrote that you found a villager, and let's check it in our console. Right now we see a message you found a villager, because in our first if statement, we have my choice. My choice equals to false, yeah? It equals to false. You can hover over my choice and you will see let my choice column and the value that it has. Right now it's false. Or you can see right here, it's false, yeah? It means that we need to go to our else statement. So inside of our else statement, which represent the farm, we have a new if statement with true. So true means that JavaScript should choose this branch. And this branch console.log the message that you found a villager. So it works as intended. And if I change my choice to true and save the file, we see that we have you found a dungeon. Because if my choice equals to true, it can't go to else statement. It doesn't exist in our file. So this is the same if our if statement is false. But I return it back by Ctrl+Z. And again, I can change it to false. Save the file. And I hope that you start to understand how it works, yeah? How we choose these branches depending on these actions. So let's also change true value in our second nested if statement to lady luck. In this case, our two variables controls all our choices, and we can change the value of lady luck to true. Save the file, and yeah, right now it works the same. And our final condition, our final else statement is to find apples. In second if statement, let's write else. And here I will console log you found an apple or apples. And I save the file, and right now I can see that you found a villager. Then our lady luck choice is equal to true, so we print this line. But if I change lady luck to false, save the file, you see that, okay, my choice equals to false, I go to this branch, and here lady luck equals to false, I go to this branch. And here you have console log you found an apple, what we have in our console. I also can add one line that you found a farm after the first else statement. So I add new line with enter, write a message that you found a farm. In this case, it's more clear that we will always have two messages. So if my choice is true and Ladylak choice is false, I have you found a dungeon. I also forgot to add this last condition, be killed by a monster. After our first if statement, I see that I don't have else statement. And I can add console that you was killed by a zombie. If we look at our map, we have 4 different choices. So if I choose the dungeon, this is true in our case. And then, for example, Ladylak choice is false. It means that we found a zombie and we have 2 messages that we found the dungeon and then we are killed by a zombie. And the same with all other choices. So we have 4 different choices and right now we can control them by these 2 values. It might seem challenging, so pause the video and try write the same code by yourself. And later you can compare it with my code, but this is really important to feel these branches, how they work, to create this simple map of different choices. Build a storytelling game in JavaScript using only if statements. This project is perfect for mastering if statements and for creating your first games that you might share with your friends. For this project, I will use a simple HTML file. We will not work with that, we will work with JavaScript file. Here you can see the title, that short storytelling game project. Before we start, I want to show you how to communicate with a player. JavaScript has a command confirm. It's very similar to console.log, but it will pop up messages in our browser instead of the console. I will write something like, do you want to play a game? And I save the file, I will go to HTML file and I use live server extension to display our project in the browser. I press go live button and right now you see that we have a pop-up message with do you want to play a game? Comparing with console log, we have 2 buttons, OK and cancel. And if I press OK, it will give me true value as the result. And if I press cancel, it will give me false value. So in this way we can communicate with a player. Let's save the result of the confirm message in the variable. I'll create let user choice equal confirm. And then instead of the console log, I will use confirm to show our results. If I save the file, you will see that our first message is, do you want to play a game? And if I click OK, you have a true value in the message because user choice equals true. So then I can click any button. If I refresh the page, we will again have the same message, do you want to play a game? And right now I can click cancel and you see false value. For some viewers, this white screen might be too bright. So let's change the background color in our HTML file. We will make our background darker. After the head block, you can add new lines and create style block, style. Then press enter. It will create a block with 2 styled hashtags. Press enter to expand this block. Then just copy and paste this line. You don't need to understand what it means because this is a JavaScript course, but it changes the background color to dark gray color. Right now, if I refresh the page, you see that we have these messages, but our background is dark gray. Once you understand a confirm command, let's start from our game project. I will comment out these lines with Ctrl/. If I save the file, we see nothing in our browser, just a blank page. And right now we can start with writing our new confirm message. I write keyword confirm, then parentheses, then quotes, and inside of the quotes I can write any text, for example test. If I save the file, we see changes in our browser. I can click OK. So if you look at the project, you see that I have created several branches that you might choose, but of course you can create absolutely your own scenario. This is just for people who don't want to actually think a lot about the story, who want to practice on the mastering the if statements. I can just copy this message and use it in our confirm message. I will delete the text and just copy and paste our message. So if I save the file, you see that right now we have a message from the police officer that actually gives us a choice between kitchen and the gym. So let's create another confirm message that will explicitly ask the player about the choice between kitchen and the gym. I create a new line and write confirm. And then I'll write some instructions, something like kitchen equals to OK. As you remember, we have two buttons, OK and cancel. I have to write some instructions for player, like if you click OK, it means go to the kitchen, and if you click cancel, it means go to the gym. So after OK, I can write gym equals cancel. But if I save the file, after the first message, you will see that we have this in one line, and this is a little bit like inconvenient. How to separate this text between two lines? For this we have \n symbol that makes the same as the enter. It just create a new line for the message. If I save the file, you see that after the first message, we have beautiful like 2-line message. And you can notice that after /n, I don't use space, because in this case, we'll have like both lines starts from the same place, from the same column. So if you look at our scheme, you see that after this message, we should make a new message depending on the user's choice. So it might be a kitchen or it might be a gym. So we might create it with if statement. I'll write if keyword. Then inside of the parentheses, let's write true at this moment. Then curly braces. And true means kitchen in our case, and else means gym. So as true means kitchen, I will write a message for the kitchen. So confirm. And inside of the quotes, I will just copy and paste this message. So right now I can save the file, and we will see that we have a first description from the police officer. I can press OK, and right now you have a message with the instructions like how to choose something. For example, kitchen is OK and gym is cancel. I will choose kitchen. And we have our new message with action go to the kitchen. I also see that I want to add here a new line because action go to the kitchen is something different from our text. So I will go right here. And I will add a new line with this \n. And if I save the file, I will click OK and OK. And right now you see that we have action go to the kitchen and then the text from the police guard. I think that it's a little bit easier to read. But right now we have one problem, that instead of the user choice, we use true. So let's save user choice to the variable. I might create a new variable like right here, like let user choice equal confirm message, and then use user choice instead of true. So I will save the file and refresh the page, and we should have the same messages. So I click OK, we have the instructions and OK, and yeah, we have a kitchen because in this case we have chosen the kitchen. I also might check cancel. If I choose gym, we don't have any messages more because we don't have if statements. Let's finish with our branch. Next choice that we have is actually to talk with a man or to eat a bowl of ramen. As you see, these actions depend on our previous choice. We should write them in the same if statement. I will add a little bit more lines just for readability. And then I will write a new confirm message with two choices. First choice is talk to a man. So it's OK. Then I write enter. And the second choice is chow down on a bowl of ramen. So I will copy this action. So we might check. I press OK, OK, OK. And yeah, you see a message that talk to a man, OK, and chow down on a bowl of ramen. And I forgot to write it equals to cancel. Right now we see these messages. It works as intended. And again, let's take it in the same variable. We actually don't need to use our previous user choice anymore. So I can just write user choice equal to new confirm message. And then I can use this in our new if statement. user choice. In this case, user choice true means talk to a man. And I will create a new confirm message. Again, I will copy and paste these lines. I will also create an enter. We can go over our story with just OK. And you see that we have action talk to a man, and this is Kyle, and he is a cook. So, and then we have a new branch of choices. Right now, I hope that you start to understand how it works. So we will use the same pattern to go like deeper to our branch before we finish our game. I noticed one interesting thing. I actually use Alt-Z command to wrap our file. This is the reason why you see these messages over here. If I press Alt-Z, you see that this message is a one long line, but to wrap it with our sizes, you can press Alt-Z. This is just one setting that I have noticed I didn't talk about. And our next choice is to slice a tomato or to cook a ramen. I will create this new confirm message. Right now, inside of this second if statement, I will create some enters also right here. Then I will write confirm. And right now I can copy and paste this action or our choice. Slice the tomato. Yeah, I should put that this is okay because this is our instruction. Then I will create a new line, and the second choice that we have is cook the bowl of ramen. And it's equals to console. Let's test it. If I press OK, we have, slice the tomato with OK or cook up the bowl of ramen, and I don't like this action word. I can delete it. And right now we have this clean two lines. You actually can like put these instructions inside of one confirm message, but why I separate them? Because I want to give the player like the concentration on the description. As you see, like we have a description, and right now a player might just read it, and then you have another action with choice. So we just separate the attention of the listener, and this is the reason why I want to like add several confirm messages. Right now, if we have chosen to slice a tomato, this is our first end of the game with the achievement like a young cook. So we can create a new confirm message with this achievement. But right now I see that we didn't finish with our previous confirm statement because we don't have a new if statement. So I will again save it in the user choice variable, and I can create our third if statement with user choice. And inside of this if statement, I can write a new confirm message. Again, I will separate them with enter. I think that right now we can save the file and watch our first branch. This is our first message, and this is equals to police guy that gives us a choice between gym and kitchen. So I press OK. I will choose kitchen. And right now we see some description about the kitchen. So if I press OK, we have a new choice between talking to a man and like eating a bowl of ramen. I will press OK, and we have a new message from this man that actually is a cook of this prison, and he asks us to slice the tomato. If I press OK, we see a new choice between slicing the tomato or cooking up a bowl of ramen. And here I will choose like slice the tomato, and it should be the end of our game. And like Kyle said that, this is one of the worst things that he has ever seen, but eventually we have our work in the kitchen. If I press OK, this is the end of our first branch. I think that let's create a second branch, and I think that from this point you will understand how to create this game and you will be able to finish it by your own. I should find action where Kyle asks me to slice a tomato. Let's find it in our code. In the second if statement, I see that Kyle asked me to slice a tomato, and we have a confirm message with choices where OK means slice a tomato and else means cook up a bowl of ramen. It means that in the last if statement, we can write else statement. That means cook up a bowl of ramen instead of slicing the tomato. I will create a new confirm message. And let's look at our scheme. Here we see that if you have chosen to cook a new bowl of ramen, like Kyle says that you ain't been listening, Rocky, so get out of here. And we have an achievement like exile slime. I copy and paste it again in our confirm message. And also let's separate these lines with this symbol. Right now, let's check this branch. Let's quickly check our second branch. We start from the same window. I go OK and choose kitchen. So we have some description about kitchen and we have choice to talk to a man. We have a new task from the Kyle. If I press OK, we're in the position of 2 branches. I will click cancel, which means that I will cook a bowl of ramen. And as you see, we have ended our second branch with achievement of exile smile. So it worked as it intended. At the end of the game, consider adding an independent action that displays a thanks for playing message. You might add it to every single branch, but much more efficiently to add it at the end of the file, because this is an independent action. Regardless of the user choice, we want to say thanks for playing. So I will go after all these if statements, create a new line and create a new confirm message with thanks for playing. And if I save the file, we started from our first message. I can click OK and we have our first choice. And as you remember, we don't have branch with Jim. So if I press cancel, we will see our independent message, thanks for playing. So I can click OK. Right now you have enough knowledge to finish this game by your own. And in the next video, we'll learn about more advanced techniques of if statements with new code challenges for practice. How to compare in JavaScript. In JavaScript, we have different comparison operators that might help us compare different things. Let's write a simple if statement. Let's console log that this statement is true. It's just for clarity that we can immediately see the results in our console. If we are using literal true, we see this statement is true. And let's write else. And this statement is false. As you remember, if we're using literal values, the JavaScript can help us to immediately see the result. So we see the transparency of the first line is a little bit brighter, a little bit greater than the transparency of our else statement. What if instead of the true or false statements, we want to compare different things? For example, 10 equals 10. I used triple equal operator to compare two numbers. If I save the file, we see that this statement is true. From this example, we understand that this comparison returns true because we see the same statement that was when we had true statement. And that's how it works. It generally asks a question. So is this number equal to second number? And if they aren't equal, for example, I put 1, and save the file, we have that this statement is false. Otherwise, it returns false, so our else statement is activated. Using this operator, we also can compare strings, not only numbers. For example, I can write 10 and ask equal to cat. And we will see false because 10 is not equal to cat. This example is obvious, but what if I put 10 right here? We still have false value. So you should understand that if we are using triple equal comparison, objects of different data types are always false. Even though that it seems that this value should be true, it is false. And it's really important to consider where you're using this operator. Let's try to compare two strings, Bob with capital letter and Bob with non-capital letter, and we have false because JavaScript is case sensitive. It means that capital letters and small letters are different. To get the true, we should have the same data types and the same letters. Right now you see that Bob equals to Bob and it returns true, but if I change one letter to capital, we have false. Right now, let's talk about logical not operator or toggler or inverter. At this point, I will delete Bob condition and write true. If I save the file, we again see true. I can put an exclamation mark in front of this true to toggle the value to the false. If I save the file, right now we see that we have false, and we can read it as not true. Not true is false. And the same if I use false value, not false is true. The behavior is really simple. It just toggle the value or invert it to the opposite one. And we may use as many operators as want. I may put two not operator signs and save the file, but we will see that it returns to false. If we are using two not operators, it's the same as say not false. It's actually true. This is the reason why there is no sense to use more than one not operator, because it will return the original value. Right now let's talk about the operator that is the combination between triple equal and not operators. Let's imagine that you want to compare two items. I will write dog equals to cat. And I have a false value because dog is not equal to cat. But what if I want to ask from the point that what if our first string is not equal to second string? If I use not in my speech, it means that I should use not logical operator. I can try to put it somewhere, for example, in front of the first word, and it seems that it doesn't work. Maybe I should use parenthesis. Yeah, in the parenthesis, it seems that it works. Right now it works as dog is not equal to cat. But we see that this structure is really difficult to read. What it actually does, it compares our two objects, then returns some boolean value of true or false, and then toggle it back to the opposite value, and eventually we have true. But as you see, it's difficult to read. And for these occasions, we have combination of both these operators that looks much simpler. And if I save the file, we see that it works in the same way. So I can read it as dog is not equal to cat. Answer on this question is true. So that's the reason why I have true statement. If I put dog and dog, we can see false, because if dog is not equal to dog, but they're equal, that's the reason why this condition returns false. You start to understand how it works, and generally it's much simpler to use just triple equal operators, because it's easier to ask questions that don't contain not inside of them. Next group of operators are mathematical comparison operators. If you know them in the math, they're working in the same way. So this is less than, greater than, or less equals than, and greater or equals than. Let's start from the first two ones. We are typically using them to compare numbers. I can write 10 is less than 10. 10 is less than 10. And if I say the file, we have false, because 10 is not less than 10. And let's also talk about how to read it. This pointed end or smaller part show the smaller number, and the bigger part, this kind of mouth, shows the greater number. In this case, it's quite easy to read. If you don't know them, so you can always think about them as, okay, we have two numbers, as this smaller part shows to the smaller number, and this like bigger part show the bigger number, so it should be true. But if I change them, right now you see that this is a smaller number and this is a bigger part, so it's false. Yeah, you can like spend time and think about them, especially if you are not used to these operators. And right now let's talk about second operators. This is more or equal to, and it returns false right now, but if I put 10 more or equal to 10, it should return true. Yeah, how it works, we can look at them as two different operators. So our first operator is greater, so I can ask a question, is 10 greater than 10? It's not. So I should check the second operator, that is equal. Is 10 is equal to 10? And I can say yes. Where we are using this operator, only one of the conditions should be true to return the all condition of true. One more example where I put here 4. And if I save the file, we have also true, because 10 is more than 4, yes. 10 is equal to 4, not. But only one condition should be true to return the true value that we have. When you're comparing numbers, you always should remember about 3 different outputs. If you want to compare two numbers, for example 10 and 12, it might give you 3 different outputs. 10 might be less than 12, 10 might be equal to 12 and 10 might be greater than 12. It's really important to consider always when you are comparing two numbers. You want to look at all these outputs that might be. Let's imagine that you have a program that compares first and second number, and if your first number is less than 12, or if your first number is equal to 12, it returns a smiley face, and otherwise we have only one output when first number is greater than 12. In this case, it returns a motionless face or a Squidward face, yeah? This scheme considers all the three outputs that might be. And in the case where you want to reduce amount of outputs to only 1, as we have right here, it's better to use this scheme where you're combining operators less and equal together to get one condition, less or equal. Both these schemes work absolutely identical, and only one difference that we have, that in the second scheme we should create only 2 if statements, and it's easier to work because we have 2 outputs and eventually we have 2 outputs. We don't need to consider the third if statement, we have less code and it's easier to read. Master if statements in an Akinator style JavaScript game, the idea that player write the word and Akinator pop up the messages with his thinking. For example, the first condition that the Akinator will check is that the player's word contains more than 0 characters. So in this case, he might write that you have a word, because it means that your word is not empty if it contains more than 0 characters. And otherwise, he will write a message that I know you didn't guess anything. And this is the first condition where Akinator might win, because your word is empty. Our next condition will be if the word's length is less than 7. It means that you made a word between 1 to 6 characters, because this is a chain of actions and these actions are dependent. As we checked in our first condition that the word is more than 0 characters, and right now we are checking that the word is less than 7 characters, it means that the range of characters from the 1 to 6. It's really important to consider that you should write dependent actions, and otherwise, if your word is more than 7 characters, Akinator gives up because the word is too big for him, too complicated. The next condition is the checking of the specific word. In this case, we will check the word carrot. So if the word is not carrot, the Akinator says that your word isn't carrot and why you don't eat enough vegetables. It's really important to use absolutely the same operator as his is described, to practice with different comparison operators. And otherwise, if your word is carrot, the Akinator will write that your word is carrot and I know that I'm smart, because he guessed this word quite fast. The next check will be quite interesting because we will divide our word into 2 sublists. Like, if the word length is less than or equal to 4, it means that your word has characters between 1 to 4. Because as you remember our previous condition right here, we know that our word might contain only characters from 1 to 6. So the length of the word might be from 1 to 6 characters. This is the condition based on the previous. Right now we are talking about the higher limit. We put a new limit of 4 and this is less or equal. So it means that our higher limit will be 4, but our lower limit will be the last one that we had, so it's 1. And otherwise we have this remaining 2 possible lengths of 5 and 6 characters. In this condition, we actually divide our condition of 1 to 6 characters length into 2 subgroups, and then we'll have the last check that is the most interesting and complicated. If the word length is between 1 to 4, and if your word is Bob, that contains 1 to 3 characters, so it's absolutely possible. The Akinator write that I knew you made your name, and it was very easy. But otherwise, if your word is not Bob, he will say that, like, I tried my best, but your word is too difficult for me. Very similar check in the second subgroup, if your word is between 5 to 6 characters, and if your word is paper, that contains 5 characters is also suitable for this subgroup. Your word is paper. I know that you want to play rock, paper, scissors game. This is the condition where Akinator wins, and otherwise he will write absolutely the same phrase. Try to solve this code challenge by your own, but right now let's solve it together. I start from the first condition where I should check the word's length, and for that I need 2 variables. Actually, I need the variable of word. So let's write let word. Let's put something like, I will put empty string right now. So because I want to check this condition, but this is actually the variable that player might choose. I might even change this variable to player's word. Yeah, I think that player word is the best name for this variable. The second variable will be player's word length. As you remember, we should use the previous variable and just write .length to find his length property. I also found that I accidentally put semicolon. For JavaScript, it actually means nothing, so you can delete them. I prefer to avoid them in order to have cleaner code. And right now, let's write our first condition. We have a variable of player's word length, and I can check that if this player's word length, that is number, I can also hover over this variable. I might see a data type of number. I'm sure that this is a number, and I might check that if it's more than 0, and then continue that. It means that you have a word. I wrote this condition. If our length is more than 0, I write a message. Right now I will write this with console log. I also think that we might change this you have a word to you made a word. Let's talk about our else statement. Our else statement means that the word's length is 0. So it means that we didn't guess anything, like in our example right here. I will write else, and I will write a console log with the same message as here. I also might add an emoji if I want. If you want to add some emojis, you can find them, for example, on emojipedia.org. You might use other websites as well. I just use this because I know that I might find some emoji, click it, and then just copy this emoji and paste it right here. Right now I will use live server extension to run this project in the browser. I go to my HTML file and then press go live button. And here, if I inspect the page, I will choose a console. Right here we have 2 messages, the default message that live reload enabled and one fail. You actually can refresh the page, and right now you will see only the message from our console. As you see, my length is empty, so I guessed an empty word, and right now we have that I know you didn't guess anything with smiley face, so it works properly. I also can check other conditions. For example, I have carrot. Save the file, so you made a word. It works. When we have checked the condition, we might go to the next one, and our next one is to check that if the length is less than 7. Right now it's really important where I will write this condition, because if I will write this separately, it will mean that these actions are independent. I want to show you what happens if I will write it separately. The condition by itself is very similar to our previous one, but right now I'm using less symbol and I'm using less than 7. I might write the same message as here. Let's save the file. Right now we see 2 messages. You have a word, and then you have a word between 1 to 6 characters. That is true because I have carrot as a word and the length of this word is 6. But let's delete this word and let's use an empty word again. If I save the file, you see that I have else statement from the first condition, so I know you didn't guess anything, but then our second condition works and we have a message that you made a word between 1 to 6 characters. But right now we know that this is not the desired result. The reason why we have this message is because both these lines are independent. In the first condition, it checks that your word length is more than 0, and if it's not, it uses else statement and write it. We have this message. But then it goes here, checks the second condition that if player's word length is less than 7, 0 is also less than 7. And this is the reason why we have this console. In order to check these both conditions, we should check it inside of the first if statement. I will just cut it with Ctrl X and paste it right here. If I save the file, right now we see only one message, because right here we check that if player's word length is more than 0, we go to the else statement and we absolutely ignore all the content that's inside of this if statement. We will not even check the second condition right here. This is the most important and the most complicated thing of this code challenge. So right now I will add some spaces in order to increase the readability. Now we clearly see that these statements are separated. Let's continue with our else statement for the second condition. And our else statement means that our word's length is more than 7 and Akinator gives up because the word is too complicated for him. I should find my second if statement, my second condition, and right here I can write else. And I will write the same message in the console as I have right here. And again, if I want to use emojis, I will go to this website and find this pensive face or just sad face. Copy and paste it right here. I also want to use Alt-Z to wrap our file. So if I press this button, you see that our lines are wrapped. Right now my 10th line is separated into 2 ones. Again, let's check this condition. So if our word is more than 0 and if our word is else of this, which means 7 or more, so let's put something like, for example, some fancy word, and if I save the file, we have that you made a word. This is the message from the first condition, because the length of this word is more than 0, because the JavaScript checks all these 3 words as 1. And we see that, this length is more than 0. We have this first message, and then we have the second condition where we check that if this length is less than 7, but we see that this length is more than 7. So we have this else console log where Akinator gives up. Our next one is if the word isn't carrot. It also should be after these conditions. We should also check that this word's length is between the possible range, because we might change this word to something else, but if we change this word to something like some fancy word, it will not be a proper condition because it's not satisfy our previous condition of the range 1 to 6 characters. I will write inside of our second if statement our new one. Right now I will check player's word directly. I will use not equal to operator to compare that this word is not carrot. And inside of the quotes I will write carrot. So if our word is not carrot, I will write the same message as right here. After this condition, let's also find an emoji. So I see this thinking face right here, and I will copy this and paste into our code. Before I check it, I also want to write else statement. Else statement means that player's word is equal to carrot. So, and in this case, I will write these 2 console logs. As I want to write 2 different console logs, I might use Alt, Shift and down arrow to copy this line down. And right here I might change this message to I know I'm smart. Right now I have if and else statement and I can check them by changing our input. Let's write the word carrot. And if I save the file, right now we see several messages right here. The first that you made a word, which is the first condition of if statement. Then we go deeper and we have you made a word between 1 to 6 characters. And then we have else statement because our word is carrot. This else statement provides 2 console logs and we see both of them. your word is carrot, and I know I'm smart. Let's also change it to a carrot with capital letter, because as you remember, capital letters and non-capital letters are different for JavaScript. Actually, our word carrot with capital letter is a different word, and this is the reason why we have the change in the final message to your word isn't carrot, why you don't eat enough vegetables. It works properly, and right now we can go further and write our next if statement. The next condition is interesting because we should separate our list into two possible words. Let's add some enters. We will check our word's length again, and if it's less or equal to 4, this symbol means less or equal to 4, and as you remember, only one of the conditions should be satisfied to give the true for the entire condition. It means that if our word is less than 4, for example 3, 2 or 1 character, it will be satisfied, and if our word's length equal to 4, it will also be satisfied. Let's write this message. So right now I have a message that you have between 1 to 4 characters word, and otherwise I'll write that you have a word between 5 to 6 characters. Let's also check it. I might delete 2 letters, and right now we have car word that's length is 4. If I save the file, we see that you have a word between 1 to 4 characters. That is our first condition. Let's also check 3 letters. It also should work fine. If I change letters to 1, it also works. And let's check some 5 characters word, for example car. So right now we have you have a word between 5 to 6 characters, so it all works properly. And finally, let's write our last 4 different cases. Right here we should be very careful where we'll write these statements. As you see, this arrow shows that if the word is Bob, we will write this message, but let's also check that Bob contains 3 letters. It satisfied our previous condition. It's really important, so we should find the condition of 1 to 4. It's right here, and here we can write our new statement where if the word is Bob. Right now I will use 3 equal operator to say is equal to Bob, and I will write a word with a capital letter. It means that if our input will be with a lowercase letter, this condition will not be satisfied. I wrote our first condition, and let's write else condition for this statement. So else, as we see, I tried my best, but it's too difficult. Let's write the same. Let's also check that it works properly. I will change our word to Bob and save the file, and right now we see that I knew that you make your name, so it was very easy, which works fine. So if I will change first letter to non-capital letter, we will see else statement that this word is too difficult because these 2 strings are different. Right now we can continue with our last 2 statements. Let's find the condition where our word's length is from 5 to 6. I see this message right here. It means that I should write our if statement here. If our word is equal to paper, which also contains 5 characters, so it satisfied our previous condition. In this case, I will write all with the lowercase letters. Let's write the same message. And let's also write an else statement for this condition. Else statement is the same as in our previous condition, but it doesn't mean that we should have only one else statement. We might just copy and paste this message and write it right here. It might be quite tricky once why we don't have 2 separate else statements on the scheme. And I didn't do that in order to give you this tricky moment where you should think like how to make both these conditions possible. And I think that at this point, the easiest way to actually separate them both, but they're actually the same. The content of both this else statement the same. So on the scheme, it might be simplified to just one else statement. Let's try our final code. I will add a little bit enters. Right now we have all lines separate and we might read them clearly. And I might change our input to, let's try paper. If I save the file, we see the change in 2 lines. Our first line says that our word is between 5 to 6 characters, what is true for the word paper. The second line says that your word is paper. If I change this to capital letter, we see that our word's length is from 5 to 6, but our word is too difficult. I also might check, for example, 6 characters, papers. It works the same, and if I add 1 more character, we will absolutely have another message because our second condition is not satisfied. Our word is equal to 7. It's not less than 7. We have absolutely another else statement. I hope that this challenge wasn't too difficult or too easy for you, but give me the note in the comments. Learn logical operators in JavaScript. There are 3 main logical operators that you will use incredibly often. There are not, and, or logical operators, and one of them you remember from the previous video. I start from a quick reminder. I will write a simple if statement with literal true value inside of the brackets. And I also write an else statement. I have written a simple if statement where if the statement is true, we have a message in the console that this statement is true, and if the statement is false, we have a message that this statement is false. Let's look at the console. To show my console in the browser, I will use a simple HTML file that you might copy and paste, and also live server extension. I will click Go Live button. I will see a new gray window where I can right click, choose Inspect, and choose Console tab. Here we will see 2 messages. This statement is true and live reload enabled. I can refresh the page by clicking this refresh button. Right now we see only 1 message in our console. But what happens if I put an exclamation mark that calls logical not operator? I will save the file, and right now we see that this statement is false. The same if I will change this true value to false. I save the file and we see that this statement is true. Logical not operator works as a toggler or inverter. It changes the value to the opposite one. But let's continue with logical and operator. I'll write logical and operator as a title, and as you see, this symbol or this sign means and. I will use the same example, but I will write true and true, and save the file, and right now we see that this statement is true. For example, I have 2 statements. First statement is true and the second statement is true. And as it contains in one parenthesis, in one if statement, this expression will give the true. The same if I will write false and false. I save the file and you see that this statement is false because our first check is false and our second check is false. The most interesting part of this operator when we have 2 different statements, when we have 2 different results in the checks. For example, I have false and true. In this case, we still have false value as the result. To better understand how it works, let's write an example. Let's assume that we have a street that contains houses. So I will write a first variable as let house amount equal to, let's assume 10. The second variable will be villagers, or I will write let people amount. And let's assume that we have 100 people. Let's also agree that in one house can live 10 people. If I have one house, it means that there are living 10 people. And our program should give the message if we have enough houses or not. Let's check if there are enough houses on the street. At first, I will write if statements that we already know. I will write a statement where if house amount, that is 10 in our case, multiplied by 10, this is the amount of people that might live in one house, is greater than people amount, that is 100 right now. I will write a message that we have enough houses. If I save the file, we will not see any changes in our console, because if we calculate 10 multiplied by 10 equals 100, and 100 is not more than 100. It means that I should write more or equal to, because if we have 10 houses where can live 10 people, and we have only 100 people, there are enough houses. If I save the file, right now we see this message. Let's also write else statement. I will write a new message that declares that we need more houses. Right now, let's change this number to our actual variable, house amount, and the second variable to people amount. Right now, I might save the file and we still see our first message. If I increase the amount of people, we will see that we need more houses, because right now we have only place for 100 people, but we have 1000 people. If it's clear, let's add one more building, for example, groceries or food stores. Grocery amount equals to, for example, 100. And let's also agree that one grocery might serve 5 people. I also found that I put semicolon. I might delete them. Nothing will be changed. And right now we'll have a little bit another question. Let's check if there are enough buildings on the street. I will change this question houses to buildings. As you see, grocery is a building and house is a building. Let's write a new solution. But at this point, we'll use logical AND operators. What I should actually write, let's think when we have enough buildings. We have enough buildings if we have enough houses and enough groceries. Inside of our if statement, I should write if house amount multiplied by 10 is more or equal to people amount, and if grocery stores multiplied by 5 is also more or equal to people amount, then I should log the message in our console that we have enough buildings. I increased our Visual Studio Code that right now you might see exactly how this huge line looks like. And right here I can write also an else statement that is absolutely the same that we had in our previous example. Now our message will be logged in the console only if we have enough houses and enough grocery amounts. Because as you remember from this example, if we have true and true, we have console log with this statement is true. If one of these conditions is false, then JavaScript shows this statement is false. Let's also check our file and look at the console. And right now we see that we need more houses because we have only one grocery store. But if we change this number to 1000 grocery stores, we see that we have enough buildings. Right now let's talk about logical OR operator. I will delete our previous example, change this title to logical OR operator that looks like this symbol. And let's change this example to true or true. If I save the file, we'll see that this statement is true. It works absolutely identical as AND operator when we have two true statements. Let's also change true to false. And the second one also to false. If I save the file, we see that this statement is false. False or false gives the false value at the result. The only changes that they have is when we have different statements. If I have true or false, this statement is true. This is the main difference between AND and OR logical operators. Let's look at another example to better understand how it works. Let's assume that we have a speed limit and 3 cars, and we want to find have any driver exceeded the speed limit. I wrote 4 different variables. Our first variable is speed limit, that is 90 km per hour or 55 miles per hour. And then I will work with kilometers per hour, and we have a bus with a speed of 50 km per hour, truck that goes 70 km per hour, and sports car that goes 90 km per hour. Let's think how to find if there are any exceeds. If our bus driver exceeds the speed limit, or if the track exceeds the limit, or if the sports car exceeds the limit, we have speeders. And as you have heard, I used or in my speech, so I can use or in our if statements to check this condition. If bus greater than speed limit, or if track is greater than speed limit, or if sports car is greater than speed limit, we will write a message that there are some speeders. I will write an else statement with the message that no speeders have been detected. Right now we see the message in our console that no speeders have been detected because no one from our list of drivers exceeds the speed limit. But if I change the sports car speed to 100, we will see another message that there are speeders. Let's also calculate the result manually. Bus speed is greater than speed limit. We see that bus speed is less than speed limit, so instead of the statement, we'll have false. I might write false at the result right here, then or, and I need to look at the another statement separately. Track greater than speed limit. We see that track speed is less than speed limit, so this statement is also equals to false. Right now we have the last condition that we should check. Sports car is greater than speed limit, and we see that right now sports car's speed is 100 km per hour, which is greater than our speed limit. So instead of this statement, we will have true. As I said, if we have different values, the OR operator will give the true value as the result. To easier calculate the result, I will give you one clue. If you are using OR operator and if any statement is true, the result is true. No matter how much false statements we'll have, we'll see that there are speeders while there are at least one true value. For AND operator, if we have any false statement, the result is false. So the entire expression equals to false. No matter how much true I have, this statement is false because I have one false value. Mastering JavaScript if statements and logical operators with Buckshot Roulette game project. We will write a game logic that is similar to Buckshot Roulette. During this project, we will go over a lot of different topics and details. Let's get started. Let's start from the variables. In this game, we will have two characters, main player and dealer. And they both have limited amount of lives. Our first variable will be player's life amount. I will put right now the number equals to 2 because this is quite small number and it will be convenient to work with that, but we might change this number a little bit later. I will do the same stuff for the dealer. Right now we need to create a bullet. Our bullet might contain two values. First, if the bullet is real, and the second, if the bullet is blank. I will represent them with zeros and ones. Let's assume that if bullet is a blank, this is a 0, and if bullet is a real, it is a 1. You might also ask why we don't use Boolean values like true and false in this situation. And this is because in the future, we don't want to assign the bullet manually to the number of 0 or 1. We want to make a random function that will assign these values for us. When we make a choice where to shoot, we will not know if there is a bullet or not. Our last variable will be player's choice. At this point, I might manually put true or false value in this case. So let's agree that true means choose the dealer, so shoot the dealer, and false means shoot yourself. Let's create a game loop. When we get the input, we should actually analyze and give some result. Let's create the first if statement. For example, it might be the if statement where player choice is true, which means that shoot the dealer, our target is a dealer, and our bullet is 1, which means that bullet is a real. So I write that if player choice equal to true and our bullet equal to 1, then I will put a curly braces and it means that I can write something. For example, console.log this value. To see the changes in our console, I will use a simple HTML file that you might copy and paste, and I will use the live server extension. If you don't know how to connect JavaScript to the browser, I have a video on this topic. I will press a Go Live button, and then in the new window we see a blank page. I should right-click, choose Inspect, then choose Console, and we will see our message with a line that Live Reload enabled and with a failure of 404. In this case, I should just refresh the page. Right now we see only our message, so it means that our if statement works correctly, because as we remember, player choice is true and bullet is 1. Also, one detail that you might remember is actually we don't need to provide the literal value of true. So I don't need to write player choice equal to true. I might just delete it. And while this variable is in our if statement, by default, it means that if this variable equal to true and then and bullet equal to 1. This thing and the previous one are the same, and that's the reason why I might delete it. To actually write a full game loop, we need to take into account every single outcome. At this point, we have considered only our first outcome, where the player choice equal to true and boolean equal to true. And we said that in this case, the dealer's HP should be decremented. Let's also think which are the possible variables we have. For example, we still have the choice to shoot the dealer, but our bullet is a blank. In this case, I think that we might decrease the amount of lives of the player. Because as you remember the original game, if the bullet is a blank, we just change the term, and right now dealer can shoot the player. To just simplify the logic, let's say that player's HP should be decremented. I also represented the last possible outcomes. They are when player chooses himself and the bullet is real. The outcome is very obvious that the player's HP should be decremented. But when the player chooses himself and the bullet is a blank, we might get some interesting result and, for example, increase the amount of life of the player. In this case, the game will be a little bit more interesting than we just copy and paste the first outcome when dealer's HP might be decremented. Let's write all these if statements in our project. Let's finish our first if statement. As I said earlier, we should decrease the amount of life of the dealer. Let's write that dealer lives equal to dealer lives minus 1. If we put numbers, so right now dealer's life is 2, our dealer lives variable equal to 2 minus 1, which gives 1 as a result. And if we have number 1, 1 minus 1 will give the amount of lives to 0. With every iteration, we will decrement the amount of lives of the dealer. Let's also print another message. For example, you hit the dealer and dealer loses a life. And to make it more interesting, I would recommend you to use emojis that you might just copy and paste from the internet. I personally like to use this website because I can easily copy and paste every single emoji that I want. The next condition that we might write is when the player choice is true, he's still shooting to the dealer, but the bullet is a blank. To cover every possible outcome, I will use else if blocks. Let me explain. If you have only two possible outcomes, you might write if and then else. And it means that if the first statement isn't satisfied, the program will do else statement. So when we have this block, we might be 100% sure that one of these blocks will be chosen. But in our case, we have 4 different possible outcomes because we are working with 2 variables. And in this case, else statement means all the remaining 3 blocks. If our if statement isn't satisfied, it still means that I have 3 possible outcomes that might be in our else statement, and I should check every single outcome to be sure that only one is chosen. In this case, I might write an if statement after our else statement right here. The syntax is very simple. I write else, then blank, if, blank, parenthesis, and inside of the parenthesis, I might write the same usual if statement as right here. So I will write that player choice equal to true. At this point, I will remain with a short version of player choice equal to true and bullet equal to 0. In this case, if our first statement isn't chosen or isn't satisfied, our else statement means that we still have 3 different possible outcomes, and then I just have a new if statement that specifically select only one outcome from the 3 possible. It means that at this stage, if this condition is satisfied, our second outcome is chosen. And as you see, we should decrease the amount of lives of the player. Player lives equal to player lives minus 1. And then let's console.log some message. For example, I wrote that, oops, you shoot yourself and you lose a life. I see that I don't see the entire screen, so I will press Alt-Z to wrap our code. And right now you might see that our 15th line is split into 2 lines. And here I might continue. Don't be misled by this double line. If I expand our page, we see that our 15th line is still 1, and this is the same as usual. But at this point, I just don't have enough space for this 15th line, and this is the reason why if I wrap the page, it will be divided by 2 lines. I delete this figure brackets because we should continue from the same yellow bracket that we have in the first column. Here I will continue with the same else if block. Our else statement means that right now, if both these conditions aren't satisfied, it means that we still have 2 remaining ones, and I still should clarify which condition I want to choose. For that, I will write a new if statement. And at this point, I will write if player choice equal to false and if bullet is real. I might write in a full version like player choice equal to false, or I might delete this equal to false and just put an exclamation mark before the player choice, which means inversion or logical not operator. Then I put and write that bullet equal to 1. In this case, player lives also should be decremented. And let's write a new message. For example, I wrote that empty shot, dealer counterattacks, and you lose a life. At the end of this block, I again start from the else statement. At this point, it means if all previous checks aren't satisfied, in this case, the remaining one is only 1. And it means that I shouldn't even clarify any additional details, and I might be sure that this else block means that player choice equal to false and bullet equal to false. In this case, as you see, we should heal our player. And let's also write a new message. I wrote that lucky break, you gain an extra life. Let's also check if it works. I will change the bullet to 0, save the file, and yeah, we see another message. I also might change player choice to false. And right now we have lucky break because bullet is 0 and player choice is false. And let's return back bullet to 1. And right now we have our third condition that dealer counterattacks and you lose a life. Right now we are sure that all these checks, all our game logic loop is working, and we might just copy and paste it to create a second cycle. And again, if you see this structure that starts from the if statement and finishes with else statement, no matter how much branches we have inside of it, our program will definitely choose one of the options. It means that it will react the user's input and it will change the current condition of the game. By other words, it will interact with a player. Right now we have 2 cycles, but our player can't actually communicate with the game. So let's change this variable into confirm function. If you don't know how confirm function works, you might watch my first project of the game development where I have used this function and explained all the details that you should know. Inside of the confirm function, I put a message where I ask a player, where do you want to shoot? And I also gave some instructions. OK button means shoot the dealer and console means shoot yourself. If I save the file, we see this pop-up message and I might choose, for example, shoot the dealer. And we have 2 the same messages that you hit the dealer and dealer loses a life, because when I pressed the OK button, I assigned the true value for the player choice and we see that our bullet is 1. That's very logical why we had this condition, our first branch. But we shouldn't see both conditions or the entire game after our first choice. We should actually reassign this variable after every single cycle. I might just copy this line without let keyword and put it after our first cycle. I also want to write some comments to differentiate the cycles. This is our first cycle, and this is our second cycle. Let's test it. Right now I can press cancel. It means that empty shot, dealer counterattacks, and you lose a life. I actually found that both these branches do the same thing, that they decrement the amount of lives of the player, but the messages are messed up. I should actually change these messages because right now we have a bullet and I chose cancel, so I said false. And this is our third branch, but it means that if the bullet is 1, it means that bullet is real. So we actually shoot ourselves. This is not a dealer counterattack. So I will swap both these messages. If I save the file, I again see this pop-up message, and if I choose cancel, we have that oops, you shoot yourself, which is true because our bullet is 1, so our bullet is real. And by clicking cancel, I assign a false value to our player choice, and we should see this message that we shot ourselves. Now I might choose OK, and we see the message that you hit the dealer, so dealer loses a life. I changed these messages in our first cycle, but it also means that I should change them in our second cycle as well. I will just delete our second cycle, copy and paste our first cycle. Let's also check. If I choose 2 times cancel, I should see the same message in the console. Right now we might press different buttons, but we don't have any purpose in our game. So we should establish a specific goal. Let's delete our second cycle to better understand what happens. And after our first cycle, let's actually write a winning check. I again wrote all the possible outcomes that might be in our game, and let's start from the end. If player lives more than 0 and dealer lives more than 0, it means that we should continue the game. It means that both player and the dealer are alive. And we also have impossible action for our game when the player lives equal to 0 and the dealer lives equal to 0. So we should prevent this outcome. And there are actually only one condition for player wins and one condition for dealer wins. If the player lives more than 0 and dealer lives equal to 0, it means that player is alive and he is the winner. And if dealer lives is more than 0 but player lives is equal to 0, it means that the player is dead and the dealer is a winner. Let's write both these conditions after our first cycle. I will start from the player win. If player lives more than 0 and dealer lives equal to 0, so it means that player wins and we should write this message. I wrote that congratulations, you killed the dealer. And let's also write a second if statement. So I will write it separately, and let's check that if player lives equal to 0 and dealer lives is more than 0, so it means that we are dead. I wrote a message that game over, you died, and dealer wins. To test our winning condition, we should decrease the amount of lives of the player and of the dealer, because we have only one cycle, and after each cycle we might decrease only one life. So I changed the amount of lives of the player and the dealer, and right now if I press OK, we see that you hit a dealer and congratulations, you killed the dealer. And if I choose cancel, we see that you shoot yourself and game over, you died. If we want to create a second cycle, we actually need to copy and paste all the code that we have, because we should check the winning condition after every single cycle. I will copy and paste it. And I might return back the amount of lives and check our game. I will press OK, and we see that you hit the dealer and then you again hit the dealer because we forgot to reassign a player choice. Again, I should copy this line, paste it before the second cycle, and right now if I save the file and choose OK, we can make a new choice. I will press OK again, and we see our winning condition. Let's try to add more cycles. I will just copy the second cycle, paste it, and rename the counter of the cycle. Before I continue to copy and paste additional cycles, I want to show you one problem that we have. I refreshed our game, I choose OK, so you hit the dealer loses a life, and right now he has 1 life. I can press OK again, and we see that congratulations, you killed the dealer, but we have a new pop-up message, and I should choose something, for example cancel, and we have the congratulations message again. Why it happens? If you look at our scheme, you might see that we want to continue the game only if players' lives more than 0 and dealers' lives more than 0. We don't have this check. So when we have our winning check, we're checking for these 2 outcomes. And then they don't prevent the last outcome that we should finish the game. The easiest solution is to add this check before every single cycle. Let's go to the first cycle and write if player amount of lives is more than 0 and dealer amount of lives is more than 0. In this case, we want to continue the game. But what it means? It means that we want to continue our checks and reactions on the inputs of the player. I should just take all this logic that reacts on the input. I can cut it with Ctrl X and put it inside of our new if statement with Ctrl V. And we see that this block is inside of our if statement check, and it means that we will react on the input of the player only if both player and the dealer have amount of lives more than 0. Right now, again, we should delete all our previous cycles and replace them with this new one. I will delete this game pattern from the second cycle and from the third one. Right now, I might just copy and paste new cycles instead of the old ones. Let's save the file and check if it works. I will do the same stuff. I will click OK and again OK, and we see that congratulations, you killed the dealer, but we again have this message. At this point, if I press any button, I will anyway see the congratulations message twice. If we look at our code, the first thing that we want to ask the player about the choice also only if player's lives and the dealer's lives is more than 0. I will go to our first cycle. Here I'm sure that the player lives and dealer lives is more than 0, so I might remake this confirm message. I should go to the second one and put this message inside of our if statement. I'll do this by Alt and down arrow. Right now we have our message inside of our if statement. I create some additional spaces that we might better distinguish these blocks, and I should do the same process with the first cycle. There's also one problem. I have several winning checks that we needed because at first we had the logic where after every cycle we should check the winning condition. But right now our game reacts on the input, and our input happens only if this if statement with player lives and dealer lives is satisfied. So it means that I don't need to have several winning conditions anymore. So I might delete our first winning condition after our first cycle. I will do the same thing after our second cycle. So it might be a little bit difficult to understand why we actually don't need to have this winning checks after each cycle. And this is all because right now we check that if player's lives is more than 0 and dealer lives is more than 0, we continue the game. But if one of them is equal to 0, it means that all the remaining loops, all the remaining cycles will be skipped, and we can immediately go to our winning checks. Let's also test our changes. If I save the file, I have the message where I can choose, for example, OK, Then I will press OK again, and we see that right now we have a winning message and we don't have any additional pop-ups. Our first cycle was skipped successfully. Let's also try with the defeat block. If I press cancel and cancel again, we see that game over, you died. Master JavaScript random and concatenation with Buckshot Roulette game project. We will need the Buckshot Roulette JavaScript file from the previous video and also an HTML file to connect to the browser. Be careful if you have several files in this field like script.source. You should choose your JavaScript file that you will continue to develop right now. If you have several files, you might write GS, and then the Visual Studio Code will give you the choice between all the files that you have. And I will choose Buckshot Roulette and save the file. You will probably have these names with gray font or gray color. I have a green color and this U letter because I'm connected to GitHub. You don't need to do it. If you have the gray color, it's absolutely fine. In the previous part, we wrote a game loop. We also created several cycles and we have a winning check. But if I run my code using live server extension, you will see a pop-up message because we are using confirm functions. And at first you should just skip this pop-up. You can just press OK or cancel. Then you might inspect the page and choose the console and you will start to see all the changes in the console. The main problem that we have right now is that we always know the result of the bullet. So we always know that our bullet is real, or I might change it to a blank one. No matter what choices I do, I will always have the same message in the console because our bullet doesn't change with the cycles. To give a random parameter to our bullet after every cycle, we have a special function in JavaScript that calls math.random. I wrote an entire expression that will generate a random bullet from 0 to 1. But let's break it down how it works. At first, you should know that math.random function generate a random number within the range from 0 to 1. 0 is inclusive and 1 is exclusive. So it means that our actual range is from 0 to 0.99999. We always should consider that this last number is exclusive. If I modify this function by multiplication, how to calculate a new range? I should take the AND numbers, the minimum and the maximum number of the random function. We know that this is 0 and 1. And then I should calculate the range based on these numbers. So I should take the lowest number, multiply it by 2, then take the highest number and also multiply it by 2. And I have a new range from 0 to 2. And we also should consider that the last number is exclusive. So it means that our actual range from 0 to 1.9999. One more example. At this point, I will multiply it by 2 and also sum 1. The principle is the same. I should take these edge numbers, that is 0 and 1, and just calculate our expression. If this expression equal to 0, I will multiply it by 2 and sum 1. And if our expression is 1, I will also multiply it by 2 and sum 1. Here I multiplied both numbers by 2, and right here I also sum 1, and we have a new range from 1 to 3 and the actual range from 1 to 2.999. I'm also using a math.floor function. What it does, I copied and paste the math.random multiplied by 2 that we have calculated in our previous example. So we know that this range is from 0 to 1.999. If I'm using this function inside of the math.floor, what it does, the math.floor works as a rounder. So it rounds our number to the closest integer, to the closest whole number, without decimal part. And as the name floor means, it will round the number downside. So it will essentially just take all the decimal part and delete it. We will eventually have the range from 0 to 1. You see that if we are using math random multiplied by 2, we have this range from 0 to 1.999. And if I'm using math.floor to cover this range, I will actually have the range from 0 to 1 because math.floor just round the number to the closest downside number. So it will just take the decimal part and delete it. One also important detail is that math.random gives a range of numbers that are actually rational numbers. As you see on this diagram, rational numbers means numbers with decimal part, numbers with a fraction. So we might have actually any number within this range. So it might be 0.1, 0.2, or 9.8. So we have really a lot of numbers within this range. But if we're using math.floor, it changes the behavior of our range to integers. As you see on this diagram, integers are actually whole numbers, numbers without decimal part. So from the range of 0 to 1, we have only 2 whole numbers, that is actually 0 and 1. And this is the reason why this function will always give the number of 0 or 1, only 2 possible options. And this is exactly what we need. If you remember, we used bullet as 0 or 1. I wrote a function that chooses randomly 0 or 1, so only 2 possible options. If I save the file, I might check it. I have a choice, where do you want to shoot? And I might choose, for example, myself and press cancel. And we have that, oops, you shoot yourself. I think, okay, let's try again. And again, oops, you shoot yourself and game over. And we might try it again. And at this point, let's shoot dealer. And we have, empty shot, dealer counterattacks, and we might try again. And you see that this random is a little bit strange. And this is because after every cycle, we should always assign the value. So what it actually does at this point, it chooses the number of 0 or 1. So it makes this choice only once. Let's refresh the page and look at it again. Our bullet right now chooses a number of 0 or 1. I might choose OK, and I see that, oops, empty shot. It means that this function chose a number of 0. Okay, let's go to our second cycle. And what the problem we have right here? We have this player choice variable that asks us about our choice, but we don't have a new bullet right here. I know that this bullet is 0 right now, and I might use cancel to heal up myself, because I know that if this bullet is fake, and if I shoot myself, in our logic, we just heal the player. Let's go to the first cycle, and here again, we update the player choice, but we don't update our bullet. And I know that this bullet equal to 0. I might again choose cancel, and I will again heal myself. To actually make it fully random, we should always update it after every single cycle. I will delete it, and the easiest way how to understand when you should update this variable is actually, we just might copy this part without the keyword let and put before the player choice. And that's it. We always might put it before the player choice. In this case, it will at first update the bullet, and then it will give us the choice to shoot. And we will not know, is it bullet 1 or 0? I save the file and try to play it again. Let's shoot the dealer. We have an empty shot. Okay, I might try to shoot it again. And you see that you hit the dealer and dealer loses a life. So we have 2 different options, but I used the same choice. And let's try it again. And you see that you hit the dealer. Congratulations, you killed the dealer. By this combination, we see that our random works. We have a working game loop, but as you see at this stage, I should always remember the amount of HP for the player and for the dealer. We don't have any message that says how much HP we have. I expanded the window, and you might think that it's easy to change. You might just add the numbers right here. And okay, I might write something like HP equals to 2, then go to the next cycle and write HP equal to 1. Go to the next cycle, write HP equal to 0. But if we think about that, we know the amount of HP only in our first cycle. We know that player has 2 HP and dealer has 2 HP. And if we have this branch, though dealer will have 1 HP because we decrease the HP of the dealer. And in the second branch, will also have 1 HP, but it will refers to the player. Here we'll also have 1 HP, and here we'll have 3 HP. But it doesn't work for our second cycle because I don't know which of the 4 possible branches have been chosen before the second cycle. And as you see, we have like 4 different branches with 3 different outputs. So it means that inside of every single branch, I should add at least 3 new if statements to check every possible condition. And it will be much more complex in the first cycle. How to fix it? Even though that we don't know the amount of HP for each cycle, but we have a variable for player and for the dealer that contains the amount of HP. It would be very nice if we might just console these numbers, and we might do it. For example, you might write a new console. So I will delete this HP equal to 1 and write a new console. And here, instead of the string, so instead of the quotes, I will just write dealer lives. If I save the file and press OK, now you see I got the first branch and we have 2 different console logs, and we see this number that refers to the amount of HP that dealer has. But it's also a little bit difficult. You might continue adding this additional console logs, but there is a way how to write them into one console log. So I might delete my console log that refers to dealer lives. I added a new sentence, and as you see, I have a previous sentence and a new one where I have dealer lives column, and here I have plus, and I'm using our variable. Let's also break it down how it works. In JavaScript, this plus operator might be recognized as addition or as concatenation, and how JavaScript choose what to do is actually based on the data type that we provide to this operator. So if we have 2 numbers, JavaScript will just add them together as we have in the math. So 1 plus 1 equals 2, 10 plus 5 equals 15. But if our data types are strings, we might recognize them by these quotes. I might recognize that this is a string. If we are providing 2 strings for plus operator, it will just join them together. And this operating calls concatenation. 1 plus 1 will give 11 as a result of concatenation of 2 strings. The same if I have 2 words, so I might have good and morning, and the result will be good morning as a one joined string. And one also interesting example, if I have different parameters, like one parameter is a number because it's without quotes, and one number is a string. So in this case, JavaScript will automatically change the number to the string and will join them together as a common concatenation. And this is actually what we have in our code right now. All this huge sentence is a first string parameter, then I'm using plus operator, and I'm using dealer lives. And if we hover over it, we see that this is a number. The result will be our previous message that you hit the dealer, and right now we see that dealer lives equal to 1. So this is exactly what we have. Right now I might use the same pattern for remaining console logs. I will change this parameter in our second branch. I will delete this HP and add player lives plus player lives. Our third branch does absolutely the same thing, so I will just copy and paste it. Even though that our third branch increases the amount of HP, I might also copy and paste it, because right now this variable will be dynamically updated depending on our previous code line that says that, okay, right now our player lives should be incremented by 1 or decremented by 1. We'll see the right result. I should do the same thing for our second and third cycle, so I will just copy these if statements and paste them right here. Let's save the file and see how it works. I have the same message that where do you want to shoot. I might press OK and we see that you hit the dealer and we see the amount of lives of the dealer. I might press cancel and we see that lucky break, player lives equal to 3, and I will press OK again and you see that you hit the dealer and dealer lives equal to 0, and then we have the congratulations message. And let's do one more thing. Right now all our cycles are working and you might just copy and paste these cycles to increase the amount of them. I saved the file. Right now I have 3 cycles and I might try to use only cancel button. What will happen? So we see that lucky break, let's try again, we loses a life, let's try again, and you see that we loses a life again, but our player lives is still 1, but we don't have any message anymore. And this is because we don't have any cycles anymore. And no matter how much cycles you will add, the player will always have a chance to just run out all of them. And in this case, we should write any default condition. In the end of our file, it might be just a simple message that all the cycles have passed and restart the page if you want to play again. So something that the player will know what happens. I will use Alt-Z to wrap our code and see all the message that I wrote. Right now I wrote that all cycles are completed. Please refresh the page to start a new session. It might be a great default condition, but the problem that we have is that this default condition will console a new message always after the winning check. But what we want to do, we want to define if the player have lives and if the dealer have lives. It means that we don't have any winner, and in this case we want to show this message. So our if statement will be the same as we have in our cycles. So if player lives is more than 0 and dealer lives is more than 0, it means that we don't have any winners. I will write the same thing. And right now I might cat this message by Ctrl X and put it inside of our default condition. Let's also test it. We see a pop-up message and I will try to do it again. I will try to press cancel, then cancel again. And I know that, okay, now I have 2 lives. If I press cancel again, we see that player lives is equal to 3. And we have a message that all cycles are completed. Whew, it was a huge work, a huge project that is working right now. And you might give to your friends, so they might play your game. Learn while loops in JavaScript. We will begin with a basic example. I have written a while loop and right now in the console we might see numbers from 1 to 9. Now let's reproduce that output by hand. I will comment out our previous while loop. Right now we have a clear console. I start from the same variable number, then I console.log this value and increase it by 1. Then I will just copy and paste last 2 lines. Right now you see that we have 1 and 2, and I might just continue to copy and paste them until I reach number 9. Now we have the program that does absolutely the same thing as our while loop, but you see how simpler is this code that contains just 5 lines comparing to this code that contains 19 lines. Once you find yourself copying and pasting the same part of the code, you can use while loop to avoid repetitions. I want to demonstrate you one problem you might encounter in the future. If I will save this file, you will see that my console will be bombed with messages, and in this case I will just close the page. So I save the file. We see a lot of messages. Okay, and I closed my page. Then I need to add a keyword break and connect to my browser again. We see that we have only one number, so this condition that we had calls an infinite loop. I have demonstrated this problem because at the first time it might be very scary, and right now you know that you need to close the page or you might close the browser. If your computer doesn't respond, you might turn off the computer. But generally, you can just close the page, it will be enough. Let's break the while loop down and compare it to if statements. I comment out this while loop And now we can see the messages only from the if statement. What does the if statement do? If this condition is true, it goes inside of our curly braces, so this part calls body, and it executes our body. Then it goes to the next section, and this is the reason why if this condition is true, we have the message, and then we have the message about the next section. Now let's compare it to the while loop. While loop has another keyword. Instead of if, we write while. Then it has absolutely the same condition in the parentheses, and this condition also might be true or false. If this condition is true, it goes inside of our body, executes this code, and then check the condition again. And if this condition is still true, it will execute our body again. To better understand the difference between while loop and if statements, let's look at this diagram. If the condition of if statement or while loop is false, they behave in the same way. They just skip the body and go to the next section. I might write 100 right here, and the same I will do with while loop. Right now the condition inside of our if statement equals to false, and the same condition we have inside of our while loop. If I save the file, we'll see just messages about the next section. So while loop block section and if statement block section have been skipped. This is what I mean when I say that they skip the body. If the condition inside of the while loop or if statement is true, the first step is the same. They execute the code inside of the body, but then they behave in a different way. If statement, just go to the next section, but while loop, check the condition again, and if this statement is true, it returns back and start the loop again. And we might exit the body, exit the while loop only if the condition equals to false. In this example, if I change back the score to 0 and save the file, we see that 0 is less than 10, so this condition is true. Then it executes the body where it increases the score by 1 and show it in the console. Then it will go back to check the condition. So right now our score equals to 1. 1 is again less than 10, so this condition is again true. It will go again to execute this code, and at the point when score is equal to 10, this condition will be false and our while loop will be skipped, and we will go to the code section immediately. Here is another example. I will start from the keyword let and write a variable for string. And let's assign an empty string. So this is our variable, and right now let's write a while loop. I start from the keyword while, then I put parentheses, and inside of the parentheses I should write the condition, the same as in if statements. I might write that string.length is less than 5. Then I must put curly braces, and right now I might write some body, but our body must influence the condition, because otherwise we'll have an infinite loop. So first thing that we should change is actually string length. Right now it's equal to 0 because we don't have any characters. Let's add new characters to our string. For example, we might add a letter to our string, and let's also console.log the value. Now, if I save the file, we see that we have a that increases to 5a in a row. So our loop works correctly. We might add if statements inside of our while loop. So let's write something like if string.length is more than 3, we will assign another letter to the string. So now I might save the file and we'll see another messages. And now I might play with that. For example, change the length to 10 and we will see interesting messages in the console. So you might play with that to better understand how while loop works. I will give you a code challenge. Try to solve it by your own. In the code challenge, you will have two variables, word and speed. The initial value of word is equal to an empty string, and the initial value of speed is equal to 0. If our word's length is less than 4, you should add a letter to the word. And if the word's length is more or equal to 4, you should increase the speed by 2. And all this part should be inside of the while loop, and you should exit the while loop if the speed is more than 5. And then you should write the message that all cycles have finished. Pause the video if you want to solve it by your own, but right now let's solve it together. I should start from the two variables, word and speed. So I will write let word equal to an empty string. And also I will write let speed equal to 0. Then I should start a while loop. So I will start from the keyword while. Then I have parentheses, and inside of the parentheses I should write the condition when we should execute our body in the loop. In our case, we see a message that if our speed is more than 5, we should finish the loop. So it means that if our speed is less or equal to 5, we should execute the body of our loop. I wrote that speed is less or equal to 5 and then goes curly braces. And inside of the curly braces, we write our body. So we have two different conditions. If our word length is less than 4, add a letter to a word. Let's write an if statement where the condition is word length is less than 4. And we should add a letter to the word. So let's write word equal word plus a. And then we have the second if statement that if word length is more or equal to 4, increase the speed by 2. I might write a new if statement, and then I might increase the speed by 2 inside of this if statement. But you also might notice that we can simplify it because we have two opposite conditions. Our first condition is word length is less than 4, and our opposite condition is word length is more or equal to 4. So instead of the second if statement, I might write else statement. And here I will have the same body that speed is equal speed plus 2. If it's easier for you to write two different if statements, it's totally fine, and you might solve this code challenge by two different if statements. If you understand why these conditions might be simplified with if-else statement, you might solve it with if-else statement. And before I save the file, let's have a look that inside of our body, we have a statement that influences our condition. In this case, we have speed that might be increased by 2. And if we'll increase it 3 times, we'll have a number of 6 that is more than 5. So this statement will be false and we'll go out of our while loop. When we exit our while loop, we should write a message that all cycles have finished. Let's write this message. And right now, let's save the file and see how it works in the console. I saved the file and I see that I haven't consoled our values, so we don't have any changes. So let's add two console logs. In our first if statement, I will console.log our word, and in our else statement, I will console.log the speed. Right now, if I save the file, we see that our loop works as expected. We add a letter A to the word, then console this word, so we have A. Then we start again. Our word length is still less than 4, so we add a new letter A, and we continue to do it until our word length is equal to 4. And then we'll start to execute the else statement where we increase our speed by 2 and console it. We started from 0, then we sum 2 and our speed variable has the value of 2. We console this, then we do it again, we have number 4, then we do it again, we have number 6. And when our speed is equal to 6, our while condition is equals to false because our speed is not less or equal to 5. And we have the final message that all cycles have finished. The first challenge demonstrates a common way of using loops. Write the program that calculates the sum between all numbers from 1 to 100. The correct answer should be 550. Pause the video to solve this code challenge by your own, but right now let's solve it together. I know that we must use a while loop for this code challenge, so I might start from the keyword while. Then we have a parenthesis, And inside of this parenthesis, we might write any condition that equals to true or false. So the same conditions as in if statements. So let's think when our loop should work. It basically should sum all the numbers until we reach the number of 100. And as our 100 number is including, we actually should finish our while loop if our number is 101. So I might write something like counter is less than 101. While this condition is true, our while loop continued to execute the body. At this point, I will add break keyword immediately to prevent accidentally creating an infinite loop. So I write a word break. Right now, I might save this file, but as you see, we haven't initialized our counter. So let's write let counter equal to 1. We should start our calculation from the number of 1. This is the reason why the initial value of our counter is equal to 1. I should also store the result somewhere. So I might create a new variable total to store our answer. I will write let total equal to 0. Here is the initial value is 0. So in the body, I might write total equals to total plus counter to constantly increase the value of total by counter. In this case, after each iteration, we will add the counter to the total until the counter reaches the number of 101, which means that we should exit the while loop. Right now we change our total variable, but we don't change our counter. So it means that this loop will work infinitely. Let's also change our counter. So right now our counter will be incremented by 1 after every iteration. So let's calculate the results of our body to better understand how it works. At the beginning we have counter that equals to 1 and totals that equals to 0. And then in the body we should add total that equals to 0 plus counter that equals to 1. So our total will be 0 plus 1. And then our counter takes our counter value, that is 1, and then add a constant of 1. And our new counter will be 1 plus 1. For the second iteration, we take these values of total that equals to 1, and we also take the counter that equals to 2, and then we do the same stuff, so we goes by the same formula. We take total that equals to 1 and sum the counter that equals to 2. So our new total equals 1 plus 2. The same with our counter. We take the counter that equals to 2 and constantly add 1. So our new counter is equals 2 plus 1. Then we take these numbers for our third cycle and we do the same stuff again. So we take the total and sum the counter, and this is our new total. And then we take the counter and sum 1, and this is our new counter. And this process goes constantly until the counter reaches the number 101, because at this point this statement will equal to false and our while loop will be finished. Let's delete the keyword break and console.log the result of total to see the result in the console. If I save the file, we see that our value is equal to 5015. That is the right answer. There are actually many ways how to solve this challenge. For example, we might start from the counter of 0, and we might start from the line that increments the counter by 1, and then the line that adds the counter to the total. So this is one of the possible solutions, and we see that this line also gives the 550 to the console. And there are also one interesting solution that might be easier for beginners, but it requires more lines. So basically, we use a variable works for our while loop that stores the value of true or false. And then we assign a value of false if our number equals to 100. In this solution, as you see, we also print every single iteration to the console, and we might see how our numbers are changing during the iterations. Any of these solutions are right, write this one that is simpler for you. The second challenge is love letter. You start from the two variables, letter and counter. Then you have two different phases. One phase is a rising phase and the second one is a falling phase. During the rising phase, you constantly increment the counter by 1. So it starts from 0 and go until the number of 5. So it goes 0, 1, 2, 3, 4, 5. And during each iteration, you should write a word darling to the letter. When the counter reaches the number of 5, it should switch the phase to the falling one. Falling phase starts from the number of 5 and then it decrements the number by 1 every single iteration until it reaches the number of -5. So it will go from 5 to 4, 3, 2, 1, 0, -1 and so on until it reaches the number of -5. And every single iteration at falling phase you should add the word love to the letter. I will give you one clue that you might use several while loops for this challenge. So right now, pause this video if you want to solve this challenge by your own, but right now let's solve it together. I know that I must use the while loop, so I start from the keyword while. Then we have parentheses, and let's think what condition we might write in this parenthesis. So let's assume that our first while loop belongs to the rising phase. It should run the code. It should run the body until our counter reaches the number of 5. So I might write something like counter is less than 5. Actually, you might write something like counter is less or equal to 5, or even counter is less than 6. Here is not specified what you must do when the counter reaches the 5. So we don't know, should we add a new word darling to our letter, or should we immediately change the phase to the falling one, and maybe we need to add a word love. So write this condition that is more logical for you. I think that for me the simplest one will be less than 5. So I use counter in the parentheses, then I will start my body from the keyword break. Now you see that I'm using the counter, so I should initialize the counter. So we see that our counter equals to 0. This we have in our assignment. We also have another variable letter that equals to an empty string. So let's initialize it as well. Now we have two variables and we might think about our body. Until we reach the number of 5, we should add a word darling to our letter. I will write that letter equals to letter plus darling. And we should also increase the counter because we use it in our condition. In order to prevent an infinite loop, we will increment it in our body. Right now I see that I increase our counter and at some point it will reach the number that is higher than 5. I know that we will have an exit condition, and this is the reason why I might delete our keyword break and log the result to the console. If I save the file, right now we see a lot of word darling. I might also add a white space after our darling word, and right now if I save the file, we will see 5 times the word darling separated by space. Our rising phase works correctly. Let's start from our falling phase. So I will start from another while loop. Again, we have the parenthesis. Let's think about the condition that we should write there. So our falling phase goes until our counter reaches the number of -5. So I might write that counter is more than -5. Then I will start the body from the keyword break. And now let's think what we should add in our body. Instead of the word darling, we should write a word love. So let's write the same line as we have right here, but instead of the darling, we'll use the word love. And we also should decrement our counter by 1. Right now, I will delete a keyword break and I will log the result to the console. If I save the file, we see two messages. Our first letter is after the first while loop. Here we have 5 times word darling. And our second letter is our final letter, where we have words darling and words love. Our last challenge for today is a printing machine. We need a message with 5 letters. So ask a user to write a message. So you have a while loop, and while our message length is less than 6, you should constantly ask a user for writing a letter. For this purpose, use a confirm function. If you don't know how confirm function works, I have a video with a JavaScript game project where I explained how it works. As we know, in the confirm function, the user has two choices. He might press OK, and in this case, we'll add a letter to the message. Or he can press a cancel. If the user presses cancel, switch the letter from A to B or from B to A. So the user has only two options. He might write a letter that is chosen right now, or he might switch the letter. So I think that we might start from the variable message. And our message equals to an empty string. And then we might write a keyword while. I recommend to immediately add a keyword break to prevent an infinite loop. In the parentheses, we must write a condition that keeps our loop running. In our case, this is message length is less than 6. And first thing that we can do in our body is actually ask a user to write a letter. So let's start from the confirm function. At first, I might ask a user to write a message. Then I will use this symbol to separate lines. This symbol works as pressing enter on the keyboard. And then we might add some instructions. For example, OK means add the current letter. And cancel means switch the letter. And we also might display the current letter. For that, I might use a concatenation. It uses the same sign as addition, but it calls concatenation when we sum two strings. So when we join them together. And right here, let's join current letter. So we don't have this variable and we must initialize it. In our description, we have that default is A, so I might immediately give the value of A to the current letter. And it should work that it will take this variable, replace with the value, so in our case this is A, and when we have the concatenation between two strings, it will join them together, and we will eventually have a one string. This is our final message that we should have as a result of this function. I will undo our changes by Ctrl+Z. And then I will open the console in the browser using Live Server extension. And right now we see a pop-up message as expected. So I might press OK. And then I will press Alt-Z to wrap the code. And right now we see that our 14th line is separated into 3 lines. But if I expand this window, we see that this is still a one line. And of course we might separate this message into several confirm functions, but it depends on your choice. We should think about our exit condition. We must add the current letter to the message 5 times to finish the loop. Let's write that message equal to message plus current letter. But we also should check that the user presses OK to add the letter to the message. We can add an if statement. And inside of the if statement, I might write that if the user choice equal to true. So then we add a letter to the message. We don't have the user choice variable, so we should initialize it. Our user choice is a confirm function that returns only true or false values. If the user choice equal to true, we add the current letter to the message, and if it equals to false, we should switch the letter. I will write just else letter equal to B. So right now, if user presses OK, it gives the true value as a result, and we will increase the message length. So we have an exit condition, and this is why I can delete the keyword break and test this code in our browser. If I press cancel, we see that current letter have been changed to B, and then if I press cancel again, we'll see absolutely the same message. So I can toggle it back to A, but if I press OK, I should actually press it 5 times to exit the loop. Right now we have finished our loop. Let's add console.log to better see the changes. At the end of the file, I will add just console.log. I will log our variable message. Let's inspect the page. And right here we will choose a console. And now I might save this file. And we see that our current letter is A. If I press OK, it adds a letter A to the message. And if I press cancel, it switches the letter. The console shows number 2 next to the double A because we console our message every cycle. And when I press cancel, this is the action of switching the letter, and it takes 1 cycle. Every time when I press some button, I have a new message in the console, and I might do it until I reach the number of 5. Right here I see that it actually finishes our loop when our message is equal to 6. So let's change this number to 5. And then I will test it again. And right now it works as expected. Let's add this last mechanic of switching the letters from A to B and from B to A. We switch the letter in this else statement. And right here I should check what is the current letter. So if it equal to A, we should assign a new value of B. And if the current letter equals to B, we should assign the value to A. As I have only 2 possible variables right here, my current letter might be A or my current letter might be B, I will write it as if-else statement. Right now I might test this file, and if I press cancel, it switches the letter to B. I might press cancel again. It switches the letter back to A, so it worked as expected. And right now I might write a message using only 2 buttons. So basically I might press OK to add the current letter to the message, and I might press cancel to switch the letter, and this is our final result. Now let's use new skills to refactor our game project. And you might work in this file, but I will copy and paste this file to a new JS file. So I will press Ctrl A to select all the code, then Ctrl C to copy it, and then I will go to the new JS file and press Ctrl V to paste it. And to see the changes in the console, I should go to our HTML file and change the source to GameRefactor.js. This is the name of our new JS file where we will work. So if you want to work in the Buckshot Roulette.js file, you should choose a Buckshot Roulette.js file right here. Now, if I save the file, we see our game in the console. As you remember, we might press OK in order to shoot the dealer, or we might press cancel to shoot ourselves. And this is basically how we played this game. I expand the window to better see what happens, and notice one interesting thing, that the second cycle and the first cycle are identical. If we want to add more cycles, we basically copy the last cycle and then paste it to create a new cycle. But we might use while loop to actually have as many cycles as we need. I see that my first cycle and second cycle are a little bit different. The second cycle has 2 additional lines. I should add them in the first cycle. I will copy and paste them, and I will delete this space. Our first cycle and our second cycle are identical, but we have one problem, that basically we have both these lines above when we initialize all the variables. So right now we should initialize these variables without any values. So I might just delete all this code above. And right now you see that both these variables are empty, and this is exactly what we need because we added these lines into our first loop. To better understand how to modify our code with while loop, I start to write it a little bit above. When we start writing the while loop, we start from the keyword while. I write this keyword. Then we have parentheses. Inside of the parentheses, we should write the condition that keeps our while loop running. We want to run a new cycle if player's lives is more than 0 and if dealer's lives is more than 0. So the condition is absolutely the same as in our if statement. Then we have parentheses, and inside of the parentheses, we are using the body. Our body is the same as our body of the if statement. If I copy and paste them, Right now we might compare both these statements and we see that they're different only in this keyword while. What I actually can do, I will delete this block that we have written, and then I will just change the if keyword to while. And right now it means that while our player lives more than 0 and dealer lives more than 0, we will generate a new cycle. This is exactly what we did when we copied and pasted our cycles. So right now I might delete the second and the first cycles. Right now you see that we have a game loop, so I might delete this label of first cycle. Then we have a winning check, and winning check happens only if we exit our while loop. And we exit our while loop if dealer's lives is 0 or if player's lives is 0. And then look that we have a default condition that can't running right now because our while loop will generate as many cycles as we need to kill the player or to kill the dealer. So I can delete a default condition as well. And basically, this is the end of our refactoring. So let's save this file and test how it works. I save the file and I see the same message as previously. If I press cancel to shoot myself, we might lose a life or we might gain a life. So I will press it again and you see that lucky break. Right now I have gained my life. So both these conditions works correctly. And let's press OK. And I might also lose a life or I might shoot the dealer and the dealer might lose a life. So let's try to press OK again. Unfortunately, we have lost 2 lives. So let's play this game again. I refreshed the page. Right now I will try to shoot the dealer and you see that you hit the dealer, and I will try to shoot the dealer again, and you see that, yeah, it works. So we might shoot the dealer 2 times, and you might test it as many times as you want, and you will find that this code works absolutely the same as our previous code. Learn increment techniques in JavaScript. With an understanding of loops, we started to increment our variables quite often. Right here I have a simple example of increment techniques. I declare a variable counter with initial value of 0, and then until our counter reaches the number of 10, I increment counter by 1 and log the results in the console. And in the console we have several logs from cycle 1 to cycle 10. But in JavaScript we have shorthands that are extremely common. Let's assume that I have a variable of counter and I need to increase it by 5. I can achieve that with a line like counter equal counter plus 5. But I also have a shorthand for the same code, which is counter plus equal 5. Both these lines do absolutely the same thing, and the upper one is a shorthand. But that's not the end. Have a look at another example. Now we have a counter and we want to increase it by 1. We can use the first method, which is counter equal counter plus 1, or we can use the second method, which is counter plus equal 1. But this situation in JavaScript when we need to increase a counter by 1 is so common that we have the third method, and our third method is counter plus plus. All these 3 line of codes do absolutely the same thing. They increment the counter by 1 and save the result in the counter. But we also can do the same thing with decrementation. In order to decrease the counter by 5 every cycle, we just need to replace the plus sign to a minus sign. And the same thing in the second method. We just replace plus equal sign to minus equal sign. And the same if we need to decrement the counter by 1. So we can use counter minus minus instead of the counter plus plus. Let's try to do the same thing in the code. As I said, I can replace this line of counter equal to counter plus 1 to something like counter plus equal 1. And if I save the file, we see absolutely the same result in the console. I might change this number to something like 2 because we remember that the second method works with all the range of numbers. Instead of 1, we can use 2 or 10 or whatever number you want. So if I save the file, now we see only even numbers in the console. Let's also try to use counter plus plus. And if I save the file, you see that we have absolutely the same outcome that we had before. And once you get used to, you will find that it's much more easier to write and to read. And you will want to use counter plus plus instead of counter equal counter plus 1. And let's also test the decrementation. So I change our initial value to 10. And I changed the condition to counter is more than 0. In this case, we might use counter minus minus, and I save the file, and right now you see that we have cycle 9 to cycle 0. And for example, I might also try counter minus equal 1, and we have the same result. Or I can change this number to 2, and right now you see only even numbers in the console. Today you will learn about for loops in JavaScript. For loops are the most common type of loops, even though they might look very scary at first. The best way to get used to them is through practice. So let's try to solve the same challenges as we had for the while loop, but at this time using for loops. In the first challenge, we need to sum all numbers from 1 to 100. On the right side, I have a while loop solution that we made in the video about while loops. But right now, on the left side, I will solve the same challenge using for loops. At first, I'm using for keyword. Then I have parentheses. The part inside of the parentheses is split into 3 different parts. Let's have a look at the middle part of the for loop. We can find that this part is absolutely the same as we had in the for loop. So the middle part determines while our loop should work. Then if we look at the while loop, we see that we initialized our number before the loop. But in the for loop, we have the first part where we can initialize our variable. And the third part of the for loop is the last action in our cycle. So after the cycle, we should increase the number by 1. We have the same line in the while loop, but it is written in the body of while loop. And then if I want to sum all numbers from 1 to 100, I also need a variable that will store my answer. So I will initialize the total. And in the body, I will write absolutely the same line that we had in our for loop. So total equals total plus number. And let's also log the result to the console. And now in the console, we might see the answer 5015. That is the right answer. Now I will change number to a new variable I. I stands for index, and this is the most common name that we are using in the for loop. And instead of the line total equal total plus I will use a shorthand. Total plus equal I. If these shorthands as plus plus and plus equal are new for you, I have a video on this topic. Let's practice more to get comfortable with for loops. In this challenge, we have 2 phases. So in the rising phase, while our counter moving or changing from 0 to 5, we should add the word darling to our letter. And in the falling phase, when our counter changing from 5 to -5, we should add the word love to our letter. Let's start from the rising phase. I'm starting from the variable letter that equals to an empty string. And then I will write a for loop. So I'm starting from the keyword for. Then I should initialize our variable. Generally, the name of the variable is I. So I will write let I equal to 0 instead of the let counter equal to 0. Then we have the same condition as we had in the while loop. In this case, while our counter is less than 5, so I can write I is less than 5. And then what we should do with our counter after each cycle. We should increase the counter by 1, and I will write I plus plus. Now inside of our body, I will add the word darling to our letter. And at the end of this word, I will add a space to increase the readability in the console. Let's log the result to the console. And now you can see that we have 5 times word darling separated by space, and we had the same result with a while loop. So now let's write the following phase. Again, I will start from the for loop. This might be tricky, but I can again initialize the value I in this for loop. But I think that this might be confusing why we can initialize our variable again, so I think that this is better to change this letter to another one, because this topic is beyond this video. So let's just change I to J. And then we should write the condition while our loop should run. So as you see, while our counter changes from 5 to -5, we should add the word love to our letter. So I will write J is more than -5. And we also should change the initial value of J to 5 because we start our falling phase from the counter of 5. And finally, I will write I --, because we should decrement our counter after each iteration. Inside of our body, I will write letter plus equal love. Let's look at the result in the console. So I will delete this line after our first for loop, and I will add it after our second for loop. And now I have a reference error because I forgot that we have used J in this case, and I wrote I --, so we should change this I to J. And now if we look to the console, we see that we have 5 words darling and then a lot of words love. The third challenge is called printing machine. In this challenge, we should ask a user to write 5-letter message using the confirm function. When the user presses OK, we should add the chosen letter to the message, and when the user presses cancel, we should switch the letter to another one. Pause this video to solve this challenge by your own, but instead of the while loop, using for loops. But right now, let's solve this challenge together, and it will be very interesting that the solution will be almost the same. So I might just copy this part that we had in our while loop challenge. And all what I need to change is the keyword while to the keyword for. And then I also should add the first and the third parts of the for loop. But both these parts don't influence the result at all. So I might write whatever I want in our first part and in our third part. So let's also check this in the console. Is it working or not? And now you see that, please write a message. And then I might add this letter to the message. Or I might switch the letter and add our new letter to the message. And as you see by pressing OK, I wrote the 5-letter message that we see in our console. And the problem of using for loop in this challenge that the for loop is built for specific amount of cycles. These 3 parts that we have in the for loop, they determine the specific amount of cycles. As we had in our first challenge, we knew that we should sum all numbers from 1 to 100. So we knew that if we add a new number to the total every iteration, we should do 100 iterations. And this is the reason why our for loop solution was much simpler than our while loop solution. But the main purpose of while loop is to be used when you don't know the specific amount of cycles. As in this example, we don't know how many cycles user needs to write the 5 letters message because he might switch the letter and basically he might do it infinite amount of time. He might just press cancel and cancel and cancel. For these situations, while loop is much better, is much simpler because it has only the condition while it should run. Master JavaScript for loops with this code challenge. This code challenge is split into 3 parts, so you can attempt each part yourself before watching the solution in this video. This code challenge is built for beginners who are just starting to learn for loops. The first part is called message mixer. You should ask a user to write a message using the prompt function. I will quickly demonstrate how prompt function works. At first, you should connect to the browser using a live server extension. The first message that we see is a confirm function. Confirm function just pop up a message with 2 buttons, OK or cancel. And this function returns true if you press OK and returns false if you press cancel. For example, I press OK and then we have a new message. This pop-up message is generated by prompt function. Here the user can type something, and then if the user presses OK, we will have this message in the JavaScript. And if the user presses cancel, we will have null as a result. So after you got the message from the user, for each character in this message, choose a random 0 or 1. For each 0, you will increment cats by 1, and for each 1, you will increment dogs by 1. Dogs and cats are represented by numbers. To generate a random number, you can use this function, and if you want to know more about random in the JavaScript, I have a video on this topic. Try to solve this part by your own, but right now let's solve it together. The first step in our challenge is to take the message from the user, so I can write the same line to ask a message. And we will store it in the variable user message. Then let's try to write a for loop. I start from the keyword for. Then in the parentheses we have 3 parts. So in the first part I initialize the variable. I is the most common name for the variable in the for loop, and by default we assign the initial value of 0 to the I. In the second part we should determine when our loop should run. We want to iterate through every single character that user wrote in the message, so I can write I is less than user message.length. And in the third part we should increase or decrease our I. In our case we can increase it by 1. Then we need to generate a random 0 or 1. I will start from the variable random number. And then I will write the same function to generate a random 0 or 1. Now I need to increment cats if our random number is equal to 0, and otherwise I need to increment our dogs. So let's initialize cats and dogs. And now we will write a simple if statement. If random number equal to 0, in this case we will increment cats by 1. I used a shorthand ++ to increment cats by 1, and otherwise we will increment dogs by 1. Let's also log the message to the console to see how it works. I wrote 2 console logs, and right now we see a pop-up prompt where we can write something. And when I pressed OK, you see that our word was allocated between 2 variables, cats and dogs. And let's try again. If I just press OK, we have number of cats that is equal to 0 and number of dogs that equals to 0. The second part is called bone distribution. In this challenge, you need to order food for animals. And then in the console, you need to show if there are enough food or not. We assume that all cats have food, but then for each cat, we order a new bone for dog. So the amount of bones will be equal to the amount of cats. And then if number of bones are more or equal to number of dogs, you need to log the message that all animals are happy. And otherwise you will log the message that not enough food. Now you can try solving it on your own, but right now I will show you the solution. Let's start from the new variable bones. And then we'll create a new for loop that will order a new bone for each cat. In the first part, I initialize I. Then I will write that I is less than bones. So we don't need to add a word length to the bones, because in this case, bones are represented by numbers. And in the third part, I will increase I by 1. And now I can just write bones ++, because for each cycle I need to add a new bone. And then we will continue beyond this for loop. We will write that if bones are more or equal to dogs, console.log the message that all animals are happy. And in the else statement, we will log the message that not enough food to the console. I also added a new log to the console to see the amount of bones that we have. So let's test it. I will write something like code, so we know that this word contains 4 characters. And then we see that randomly it was distributed between cats and dogs, and we have 1 cat and 3 dogs. So the next message, that not enough food, is the right message because cats are less than dogs, but then we have the amount of bones that equal to 0, and this is not the right answer because it should be equal to 1. And the problem is that in the for loop we wrote I is less than bones, but bones is equal to 0, so right here should be variable cats. Now if I save the file and write the code again, we see the same situation, but the number of bones is equal to 1, which is the right answer. We can test it again to see that the amount of bones are equal to the amount of cats. I will write a long message. Now you see that we have 8 cats and 8 bones, so all works correctly. The third part is called Hungry Dog Alert, and this is the final and the trickiest part because it depends on the result of the part 2. If in the part 2 you log that all animals are happy, you don't need to add any additional messages. But otherwise, if some dogs are hungry, for each hungry dog you need to add the word more to the message. And after all these cycles, you need to add the word food to the message. So for example, if you have 2 hungry dogs, you will have the message more food. And in this case, I wrote that you will have a variable hungry dogs, but you should think how to calculate it. As always, try it yourself first and then let's solve it together. As I said, it depends on the second part. One of the possible solutions is actually to start writing it inside of the second part. So you have an else statement with a message that not enough food, and inside of this message you can start to solve this challenge. So you can write for loop and initialize hungry dogs and so on. But in this case, I want to show you one trick that you might use if you want to separate these parts. Let's add a new variable enough food with a default value of true. And then in the else part, where we log the message that not enough food, we can set the value for the enough food variable that will be equal to false. And then I will start the third part from the if statement that if enough food equals to false. And here we'll write all the logic for the third part. Also, we have a shorthand for enough food equal to false, which is not logical operator in front of the enough food variable. This if statement is absolutely the same as the previous one, but this is just a shorthand. And now let's start to solve our code challenge. For the for loop, we will need the variable hungry dogs. So how to calculate hungry dogs? So let's assume that I have 10 dogs and 8 bones. To calculate how many dogs are hungry, we need to subtract from the amount of dogs the amount of bones. So let's declare this variable. And we definitely know that hungry dogs are more than 0 because we calculated it in the part 2. So now I can start a new for loop where I will initialize I. Then we need to add the word more for each hungry dog. So I will write I is less than hungry dog. Hungry dogs variable is a number, so I don't need to add .length at the end of this variable. And then I need to increase I by 1. Let's also declare the variable message. And then we'll just add the word more to the message. I also used a shorthand for that. And this shorthand means message equal message plus more. Then we also need to add the word food after all these words more. After our for loop, I will add a new line, message plus equal food. And then we also need to log this message to the console. So let's test how it works. I will write the word code again. And now you see that we have 1 cat and 3 dogs. So we have a message that not enough food. And then we have a message more food because we have only 1 bone. And it means that we have 2 hungry dogs. Let's also try what will be if we press OK. So we see that the amount of cats are 0 and the amount of dogs are 0. All animals are happy because 0 animals need 0 food. How to debug code and what debugging means. Today you will learn two main methods for beginners to find errors in your code. You can download the code that I use in this video from my GitHub. You have a simple program that should add all numbers from 1 to 50 and then divide the result by 75. And you know that the final answer is 70. But if you log the result to the console, you see that the current answer is wrong. The first method how to find an error is to use additional console logs to see how different values change while your code runs. Let's add an additional console log inside of the for loop. Now I logged the value of sum and we see that the value starts from the 0, so this is the initial value of sum, and then all the further values are negative. So it means that instead of the addition, I use subtraction. If I look to the next line, I see that I used minus sign instead of the plus sign. Now I see that the value of sum is positive, but it's still not the right answer because we know that the right answer is 70, but we have 60.333. Now if I look to the console, I don't see any additional clues why I have this mistake. So let's add more variables to the console. Now I also logged the value of I, but it's difficult to differentiate each log, so let's add additional string before the variable. Now it's easier to differentiate which values belong to sum and which values belong to I, and if I look to the console, I see that the last value is 48, but we need to add all numbers from 1 to 50, including 50. So it means that in my condition, I use that I is less than 50, but if I is equal to 50, I also should run the body. So I can change this sign to less or equal. And now we see the right answer in the console. It might be a little bit tedious to always write these strings before the variables, so I have one trick. Now I have two empty console logs, and inside of the parentheses, I will add curly braces. And then I will write sum. I will do the same thing with I. And now you see that in the console we have the name of the variable and then the value of this variable. This is a fast way how to differentiate our logs. We can write additional console logs if we have some clue about where the problem might be. But what if our program is much more complicated and we don't know where might be a problem? For these situations, we have Debugger. This is much more complicated tool and I will cover only basics in this video. How to open the debugger in VS Code. I expanded my window and right now on the left hand you see different icons. You should find an icon with bug and play symbol. If you press it, you will see three different options. Press run and debug. Then I will choose Chrome because I'm working in the Chrome. You might also choose Edge, but I choose Chrome. And now VS Code generated a new launch.json file. If I open the Explorer, on the left hand the icon with two files. Here I will see a new folder, VS Code, containing the file launch.json. All what you need to change here is a port number in URL. So right now this is a port number of 8080, but if you use live server extension, you should use 5500 port. Now I can save this file. Then you need to run your code. I will go to index.html and here in the right bottom corner, I will press go live. Now my code is running in the browser and this is the time to add breakpoints. I will go to the file that I want to debug and here before the line number I have a gutter, and if you hover over it you will see small red button. This is a breakpoint. I will add one breakpoint before the let sum equal to 0. Without breakpoints, debugger can't work. A breakpoint is essentially a point where your code will be stopped and you will be able to see which values your variables have. So put this one breakpoint and then we can again press run and debug button And now we will see a little bit another screen. I expanded my window and let's clean up this workspace. At the beginning, you will need only variables folder so you can minimize all other folders. I minimize watch, call stack and breakpoints. And now I have only variables. And now it's the time to run our debugger. I have a green play button. If I press it, we opened a new instance of our browser. Now I minimize this window and open the Explorer. If you have a lot of different folders, in this case, when you start a debugger, you should choose in which folder you want to debug your code. So in this instance, I have all folders and I need to choose which folder I want to debug. In my case, this is AT debugger folder. I press it and I see that my line 4 is highlighted and I have new buttons. This yellow highlight means that our code is stopped and it waits for our command. The main command that you should know is step into. If you press it, you will see that on the left hand in the variables folder, you will see a new variable sum that is equal to 0. And right now, if I hover over sum, I will see a number of 0. So this is the current value of this variable. For example, if I hover over I, it shows me that I is a number, but it doesn't have any specific value. Let's press it again. And now we see that we have a new variable I that equal to 1. And if I hover over I, now we see a value of 1. Let's press step into again. So now our code checked this condition that I that is equal to 1 is less or equal than 50. And this is true. This is the reason why we go inside of our body. Here I see that my sum equal to 0 and then I want to add the value of I that is equal to 1. So if I press step into again, now my sum changed the value from 0 to 1. If I hover over sum, we see that this value is 1. I can continue pressing step into. And we will see that the value of sum and the value of I changes every time when we press step into. And we can observe which values they have. So if you want to leave your for loop, you can continue pressing step into. But here we have another button, continue. And what continue does, it skips all the code before the next breakpoint. So now we have only one breakpoint. This is small red dot in the gutter. I can add a new breakpoint, for example, on the line 8. So now on the line 8, I have another breakpoint. And if I press continue, I see that my sum equals to 2075. And right now my line 8 is highlighted. And then I can continue pressing step into. And now we see the final value of 70. And if I press step into again, we finished our code. When you finished your code, this is the end of your debugging. Now you can stop debugging by pressing this red square, or you can restart your debugging. It will return the debugger to the initial breakpoint. It's also important to understand that in the VS Code, you can only step forward, so you can't return back. If you want to return back, you need to restart your debugger. One more example how to use debugger with more complicated project. This is another JavaScript file. So at first, in my HTML file, I should change the source to the file that I want to run. In my case, I want to run game.js, so this is the reason why I have this name. Then I must put at least one breakpoint if I want to run a debugger. I will put it on the same line where I declare my first variable, just to start observing my code from the beginning. Then I need to run my code. I return back to my HTML file and press go live, and now I see that my code is running in the browser. I can minimize this window because I want to debug this application. I return back to my JavaScript file and then I press play button. Remember that you should choose run and debug, and then you will see green play button. New instance of Chrome browser is opened, and here I should choose my folder. So in my case, this is AT debugger, and now I can minimize this window. And in my code, I see that the line number 3 is highlighted, so it means that we stopped at this position. Now I can step into my code, and on the left hand, I see how different variables appear. I can continue step into. So now I have several values, And now I'm inside of the while loop. Interesting thing of the debugger, I can hover over my variables and then I can calculate the result of this statement by myself. So I see that player lives equal to 2, so 2 is more than 0, and dealer lives equal to 2, and 2 is more than 0, so it means that this value is true, and we will go to the body of our while loop. Here is also one interesting thing. Now I have a variable bullet, and we will randomly assign 0 or 1 to this variable. If I press step into, now I see that my bullet equals to 0. Then we have player choice variable. If I press step into, it seems that we finished our debugging, but I still have this debugging tools, and we need to remember that confirm function waits a response from the user. Actually, we need to open the instance of our browser, and here we see a message, and we need to choose OK or cancel. So I press OK, and then I again minimize this window. And now we see that our next line is highlighted. Player choice equal to true because I pressed OK. Here we have if else statement block, and I can manually find the right branch that will be chosen. If I hover over player choice, this equal to true, our bullet equal to 0. So I know that this branch will be skipped. Let's observe the value of the second if statement. The first value is true and our bullet equal to 0, so I know that this branch will be chosen. And yes, if I step into, we see how our branch works. Our player lives should be decreased by 1, and now our player lives equal to 1, and then we have a console log. And if I pressed step into again, all our block is skipped and we return back to our while loop condition. Our code checks again, is it true or false? Player lives variable is equal to 1, this is more than 0, and dealer lives variable equal to 2, this is also more than 0. It means that we again run our body. I think that you understood how we can observe different values with debugger. I hope that this video wasn't too overwhelming for you and you learned something new. Today you will learn about let, var, and const, and also the cases when you should use them. This is a beginner's guide, so I will explain the topic without going too deep. Let's start with var. This keyword is very similar to let, but it was introduced into JavaScript earlier than let, so you will see a lot of this word in legacy code. Legacy code means old code. For example, I have a variable my car with a value of Lamborghini, and I also log this variable to the console. And you see that we have a word Lamborghini in the console. I might easily change the keyword var to let, and if I save the file, you will not see any changes. We don't use var much because we have let. But if you look at some code on the internet, right now you know what means var. Up to this point, we use the keyword let to create our variables. Let keyword creates a variable that we can change. For example, I have a variable of favorite coffee with a value of espresso, and if someone asks me what is your favorite coffee, I might answer that my favorite coffee is espresso. But if someone asks me the same question after 5 years, I might prefer another type of coffee, and I might answer something like, my favorite coffee is latte. In this example, I changed our variable favorite coffee to a latte, and this is the reason why I use the keyword let. Const stands for constant. It creates constants that we can't change. For example, if someone asks me what the capital of Great Britain is, I answer London. After 5 years, I would probably still say London. And this is the reason why capital city is a constant in our code. Why we can't use let for constants? This is a great question, and let's look at an example. Imagine that you have a variable with a very simple name, something like x, and then you have a line where you do something with x and log the value to the console. So in our case, we know that this line should be equal to 100. Imagine that your code keeps growing, and between these lines, you have, for example, 1000 lines of codes, and it still works correctly. But now, after a week, you start to modify this code again, and you accidentally forgot that you had a name of x in your code. So you start to write a new section where you use the same name x, with a value of 20. And then you log the result to the console. And if you save the file, you see that your newly created code works correctly. But then you notice that your previously created code doesn't work correctly. And it might be very difficult to find the mistake, especially if you're faced with this problem for the first time. But what happens if we use the keyword const instead of let? Now I deleted our newly created code, and instead of the keyword let, I use the keyword const. Now it works absolutely the same, but if I try to add the same code between these lines, where our x equal to 20, JavaScript immediately throws an error with a description that assignment to constant variable. So it means that we try to change the value of constant variable. And when we see this sort of error, we immediately understand that, okay, this variable was in my code and I should use another name for the newly created variable. The keyword const add an additional layer of security to your code. So the general rule that I was taught is to use consts by default and to switch to let only if you know that you want to change the value of this variable. For example, I have a constant variable of favorite animal that equals to cat, and then I want to change this variable to something like dog. So we can't do it until I change the keyword const to the keyword let. And in this case, it's totally fine to change these keywords because we consciously decided that we want to reassign the value of favorite animal. At first, it might seem like a lot of additional work that you should do, but in the future, it will save you tons of time, especially when you start to work with more complex data types. I definitely recommend you to start a new routine when you use const by default instead of let. Today you will learn about arrays in JavaScript. As you remember, we can declare a variable, for example, ingredient. We used a keyword let for that, but now we are using const to add an additional layer of security. And as you see, in primitive variables, we can store only one object. So for example, here I store a hot paper as our ingredient. But what if we want to store multiple items? For example, ingredients. For this purpose, we have an array. An array is a collection of some items. Like here, you see that we have a variable ingredient, but in our array, we can store multiple ingredients. To create a new array, we must use square brackets, and then inside we can add different primitives. And as you see, I separate them with comma. Arrays have different methods. For example, we have methods to dynamically add and remove items. The first method is push. If you hover over it, you will see the description of what this method does. And as you see, appends new elements to the end of an array. So this is the first part that describes that we have an array, and then with a method push, we can add new items to the end of the list. And this is what we see in the console. So if I log our ingredients to the console, we see 5 elements, and the last element is a caret. The next method is opposite to the push, and this is pop. So if I hover over pop, we see the description that it removes the last element from an array. And as you see, right now in the console we have 4 elements, and we don't see caret that I added one line before. Then we have the unshift method that inserts new element at the start of an array. And what we see is that our new element right now in the first position of our list. And we also have the opposite method shift that removes the first element from an array. You don't have to learn all these methods. If you want to see the list of all methods that you can use, just write the name of our array. In our case, this is ingredients. And then use a dot, and you will see a list of all methods that you can use. And then if you want to know what that method does, just write this name and you will see a short description of what this method does. Also, if you look at this description, you will really often see the word returns. What this word means? Word returns means the value that you will store in the variable if you will try to store this array with a given method. For example, in this case, if I try to store this array with the method push in the variable, now I will use the word const instead of let, and then I will write variable. And now I also log this variable to the console. And now you see that our variable equals to 5. So we don't store our ingredients, but what we actually store is the new length of the array. All the description that goes after the word returns means what will be stored if we try to save it in some sort of variable. In our case, we can use any name for variable and we can change it to length or array length. We don't have any changes in the console, but right now this name describes what this variable stores. Let's look at our next method. Pop removes the last element from an array and returns it. So if I try to save this element, I will save the last element of our array. And now you see that this cheese that I pushed in the previous line, if I use the method pop, we don't see cheese in our ingredients, but I can store it into a separate variable that will store this cheese. The third method unshift is really similar to push because it also returns the new length of the array. And if we look at shift, it's really similar to pop because it removed the first element from an array and returns the first element. So now if you look to the console, you see that we don't have a mushroom in our ingredients list, but we have this in our variable first element. Now let's talk about indexes. If you look at our array in the console, you will see that the first number is the length of our array. Then you see these elements and you see this small triangle that you can expand. And here you will see more information. So you will see 0 is a bacon, 1 is a cucumber, and 2 is potato. And the last that length equals to 3. What are these numbers? 0, 1, 2 are indexes of our array. An array in JavaScript are 0 based, and this means that the first element has the index of 0, the second element has the index of 1, and the third element has the index of 2. And why this is helpful is because we can get access to a specific element by index. I wrote ingredients to the console, and now if I use square brackets and then I will put 0, now you see that we have a bacon in the separate line in the console. And notice that we still have this element in our array, but as you see, I can get access to this element using the index. Now you see all these elements accessed by index. If we try to get access to the element with index that doesn't exist in our array, we have undefined as the result. We also can get access to this property free by using ingredients.length. And now you see that I have ingredients 0, 1, 2, and then ingredients.length. And in the console we have 3, which is equal to the length of the array. How to get access to the first and the last elements of an array? As I said, we can get access by indexes. The first element in our array is ingredients with index of 0. And if you think about all other arrays, where the length is more than 0, if our array contains any items, the first element will always be element with the index of 0. But the last element is more complicated, because in our case, the last element has the index of 2, but if we add more elements, and for example, if we have 5 elements, in this case, we can't just use a hard code number, but we can calculate the last index. If you look at our array, the length of our array is 3 and the last index is 2. So it means that to get access to the last element, I can take the length of the array and then subtract 1. Let's use, instead of the hardcode value of 2, this formula. And now, as you see, I still have a potato in our console. Now I added more elements to our array, and you see that the last element is cheese, and this formula still applies, and in the last log we have a cheese. Let's solve a code challenge. Imagine that you have an array that contains some number of elements, and then no matter how many elements your array has, you should write a program that displays each element from an array in the console on a new line. For example, if you have the array items that contains 1, 2, and 3, then the manual way would be to create 3 different console logs and to get access to each element by index. But in this case, if I add or remove some elements from this array, I still need to change my logs. But how to write the program that would automatically display every single element from this array? Try to solve this code challenge by yourself. But right now let's solve it together. We have some sort of array, so we can start from the array of items that contains 1, 2, 3, and then we need to use a loop, and the condition of loop should take into account the amount of elements that our array contains. So I start from the keyword for, and then we need to declare 3 things. So the first block should has some sort of index, so I will write let I equal to 0. The second block is our condition. At this point, I will write some hardcode value, something like I is less than 10. But we will change it later. And the third part should increase our counter. I will write I++. And now our body should log every item to the console. So I will write console.log and then items. And in brackets, instead of the hardcode value, I will use our counter I. And if I save this file, you see that we have 1, 2, 3. We almost achieved our condition, but then we have 7 console logs of undefined. And this is because our condition has a hardcode value of 10. If we add or remove some elements from the array, we will still have 10 console logs in total. What kind of variable should be instead of 10? So let's think how many console logs we need. For this occasion, we need 3 console logs. Why 3? Because we have 3 elements in our array. So the length of this array is 3. Now I have 5 elements in the array. So how many logs we need? We need 5 logs because we have 5 elements in this array. So the length of the array is 5. Let's try to use the length of the array instead of the hardcode value. And now you see that we have as many logs as we need. If I remove some elements, for example, I remove 1 element, our program makes 4 logs. So it automatically updates how many logs we need based on the length of our array. Let's practice arrays with these code challenges. The first challenge is stock the fridge. Imagine that you have a fridge that is represented by an array and it contains some items. And then you bought new products and you have a list new products that is also represented by array and also contains some items. Take each item from new products and add it to the fridge. Then log the result to the console and you should see this result. Every time when I show a challenge, try to solve it by your own, but then we will solve it together. So we need to iterate through every single item in the list. So it means that we should use a loop. I used the pattern from the previous video that is very common to iterate through each item in the list. For the clarity, let's initialize current product. As you remember, I use const instead of let. Then I use the name current product, and let's think how to find the current product. We can get access to each item in the list by using the index. The first element has the index of 0, and this is our initial value for I. So to get access to the first element, we need to write the name of our array. In our case, this is new products. And then in square brackets, we can use 0 to get access to the first element. But as you remember, we can use I to dynamically get access to each element in the list. And then we need to add this current product to our fridge. I use the push method to add a new element to the end of an array. And now if I save the result and look at the console, we see that now fridge contains all items from the fridge and new products. So we added all elements to the fridge. In the second part, we should clear the incoming list. So as we added all elements to the fridge, we need to remove the elements from new products list. So in the first part, we have new products array that contains these items, and now we should remove them. As we need to iterate through each item to remove it, we again need to use a loop. But in this case, we can use a while loop because we don't need indexes of items. As you remember, we have two methods like pop and shift to remove the last and the first elements from an array. And we can use them to remove all elements from new products array. So I start from the keyword while. And then in the parentheses, we have a condition where our loop runs. As we need to remove all elements, I can write the condition that while our new product's length is more than 0, we need to remove one element from the array. I use the pop method to remove the last element from the array, but you also can use shift method. And now if I save the file, in the console you can see that our new products list is equal to an empty list. In the next part, we should calculate the total cost of our new products. So now we have a new list, new products costs, that contains cost for each element from new products list. And we also have a variable total price. And now we should compute the sum of all prices into total price. So again, I need to iterate through each element. So for that, I will use a loop. I will use a for loop with the same pattern that we had in our first part. As you see, this pattern is the same as we had in our first part. Only one thing that we change is the name of our array to a new one. So let's declare the current price. As in the first challenge, our current price equal to new products costs with index of I. And now we should add this current price to the total price. So I will use total price plus equal current price. Let's look at the result. And as you see, we have the right answer. In the part 4, we should find the highest price. So we again need to iterate through every item at new products costs, but right now we need to find the maximum. Our starting code is the maximum with initial value of 0 because this is the lowest price. It means that if our array contains any numbers, these numbers will be higher than our maximum and we will reassign our maximum to a new one. So let's start from the for loop. So I wrote the same for loop as we had in our previous code challenge. And as you see, I also use the same array new products cost for this challenge. Then we also can declare the current price. And now we should write the condition that if our current price is higher than our maximum, we should reassign our maximum. So if you think about this condition, if our current price is equal to maximum, we don't need to change the maximum. And if our current price is less than maximum, we also don't need to change it. Only in the case if our current price is higher than our maximum, we should reassign our maximum to our current price. And if I save the file, we see the right answer in the console. So the last challenge is very similar to our previous one, but on this time we should find the lowest price. Here the idea is the same, but the tricky point of this challenge is actually the starting code. As you see, we have the minimum with the initial value of infinity. So to find the minimum, we should start from the highest positive number, which is infinity. In this case, we guarantee that any number that will be in our list will be less than our current minimum, and we will reassign the minimum to a new value. The solution is very similar. I start from the for loop, then I declare the current price, and then I write the condition that if our current price is less than our minimum, we reassign the minimum to our current price. Let's see the result. And as you see, we have 4 in the result. It means that we correctly found the minimum. What is scoping in JavaScript? Now I show one example that looks like a magic if you don't know what is scoping in JavaScript. I declare my variable that equals to 1. Then I log it to the console. So now in the console you see 1. Then I create a simple if statement that equals to true. For example, if my variable equals to 1, and now I declare a variable with the same name as we had before. But on this time, my variable equals to 2. I also logged it to the console, and now you see that I have 2 variables with the same name in my code. And it seems that I reassigned my variable that was equal to 1, and right now it is equal to 2. But how it is possible? So scoping creates its own world inside of our code with its own rules and variables. It can get access to variables from outside, but can't expose its own variables to the outside. Let's have a look at several examples to better understand how it works. Let's start from declaring x that is equal to 5 in the global scope, and then we log x to the console. So this is a global scope. This is how we usually declare our variables. And as expected, we can access those variables and see the result in the console. Now let's create a local scope and let's try to get access to the same variable in a local scope. To create a local scope, we need to use curly braces. So every time when you see some code inside of curly braces, this is a new local scope. For example, I can use if statements, but the same local scopes you might create with for loops or while loops. So I wrote that if true, which is always equal to true, then we log x to the console. And this is also what we did, and as expected, we can get access to this variable, and again in the console we see 5. On this time, let's create another local scope, and there we will declare a variable with the same name as x. But on this time, our x will be equal to 10. So now I created another local scope, and there I declared x, and as you see in the console, this x equal to 10. As I said, when you create a new scope, this is a new world with its own rules and variables. Our previous x is unchanged. I logged x to the console again, and I did it in a global scope. We can understand it because we don't have any curly braces. And as you see, our last line equals to 5. On this time, let's also add a line x++ in our local scope. In my second local scope, after I declared my x, I increased it by 1 and then I logged it to the console. And now you see that only one line have been changed, so it means that when you create a new variable within a local scope, you affects only this variable. Our change x++ influence only this area inside of curly braces, because we declared x in this local scope. Now let's create a new local scope with the same line x++. Is very important difference. I created a new local scope that is very similar to our previous one, but I didn't declare x again as I did it in my previous local scope. And what we see that I increased x by 1, and then when I logged it to the console, we see 6 as a result. And then in my global scope, I also logged x to the console, and you see that my local scope affects the variable that we declared in our global scope. We also might declare a very similar local scope where we reassign x to a new value, for example 1. And again, as you see, I didn't declare x within this local scope, so it found x from the global scope that we declared in our third line, and it changed the value to 1, and then you see that 2 times when I logged x to the console, I have a value of 1. So again, this local scope affects the variable from global scope. But I highlighted both these actions with yellow color because it works only if we use let instead of const. So as you remember, const add an additional protection that prevents a variable from reassignment. So it means that if I change this keyword let to keyword const, now I have an error because both these local scopes are trying to reassign a const value of x to a new one. So I can comment out them, and you see that we don't have any errors anymore. Both these actions are legal only if we use let instead of const. Now let's create a new local scope where we declare a value of y. So now I created a local scope and I declared y that is equal to 1, and as expected, I can access this variable within this local scope. But if we try to get access to the same variable in our global scope, JavaScript throws an error because this variable can be accessed only within this border. Now in my last console log, I tried to access the variable of y, but as I said, JavaScript throws an error. And if we look at the description of this error, we see that y is not defined. It means that JavaScript don't know about any y on the line 31. All variables that are created in a local scope, they can't be exposed to the outside. And the same, if I try to create a new local scope that will log y to the console, we will also have the same error because again, as you see, y is declared only within this box. And when we create a new local scope, this local scope is not within our previous local scope. And as you see, we have the same error because JavaScript can't access to the variable that was defined within a local scope. One more interesting feature is that we can have nested local scopes. For example, let's start from declaring a local scope within our global scope, where we declare x that is equal to 10, and then we log x to the console. So at this point, we have a variable x that is accessible only within these curly braces. Now let's create a new local scope that will be inside of our previous local scope. We create nested local scopes, and there we declare a variable of y and log it to the console. To create a nested local scope, I will use the same if statement inside of our previous if statement. So as you see, right now we have a local scope, and it exists in our previous local scope. There we have y that is equal to 1, and when we log y to the console, we see that it equal to 1 and we don't have any errors. As I said, our x is accessible within these curly braces. So it means that we can get access to this x in our nested local scope. I will log it to the console. And as you see, it works fine. But if we try to log y to the console from our first local scope, we'll have an error. And this is because our y is accessible only within this local scope. But our console.log line is outside of this local scope. In our code, I logged y to the console, but as you see, this is outside of the y's scope. This is the reason why we have reference error that y is not defined. And again, let's create a new local scope that is outside of our nested local scopes. I comment out this line, and now I can create a new if statement. As you see, this local scope can create variables with the same name, and we don't have any conflicts. Today you will learn about functions in JavaScript. A function is a reusable block of code. For example, imagine writing an email. In the first part, you need to write some greeting. Then you have the main part, and you also have a closing or a sign-off. And when you write a new email, you want to write only a main message. You don't want to manually repeat the greeting and the closing. So let's write a function that will take all these parts. Now all my parts are within a function that I defined with a keyword function. Then I write a name of this function. In our case, this is email. And then I have a set of parentheses and curly braces. And inside of the curly braces, I have my body. The body is a part that will be executed if we invoke this function. I write a new line email with parentheses. This is how we invoke a function. And now you see that in the console we have 3 messages that we defined in our function. Imagine that this is our email to a first friend. And if we want to create a new email for the second friend, all what we need to do is to type email with parentheses. And now, as you see, our function was invoked twice, and each time it generates 3 console logs. Our function works well, but we want to change the main part. So right now we always generate the same message if we invoke our function, but we actually want to change the main part. For that, we can send some information to our function. I delete our second email. Now we have just 3 logs in the console. And now, where I invoked our function, let's write some email. For example, how are you? This message that I sent to our email should be instead of our main part. The data that I sent to our function when I invoke it is called an argument. All this message that I sent is called an argument. And then our function should receive this message. For that, in the function's parentheses, I should create a new variable. On this time, I will not use let or const keywords. I will just write a name of the variable. So this is a main part, so I can write main part. And this variable inside of function's parenthesis is called a parameter. So this is the data that our function receives when we call it. Now I can use this variable instead of our message. And as you see, now in the console, we see hi, then how are you that we sent to our function, and then all the best, Bob. And now if I want to write a new email, I also need to invoke this function. So I write email. Then I put parentheses, and here I should write a new message. And now you see that in the console we have 2 messages, but their main parts are different. Now, what if we want to send back some response from our function? For example, our function can respond that your message has been sent successfully. For example, we want to send this message back as a response. For that, we have the keyword return. Before this message, I can write the keyword return. And now you don't see any changes, but all this function that we call will be changed to this message. For example, I can store this function as a variable. And then I can log it to the console. And now you see that we sent a message and then we received the response that your message has been sent successfully. To better understand how our code works, let's look at our code step by step using a debugger tool. If you don't know what debugger is, I have a video on this topic. Before we start, let's write a new variable x on the second line. We will put a breakpoint before this variable to start our debugging session from the beginning. Now I maximize my Visual Studio Code, and on the left hand side I see the button Run and Debug, and here I need to click a green play button to start my debugging. I also need to choose a folder where contains my code. Now I can minimize this window, and if you put a breakpoint, you should see that our variable x highlighted in yellow. So it means that we started our debugging, and now I can press step into, and as you see, our debugger just skipped our function. So this is important to understand that when you write a function, JavaScript just skips this part until we call it. Eventually, after the line where we declared our variable, the next line for our code is where we invoked our function. If I press step into, now you see that we are inside of our function. So this is how it works. When you call your function, your code starts to execute every single line in the function's body. On the left side, we also can see that we have a new variable main part that is equal to how are you. This is a variable that we created in the function's parentheses, and the value of this variable is the data that we sent to our function. At the bottom, I see a debug console, which is the same as the console in the browser. When we execute the line console.log hi, you see that we have this message in the console. And when we execute console.log main part, we see the message how are you in the console. Then we see the third message, and then we have a return statement. If I press step into, our debugger is still on the same line, but in the left side, we see a new variable return value that is equal to our message. So, and now if I press step into, you see that our response is equal to this message. And if I console.log our response, you see that your message has been sent successfully. Today you will solve 4 JavaScript challenges to master functions. First, I will show you the problem's description and examples. Then try solving it on your own, and then we will solve it together. In the first challenge, you need to write a function that has one parameter message. And then this function should display the message in the console with the question mark in the end. And here are some examples. So this is the name of the function. And then you have the data, how are you? So this is the data that we sent and that will be stored in the parameter message. Then we have this arrow that means that the function display question should return something. And it should return a string, how are you? So this is the same message, but in the end, we have an additional question mark. For example, if I send the data, how are you with question mark, this function should return, how are you with 2 question marks. Try solving it on your own. I start from the keyword function. Then I write the name of the function. In our case, this is display question. Then I put parentheses and curly braces. Now I see that we have one parameter message, so let's add this parameter. And now let's solve this challenge step by step. On the first line, I should create a new message. For example, I can call this variable question. And this variable equals to message plus question mark. And our second step is to return this variable. So I see that I have a typo in our variable question. And now we don't have any mistakes. Let's call this function and look to the console. I invoked the function displayQuestion and I sent the data how are you. And when I log it to the console, I see how are you with the question mark. Let's try it with other examples. And now I see that our function works correctly because we have the same answers as in our examples. We also have the short solution for this challenge, and it would be return message plus question mark. It is also a valid solution, but in the beginning, I really recommend you to separate each task to a single line. It will help you to debug your code, and it will be easier to understand what happens in your code when you open this project after some period of time. In the second challenge, you need to write a function that has two parameters, hours and pay per hour. And your function should calculate how much money a person gets per hours. So for example, if you work 1 hour, and if your pay is $1 per hour, your total earnings equal to 1. And if you work 10 hours and you get $10 per hour, your total earnings equal to 100. How to calculate the total earnings? Try solving it on your own. Some explanations how to solve this challenge. If you look at these two numbers and the result, you can find the mathematical operation that you can use to solve this challenge. So you can multiply both numbers and then you will get the total earnings. And it will also work in our last example because as you see, we worked 0 hours and no matter how much money we get per hour, the total income will be 0. Let's just multiply two numbers to find the total income. I write the function calculate earnings and I have two parameters. Let's add both these parameters to the function. And as in the previous challenge, let's solve it step by step. Our first step would be to calculate the total earnings. And we also should return our total earnings. So on the second line, let's return total earnings. Now I called this function again and I used the first input from our examples, and as you see, we have the right answer. Let's do the same with the remaining examples. And now as you see in the console, we have exactly the same answers as we had in our examples. So it means that we successfully solved this challenge. In the third challenge, we use arrays. An array is a compound data type, and I have several videos on this topic. In this challenge, you have the array plans, and your function has one parameter plan. The function should add a given plan to both ends, to the beginning and to the end of the plan's array. And I have a line with attention that this function doesn't return anything. So if you look at our examples, we have the initial array plans with the string code inside, and then we invoke our function add plan to both ends, and here we use it as the data for the parameter plan. And then if I log plans to the console, I see a new array where the first element equal to it, then we have code, and then we have it. The same in the second example. We have two actions, sleep and work, and when I add a new action, read, now I have 4 actions in my plans, read, sleep, work, and read. This is your initial code. And as always, try solving it on your own, but right now, let's solve it together. So first thing that I need to add is a parameter plan. Then an array has two methods: to add the element in the beginning of the array and to add the element to the end of the array. Unshift method inserts new elements to the start of an array. This is exactly what we need, and here I can put plan as element that I want to add to the array. And we also have the method push that appends new element to the end of an array. So I need to add the same plan to the end of the array. If you forget the exact name of these methods, you always can write the name of an array. In our case, this is plans. And then you can put dot, and you will see the list of all methods that this function has. And then you can write a method's name. And if you hover over it, you will see the short description of what this method does. On this time, our plans equal to array that contains code, as in our first example. Then we have the function add plan to both ends. I log to the console plans, so as in our example. But as you see, we don't have any changes. And this is because if we want to execute our function, we need to call it. So I add this additional line, add plan to both ends, that contains the string it. And now you see that in the console, we have the array, and if I expand it, you see that it contains it, code, and it. Let's also try the second example. Now I changed our plans to sleep and work, and when I call our function, I provide the word read, and as you see, we have the array with read, sleep, work, and read. So it means that our function works correctly. And finally, you will solve a complex challenge. On this time, your function will have two parameters, numbers, which is an array, and a number. And your function should return true if a given array, numbers, contains a number that is greater than a given number, and otherwise it should return false. For example, you have two inputs. The first input is always an array. In this case, it contains the number 2. And then you have the second input that is always equal to one number. And this function returns true because we see that 2 is more than 1. In our second example, we have 1 which is not greater than 2, so we return false. Then we have more complicated example where array contains multiple numbers. And in this case, we need to find if any number from this array is greater than our second input. And we see that yes, in this function, we have the number 2, which is greater than 1. So we return true. Then you have almost the same example, but your second input is equal to 2. And it returns false because 2 is not greater than 2. It is equal to 2. We need to return true only if any number from this array is greater than our second input. And finally, we have an empty array, so it doesn't contain any numbers, and this is the reason why we return false. Try solving it on your own. Try to recall different techniques that you know in JavaScript to solve this code challenge. You also can use a paper where you write down the step-by-step instruction of what this function should do to give the desired output. You need to understand that the computer can do only one step per tick. When we create an algorithm, which is the step-by-step instruction for our computer, we need to solve it step by step. So first of all, we have the array that contains 3 numbers, but we need to compare each number to our second input to determine if there is any number that is greater than our second input. Our first step would be to take this first number and our numbers equal to 1. And then we compare two numbers. So we take 1 from our numbers and we compare it to the number from our second input. When we compare, we ask the question if this first number is greater than the second. If not, we go to the next number. So we forget about our previous number. Now our number is equal to 0 and we compare if this number is greater than 1. We know that this number is not greater, so we move to the next number. And now we have the last number in our array and we compare if this number is greater than our second number. And yes, this is greater, so this is the reason why we should return true. Do we have some tools in JavaScript that can go step by step through the entire array? We can write a for loop that will go through each element from this array and that will compare both numbers together to find if there is any number that is greater than our second number. When we compare two numbers, we also need to store this result somewhere. So we can create a new variable, for example, response, that is equal to false by default. I write R for the variable response, and if I find the case where the number is greater than the second number, I have to reassign my response to true. Now let's write some code. As always, I started from our function and then I have two parameters. So I need to write both these parameters. Then we declare a for loop to go through each element from our array. In the first part, I declare I for index, Then I write the condition while I is less than numbers.length, and then I need to increase I. In this case, when you write numbers.length, you will not see any clues from Visual Studio Code because our function doesn't know that numbers is an array. Then I need to create a variable with the number from this array. I can't write number because we already have number as the name of our parameter. I will write the long name number from array. And this is equal to numbers with the index of I. As you remember, when I use square brackets, I can get access to a specific number by index. And then I need to compare both numbers. If my number from array is greater than number, in this case, I reassign my variable response to true. But now we don't have any variable that calls response, so let's declare it before the for loop. On this time, I use a keyword let because we reassign this variable in the future. And that's it for our for loop, so we don't need to write any else statement like else response equal to false because our response equal to false by default. And if number from array is not greater than number, we just want to skip this number and go to the next one. And then when we finish our for loop, we need to return our response. And now I logged this function to the console and we see that for the first example, we have the right answer. So let's do it with other examples. And now as you see, we have exactly the same answers as in our examples. So we successfully solved our final code challenge. This is the project where you will learn the most basic mechanics that are used in the most popular 2D games. All you need to know to follow along this project are functions, loops, arrays, and if statements. This is the first version of our game. You have a map that is represented by hash symbols, and then you have a pop-up message that asks you where you want to put your unit. I need to provide index, and similar to arrays, index are 0 based. I can put 0 and then I press OK, and now we see our align unit that is represented by a letter on the first line, and on the last line we see an enemy that is represented by e letter. Then again I can add a new unit. I type 0 and press OK again, and now you see that units are moving towards each other. The purpose of this game is to reach the end of the map, but when two units collide, they destroy each other. For example, let's continue, and now you will see how on the third line, two units will be disappeared because they will collide. And if I reach the end of the map, I have the message that you win and I don't have pop-ups anymore. In the future, we will add more units and create a full stack application with graphics and multiplayer. What we need to do to make our game? First of all, we need to create a function that displays our map in the console. In the game creation, the typical name for this function is draw. Then we need to add allies and enemies on this map. Then we need to create a function with the logic of movements of our units. And last but not least is to create a winning logic. So we need to have a function that would check if we have a winner. And if we have, we need to stop this game. Let's create our map. And as you see, this variable should be string, but we will store it as a 2D array because we need to get access to each symbol independently. A 2D array is an array that contains arrays. I create an array, then I expand it by pressing enter, and now I will create a new array. And inside of this array, I will store hash symbols. This is a row and this is a column. And in one row, we have 5 hash symbols. So I will add 5 hash symbols separated by comma. And now this array represents our first row. After this array, I need to put a comma. I again press enter, and now I create our new array. And it will be absolutely identical because each row is the same. Let's add more lines. When I add the last array, I need to delete the last comma. And now you see that this grid is very similar to our map. This map is an array. This is not a string representation. So for the clarity, I will add array to the name of this variable. And now this variable calls map array. Let's write our first function. This function should draw our map. To do it, we need to convert our map array into map string, and then we need to log it to the console. So I create a new variable map string that is equal to empty string. And then we need to iterate over each symbol in this map array and add it to map string. We'll need to extend this string, so this is the reason why I changed the keyword const to let. And now I write a for loop. This is the most common loop to iterate through each item in the array. Usually we use arrayname.length property instead of 5, but now for the clarity, I hard-coded this value to 5 because we have 5 rows. As you remember, we can get access to each element by index. What we will have if I access to our array with index of I. For example, I is equal to 0. So I change the I to 0, and if we look at our array, the first element with index of 0 is the first line of this array, so the first row. It means that if I access to the array with I, it will give me a row from this map. Let's store this in the variable. And now we know that this row is a simple array that contains strings. So it means that we can iterate through this array again. For that, I will write the second for loop. On this time, my for loop is inside of another for loop, and this is the reason why I can't use the same variable's name, and I need to change our variable I to something else. By convention, if we write the second for loop, we use the name j instead of I. So I also wrote j less than 5 because this row contains 5 elements. And then I write j++ as we did with I. These two for loops are absolutely the same, but the name of the variable is different. If I access row with the index of j, I will get one of these elements. So it means that I can save it as a tile. A tile is simply a string, this one element from the map. Now we need to add it to our map string to display it in the future. If I just add tile to map string, I will eventually have a string with 25 symbols length, but I also want to separate them into each line. As we have in our map array, let's create a row of string and then we will add rows to the map string. I rename our variable row to row array. I also need to rename this row as well. After row array, I create a new variable row string. I use the keyword let because we will add elements to this row string. Now let's add a tile to a row string. Eventually this string will contain 5 hash symbols, and when we finish this for loop, we need to add this row to our map string. We also want to put each row on a new line, and for that we have a \n symbol. This symbol adds a new line, so it works the same as pressing enter on a keyboard. And when we finish both for loops, we can display our map in the console. So let's test our function. For that I need to call it. And now you see that we have a map in the console. Do you remember this overview? These are components of our game loop. The simplest way to implement a game loop is by using a while loop. I create a new while loop. I also add break keyword to prevent an infinite loop. So we need to write a condition for our while loop. So the condition while we need to play. And generally we need to play while we don't have a winner. Let's go to the top of our project, and before the map array, let's declare a winner. I create a new variable winner that equals to false, and I start from the keyword let because I know that in the future I need to change this variable to the actual winner. And now instead of the keyword true, we can use the condition while our winner equals to false. We also have a shortcut for this condition, which is a not operator before the keyword winner. So it means while our winner is false, so while we don't have a winner, we need to do something. And for example, we need to draw our map. So we can add this action to our for loop. All the further functions that we will create, we will add to this while loop. Now let's add some units on this map and write some movement logic for them. The first function is add enemies with no parameters. This function always generates the same unit on the first row of our map. However, the enemies index will be chosen randomly. Let's start from the enemies index. I wrote enemy index equal to math.random. Eventually, we want to have the input from 0 to 4 inclusive. This function returns the number from 0 to 1, where the 0 is inclusive and the 1 is exclusive. So the actual range of this function is from 0 to 0.999. To extend the range of this function, I can multiply this function by 5. And if I want to calculate the result, I need to take both edge numbers. So the edge numbers for this function are 0 and 1. And then I need to multiply them by 5. 0 multiplied by 5 is 0 and 1 multiplied by 5 is 5. So the range that we will have is from 0 to 5. But the last number of this function is exclusive, so the actual range from 0 to 4.9999. We also want to have only integers, so math.random function gives any number from 0 to 1. But we want to have only whole numbers, only integers between 0 to 4. For that, I can round this function with math.floor. This function rounds the number down to the nearest integer. And to remember this function, the word floor can be associated with down. This function gives the range from 0 to 4.999, and if we take this last number and round it down to the nearest integer, eventually we will have integers from 0 to 4 inclusive. So I can write that this function returns any integer from 0 to 4. Then let's take the first row from our map and put the enemy on this row. Map array is a 2D array, and to access the first row of this array, I can use 0 as the index. But the row is an array that contains tiles, and I can access a specific tile using enemy index. I set the tile that we accessed by enemy index to E that represents our enemy. Actually, you can choose any letter that you like, but I choose E. Let's write a similar function for allies. I found that I named our previous function add enemies, but actually we add only one enemy, so I will rename it to add enemy. The structure of this function is the same. The first line, as we had in our add enemy function, we need to get the index. This time we don't get the index randomly, we get it from the user. For now, let's assume that the user gives a valid index, so we can skip validation. Of course, in the future, we should add validation, but now for the simplicity, let's assume that the output is valid. I want to show how prompt function works, so I will call this function in our while loop after the draw map. And now you see that we have this map in the console, but we also have a pop-up message where we can type something. So for example, I can type 0 and then press OK. And in this case, my prompt will be equal to 0. All this function will be replaced by 0, but this 0 will be a string. But in our case, there is no difference that the response is a string, because JavaScript is smart enough to convert strings to numbers in the case when we use a string as a number. For example, in our previous function, if I try to access the tile with index 0, that is a string, JavaScript can automatically convert it to a number with a value of 0. A lot of other languages can do it, but JavaScript can. This is the reason why we don't need to convert our prompt to integer. In our addEnemy function, we accessed the first row because this is the first row and we want to put our unit on a tile on this row. If we're talking about allies, we want to access the last row and to put our enemy on a tile on this line. In this case, I access the row by index 4 because totally we have 5 rows and we remember that indexes are 0 based, so it means that the 5th row index is 4. And now let's set an ally on a tile. And finally, we accessed the tile by ally index and set it to capital A letter that represents our ally. Let's think about movement logic for our units. Enemies should move down and allies should move up. Let's have a look on enemies. The logic that I suggest is to check the next tile. If the next tile is empty, we can remove our enemy from the current tile and then we can set it to the next tile. But if on the next tile is someone, we need to determine if this is an ally or an enemy. If this is an ally, we have a battle and we can just remove both units. But if on the next tile is an enemy, we have a problem. We can't put 2 units on one tile. So how to solve this problem? The solution that I found is to process units starting from the last row and moving to the first row. So for example, we have this situation where 2 units are close to each other. We can check the last row. If on this row is any enemy, we should move him down. We see that this row is clear. Then we go to the next row and we see that here is an enemy. So we should move him down and eventually this row is clear. We go to the next row. Here we also find an enemy and we want to move him down. But now we know that on this row can't be enemies because we moved them down. So it means that we can move our enemy down, or if we have a collision, we definitely know that both these units are on different sides. So we can just remove them. Now we have a plan for our function. So let's write it in our code. The name for our function is moveEnemies. This function will move every enemy that is on the map. This is the reason why enemies are plural. Then we want to iterate through each tile, but we need to start from the last one. For that, I write a for loop with a starting index of 4. During this loop, we can get each row. So let's save it in a variable. And now to iterate through each tile, you have 2 choices. You can iterate from last to first or from first to last elements. At this point, it doesn't matter. Both solutions are valid. You can choose whatever you like, but for the consistency, I would choose a for loop from last to first element. So let's save this tile in a variable. I want to move only enemies. So let's check if tile equals to E. In this case, I know that the current tile contains an enemy and I should move him down. At first, I should check if there is any collision with the next tile. Let's write a new function enemy collision to handle the logic of collisions. But we will complete this function later. Of course, we could write the logic of collisions inside of the moveEnemies function, but this is a good practice to give only one responsibility for each function. In this case, it will be easier in the future to understand what this function does, and it will be easier to debug it. When we call moveEnemies function, we only want to move enemies. We don't want to have any side effects. In our case, this function also should remove enemies if they collide, and for that, we write enemy collision function to handle this logic. We don't need to fill this function right now. All what we need is to assume that this function returns one of the 3 values: true, false, or undefined. It returns true if there is a collision, and it returns false if there is no collision. Also, it can return undefined. Undefined means that our unit should go out of this map, and in this case, we want to declare a winner. Let's process each output. If the collision is undefined, we want to declare a winner. But again, I want to write a separate function for that, because declaring a winner is another responsibility. Let's create a function setWinner, and we will provide a winner to this function. I write this function, but we also complete it later. Also, in the parameter winner, I use underscore that represents a private variable. Essentially, I put it because we already have a winner in the global scope. And in order to keep the same name, I just put an underscore. Again, we just assume that this function stops the game and declares a winner. And if we call this function, we can also add a return keyword. The return keyword also stops the function when executed. It means that on the point when this function reaches this keyword, it is finished. And we want to finish our move enemies function because we already know the winner. So there are no sense to continue our game. Now let's handle the second case, where the collision is equals to true. We also have a shorthand for this if statement, which is just collision without equals to true. So this statement implies that it is equal to true. Now we know that only enemies from different sides can collide to each other. So it means that if we have a collision, we want to remove both units. So I want to set the current tile to a hash. You might think that the variable tile contains the current tile, and this is true, but we can't change our map through this tile. We have the variable row. This variable is an array. When I access the element in this row, I actually have the string, so this hash symbol. And tile has a separate cell in the memory where he cloned this symbol. So it means that tile and this hash symbol have nothing in common with our row. So this is just a clone of one element from our row. It means that if we change this data, it will not influence our row. And this is the reason why this tile doesn't change the global map. If I want to change the global map, I actually should add this row with index of j instead of the tile, and then I should change this element to a new symbol. When I change an element in this way, I actually go inside of the row with index of j, and then I change this specific index. It also doesn't change or doesn't influence our tile. So it means that even though that I changed this row to a hash symbol, our tile is still an enemy. So when we create a new variable tile, we put a checkpoint where we clone the data from our array. And then I can change this data, but my tile will not be changed. This is as a checkpoint. I also want to cover one interesting note that is beyond of this video. If you try to store a full array into a new variable, in my case I store row in a variable row2, it will not copy and paste this array to a new variable. It will just create a pointer to the same array. All what it means is that row and row2 are actually the same variable, and if you change one, it would change the another because it is not a copy, it is just a pointer. I also can represent it in this way where row2 is equal to row and is equal to an array. So it doesn't make a new copy, it just creates a pointer, this equal sign to the same array. We won't use it, this is just for your knowledge that you can't copy arrays in this way. So let's return back to our function. So as I said, if we have a collision here, we need to change the current tile to a hash map, and then we also need to change the next tile to the hash map. For that, let's take the next row. I maximize this window to write this function. If we access the current row with the index of I, we can access the next row with the index of I plus 1. J is an index for column, so we are on the same column, so we can just use J without any changes. And now let's write our final condition where the collision is equals to false. In this case, we don't have any collision, so we want to remove the enemy from the current tile and set it to the next tile. I set the current tile to a hash symbol, then I access the next row, and now I set the next row with the index of j to e. I know that this was a difficult part, but with experience you will understand it better and it will get easier. In the previous part we wrote functions for adding units and moving enemies. In this part we will finish with ally movement and units collision. So let's start from the enemy collision. This function should return true, false or undefined to indicate the collision result. To understand the collision's result, we need to look at the current tile where our enemy is, and then we need to compare it to the next tile on the same column. As I said, we need to know the current tile and the next tile. For that, we can pass the current tile's indices to the enemy collision function. I write I and j. Then we need to take these parameters in this function. So let's also add I and j parameters. Now we can find the next row on the global map. To find the next row, I use i+1 index. So if you look at our map, I is responsible for rows. For example, we are on the tile with indices of 0 and 0. If I want to find the indices of the next tile, I need to add 1 to the current index of I. So the I index of the next row is 1. And if you look at j, I don't need to change it because we are moving in the same column. Then we have a tricky moment because the next row can be undefined or an array. For example, if we are on the last row, the next row is undefined. This is important to consider because if you try to access the undefined value by any index, you will get an error. This is the reason why I need to handle the undefined outcome before accessing the next tile. So if the next row is undefined, we return undefined. And then our move enemies function calls setWinner function and stops this function with return keyword. This is a very important point that you need to understand, that after this check, our next row can be only an array from our map. And now I can access the next tile that will have one of these values. Let's process the case when our next tile is a hash symbol. Hash symbols represent the ground of our map, so it means that we don't have any collision and we need to return false. If our next tile is equal to A, it means that we have a collision and we need to return true. And now you might think that we have one more case. What if our next tile is equal to E? Do you remember how we built the move enemies logic? Our function moves enemies down, starting from the last row and moving to the first row. So it means that if we have any enemies on this row, we move them down and then we go to the next tile. And in this way, we guarantee that two enemies can't collide. In our code, it means that our next tile can't be E. Now we have finished our enemy collision function and we can start from the writing setWinner function. The setWinner function is a side effect function. It means that it doesn't return anything, it mutates the existing data in our code. For example, our enemy collision function is a pure function because it takes the data and generates a new data based on the previous data. So it doesn't mutate our current data. Pure functions always return something. As our enemy collision function, it returns true, false or undefined. Side effect functions can return something, but their main purpose is to mutate the data. Like here, our setWinner function should set the global winner and then log to the console the message that you win or you lose. In our first line, we set the global winner to our local winner that we pass to this function. Then we compare. If the global winner is equal to E, it means that the enemy wins this game. So we have the console log that you lose. And otherwise, if the winner is equal to A, it means that ally wins and we have the message you win. We wrote several functions, but we haven't updated our game loop yet. Let's add them to the game loop and see how it works. At this point, we draw the map and then we have a pop-up message where we can put the index for ally. For example, I put 0 and then I don't see any changes. This is because when we call addAlly function, we have a break keyword after it. So we don't draw a map again. I add a new function drawMap, and now if I pass the index, you see a new map, and in the end of this map, we have A for our ally. Let's also add enemies. So after addAlly function, I will call addEnemy function. Now, if I refresh the page, I have the same message where I can pass the index for our ally, but on this time, you see that we generate a map with both ally and enemy. Then we have a function for enemy movement. So after addEnemy, let's call moveEnemies. I do all the steps again. And now you see that we have a map with both enemy and ally, but on this time, our enemy is moved to the next tile. It means that our moveEnemies function works correctly. But let's also test the collision function and setWinner functions. To do it, I remove the break keyword. I will also remove drawMap function, because when we start a new game loop, we started from the drawing a map. And now I have the same message. I will provide the index of 0. And now you see that our map have been changed, and I again have this pop-up. So I will provide another index, for example 4. Now you see that allies don't move, only enemies are moving. So now we have a state where two units are very close, and in the next cycle, the ally from the second column will be removed. And now you see that we have only one enemy and we don't have any allies on the second column. So it means that our collision works correctly. And let's make our final cycle to see how setWinners function works. Now you see that the enemy reaches the end of this map. So it means that the current winner is equal to enemy. And if I provide any index, I have the message that you lose. And this game stops successfully. We have checked all three functions and they work correctly. So it means that now we can write our movement logic for allies. Before writing the movement logic for allies, let's draw how this logic looks like. We can take the same logic as we use in enemy movement function, but in this case, allies are moving up. So it means that we need to check from the first to the last row. So for example, we start from the first row and we see that the first row doesn't contain any allies. So we go to the next row and we see that in the third column we have an ally, so we move him up. Then we go to the next tile and here we also have only one ally, and now I can easily move him up because I know that on the previous row I can't have any allies anymore. And in this way works our ally movement logic. MoveAllies function is very similar to MoveEnemies function. So let's try writing it on your own. But now let's write it together. After the enemy collision function, I start a new function. As we had in our moveEnemies function, we need to have two for loops. The first for loop for each row. And I start from the index of 0 because we go from the first row to the last row. Then I write the second for loop for our tiles. Now instead of I use J because this is the convention for 2D arrays. Then I need to check that the current tile is equal to ally. If this tile is equal to ally, it means that we want to move him up. At first we need to check the collision. Let's also declare ally collision function. We will implement it later. As in our moveEnemies function, ally collision function also can return only true, false, or undefined. So we need to process each outcome. I start from the undefined because in this case we need to set a winner and then stop this function immediately. I use the same setWinner function as we used for moveEnemies because this is a universal function and only one thing that I need to change is the argument that I send to this function. If the collision equals to false, it means that we don't have any collision, so we need to remove the unit from the current tile and then we need to set him to the next tile. I also have a shorthand for collision equal to false So I use this shorthand. For the last case, I can write else statement. Else statement means that we have the collision. So in this case, we need to remove the unit from the current tile and the unit from the next tile. Then we need to complete a like collision function. This function is also very similar to enemy collision function, so try writing it on your own. So to detect the collision with the next tile, we need to access the next tile. Next raw can be undefined, so it means that I need to process this case before I access the next tile. And now I can access the next tile. If our next tile is equal to hash symbol, we return false. And if our next tile is equal to E, we return true. With this function, the case where the next tile is equal to A is impossible. Now let's add moveAlias function to our game loop. And now let's test how it works. I start from the empty map and I have the pop-up to pass the index for an ally. Again, I pass 0. Now you see that the enemy is moving on the third column. I will put my unit there. I see that my unit doesn't move, so it means that our moveAlias function doesn't work correctly. If I look at this code, I see the reason why we have this problem. The reason that I take the next row with the index +1, but I want to move my units up. It means that I need to decrease the index by 1. Now I decrease the index for the next row. Now if you try this game, you will see that you immediately have the winner. And this is because in our ally collision function, we need to subtract 1 from the map array. I have also refactored the game loop, so you can just copy and paste it. And now let's test it. I pass 0 for the first unit. And now you see the map with 2 units. I pass another index. And you see that we have generated a new unit on this map. And also our previous units have been moved. I pass another index. And now you see that on the second column, we should have a collision. So we have passed this collision successfully, and my units from the first column have almost reached the first row. I see that enemy defends this line, so let's play a bit more. And eventually I have reached the first line and we have the message that you win. My congratulations, we have finished the first version of this game. You probably know the basic math operators used in programming. Today we will look at many other methods and how to use them in JavaScript. JavaScript includes built-in math object with constants and methods. To access them, you need to write the word math with the capital M letter followed by a dot. All elements that have the icon of a blue rectangle are constants. The most useful of them is the pi constant. The convention for constants is to be written with capital letters, and for example, we can use it to draw a circle. Then we have powers and logarithms. Luckily, we don't use them often in programming, and they work the same as in the math. I wrote math.pow, and if I hover over this method, we see the description. The first thing that we see that it is a method. Methods are the same as functions, but they are attached to a specific group. For example, pow method is attached to the math object. It is really easy to recognize them because they have dot and the name of the function. So for example, console.log, if I hover over it, we see that this is a method. However, in the speaking, the word function and the word method is used interchangeably. Then in this description, I see the name of the method, math.pow, and then I have two parameters, x and y. After each name, I see column and the type of this parameter. In this case, this is a number, and after this function, in the end, I also see column and the type of this method. This is the type of the return value of this method. Then I see a short description of the method and parameters, but actually it works absolutely as in the math. I need to pass two arguments. For example, I can pass 10 and 2. In this case, I expect the result of 100 because 10 in the power of 2 is 100. And one more example, I can pass 2 and 3 and I will see the result of 2 in the power of 3, which is 8. I also can type math.log and you will see several logarithm functions. So for example, I can use log2. And if I hover over it, I see the description that it returns the base 2 logarithm of a number. So logarithms are the opposite of the exponent. For example, if 2 in the power of 3 gives 8, logarithm 8 with the base of 2 gives 3. And I see this result in the console. Now something new, because in the school's math, we don't learn methods like min and max, but they are often used in programming. Math.min returns the smaller number from the list of the given numbers. If I hover over this method, I see that it is a method, and then I see that the parameter values is followed by 3 dots. It actually means that I can pass as many arguments as I want. So for example, if I don't pass any parameters, this function returns the infinity. If I pass a one number, this function returns the same number. If I pass several arguments, this function returns the smallest of them. Typically, we store multiple values in arrays. So let's try to pass an array. I've created the array 1, 2, 3. And I passed this array to math.min. But in the console, we see none. This is because if we want to pass an array, the array's name must be followed by 3 dots. So I can add 3 dots. And now if I save this function, it works as expected and returns the smallest number from the array of numbers. I also have math.max function. In the case, if we don't send any parameters, it returns minus infinity. If we pass only one number, it returns the same number. And if we pass multiple numbers, it returns the maximum of them. If we pass the array, we see the none. But what none means? None stands for not a number. Typically, JavaScript doesn't throw errors, but if you send a wrong argument, it can return none or undefined. If the function must return a number, it returns a none. And most of the cases, we see it when we have any errors in our code. So for example, in this case, we sent an array, but math.max can take only numbers. And this is the reason why we use 3 dots to convert the array into numbers. The same error I will see if I send a string with a name. A is not a number, and this is what this method returns. Sometimes JavaScript can automatically transform it. If I use a string of a number, it automatically converts it into a number. Then we have a group of different rounders. Math.ceil method rounds the number to the closest integer upwards. If I pass 5.5, the closest integer upwards is 6. The next method is math.round. It rounds the number using mathematical rules. So if the fractional part starts from the 5, 6, 7, 8 or 9, it rounds the number upwards. And otherwise, if there are 4, 3, 2, 1 or 0, it rounds the number downwards. The next rounder is math.floor. It rounds the number down to the closest integer. In this case, the closest integer is 5. And the last rounder is math.trunc. It removes the integer, removing any fractional digits. It actually removes all numbers after the point. We can notice the difference between math.floor and math.trunc if we use negative numbers. If I pass minus 5.5, the closest integer downwards is minus 6. But math.trunc just removes any fractional part and we have minus 5 as a result. You also can memorize that ceil, the ceiling, is located in the upper part of the room, so it rounds the number up, and the floor is located in the bottom part of the room, so it rounds the number downwards. There are a few more useful functions. For example, we have already used the math.random method that generates a random number between 0 and 1. If you want to watch a full course about math.random, I have a video on this topic. the next function is ups that returns an absolute number. The easiest way how to understand what absolute number does, it just removes a negative sign if a number contains it. Otherwise, it just returns the initial value. We use math.ups method to convert our number to a positive one. Then we have math.sign. It returns 1 if an argument is a positive, it returns 0 if the argument is 0, and it returns -1 if the argument is negative. What is a modulo operator in JavaScript? The percent sign is a modulo operator. It returns the remainder of a division. The simplest way to understand it is the long division method you learn in school. The idea of this method is to subtract the highest divisible number from the current number, and then to repeat this process as many times as we need. In the example 4 divided by 2, the highest divisible number is 4. Then I write the answer, which is 4 divided by 2, and this is 2. Now I can subtract 4 from the 4 and get 0. So 0 is the remainder of this equation, and this is exactly what we see in the console if I type 4 modulo 2. And this number is the answer of the division. In this method, this is always a whole number, so we can't have any numbers after a digit. Instead of that, we have a remainder. Now let's repeat the same process, but with a new equation, 5 divided by 2. In this case, the highest divisible number is 4, and then in the answer field, I write 4 divided by 2, which is 2. And then I need to subtract 4 from the 5, so it gives 1. And now our answer is the same, but the remainder is different. And if you look to the console, this is exactly what we have when I type 5 modulo 2. Why use modulo in programming? A very common use of modulo operator is to define a number is even or odd. In this code, we check if the number is divisible by 2 or not. If the remainder is 0, this number is even. And if the remainder is 1, this number is odd. Our current number is 5, so in the console we see that this number is odd. I can change it to 4, and now in the console we see that this number is even. Actually, we don't even need to have the second if condition. Even if you remove this code, it will work in the same way. When you use a modulo operator, the second number is called divisor, and our answer can be higher than the divisor. In the case, when you take modulo from 2, the possible outcomes are 0 or 1. And this is the reason why I can use else statement without additional checks. Also, a modulo operator is especially useful for iterations with numbers. This is a simple loop that goes from the 0 to 1000, that if the current index modulo 100 is equal to 0, we display this index. The output includes only numbers divisible by 100. We also have one very common usage, and this is time conversion. You have a total of 150 seconds. Then you need to convert it into minutes and remaining seconds. I will give 2 clues, but first try solving this challenge yourself. The first clue is you need to use math.floor function to find the amount of minutes. The second clue is that you need to use a modulo operator for the remaining seconds. Now let's solve it together. In 60 seconds, 1 minute. To find minutes, we need to divide the total seconds by 60. But a normal division gives a fractional result. We want whole minutes only. For that, we can round the number down to the closest integer, and in this case, the remainder will be neglected. I use math.floor, and now I see only whole minutes. The remaining seconds are the remainder, which is what the modulo operator returns. So now we have converted 150 seconds into 2 minutes and 30 seconds. Know some JavaScript? Let's turn it into a simple cookie clicker game. You will learn the basics of HTML and how to connect HTML with JavaScript that they can work together. I have an empty project in Visual Studio Code. Let's start from the creating index.html file. Index.html is the name convention for the homepage of your web project. So if you have several HTML files, the main one is called index.html. Let's type something. For example, hello world. Then I save this file and I use live server extension to run this file in the browser. I click go live. And now in the browser, I see hello world. If your text is too small, you can click this zoom button and here you can change the zoom of this page. So we can type a text in our HTML file and it will be visible in our browser. But we have one problem. We can't control this text. So for example, on the second line, I add a new sentence. Then I save this file and refresh the browser. And now we see that even though that I wrote it on a new line, in the browser, it is still on one line. And to control the text that we type in HTML files, we have tags. Let's close this Explorer. I just click Explorer icon. And now on a new line, I type P. Then I see a list of different options and I press enter to choose the first tag. And now you see two elements, the opening tag and the closing tag. And between them, we can add our text. And then if I save this file and refresh the page, we will see this sentence on a new line. You also have other tags for a text. For example, you can press H. From H1 to H6 are different header tags. The difference between them in the size of the text. So for example, I choose H1 and if I save this file, you see that the sentence, my header, is much bigger than other sentences. So now you know the basics of HTML. Let's start the creation of our project. For that, I delete all the content on this page. Then I type an exclamation mark. And now I see the first option, so I press enter. And now you see the basic structure of an HTML file. Let's save it and refresh the page. And now you see that our page is blank. And this is because all the elements that we see on our page should be inside body tag. All other lines that we see, they are just configuration of this file. For example, doctype.html defines the rule of HTML file. Then we have HTML tag where the language is defined. In our case, this is English. And then we have a head block. Here are different metadata that is used for accessibility and SEO, and then we have a title. This is a title for our project. Let's change it to cookie clicker. And now if I save this file, you can see that in the top of our browser, we see the name of our file, which is cookie clicker. But let's add some elements on this page. So we want to add a counter. For that, we use p tag. I press P, then enter. And I also type count 0 because we start from the counter of 0. And the second element that we have in our game is a picture of a cookie. For that, we have a separate tag image. I type img and then press enter. And now I can display the image on our website. But we actually need to have this image on our computer. So you can download it from my GitHub. For that, you can click on the first link in the description and then you will see this page. These are files from the video. So to download the image, click image, then cookie PNG, and now click download raw file. Now you need to create the same folder in this project. So I click new folder and I type image. Now I click on this folder and here I paste the image of the cookie. So I choose this image and then I just drag and drop it. And now in our folder, you see that we have cookie.png image. Make sure that this is inside of this folder. If you close it, you don't see cookie.png file anymore. So let's open it back. And I can close the cookie.png image here. Now in the source, I type image, then slash, and cookie.png. Now if I save this file, I will see an image of a cookie. We also should provide alternative attribute, and this is just a text that will be displayed if our program can't find the image. We can type something like cookie image. And for example, if I change this path, so I add 1 in the end and save this file, now you see this message cookie image instead of the picture. Let's return it back and let's change the size of this image. For that, I can add a new attribute with. After the image tag and before the source attribute, I type with. and I can type something like 100 pixels. If I save it, we have a small image, and now I can zoom this page. So now we see both the image and the counter. And when we click our image, we want to increase our counter. So for that, we use JavaScript file. Let's open the Explorer and create a new JavaScript file. I call it script.js. Now we have two separate files, so we need to connect them together. For that, in the index.html file, in the head, right after our title, I press enter and type script column source. Now I can press enter. And here we can reference to our JavaScript file. So I type the name of the JavaScript file, script.js. Now our files are connected, we can start writing the JavaScript file. The first thing that we will do in our script.js file is the copy of the counter. Generally, we don't want to take the counter from the HTML, increase it, and set it back. We want to have a separate element that is responsible for the math in JavaScript, and then if I increase this counter, I want to change this text as well. And then I increase the counter again, and I change the HTML file again. So let's write a script that will do this work for us. I return back to 0. So we know that we can increase our counter, for example, by typing count++. This line will increase our counter by 1, but we also need to set the counter in the HTML file. For that, we need to access this element in the JavaScript. In the JavaScript, we have a method getElementById that returns the HTML element or null. We pass the ID to this method, and if this ID doesn't exist in our HTML file, countElement variable equals to null. But if it exists, we access our HTML element and we can change its properties. Currently, we don't have this ID in our index.html file, so let's add this attribute to our p tag. Right after p, I type ID and press enter. And now I need to pass the name of this ID. In our case, this is count. And now I can save this file. Now in the JavaScript, we have this element and we can change this text property. CountElement has a text content property. This is the text that you see right here, and we can set it to another value, for example, to count. But currently, if you save this file, you will not see any changes. So let's inspect this page. Do right click, then find inspect property, and now open the console. You will see the error that null element doesn't have the text content property. If you hover over count element, you will see that it can be equal to HTML element or null. And it is equal to null only if we don't have this ID in our HTML file. But we have this ID. What is the problem? This is a very common problem that HTML file reads the code line by line. And when it reaches the script line, it executes our JavaScript file. And at this point, we haven't initialized our body yet. So it means that we don't have all these elements. And this is the reason why our count element equal to null. We actually want to initialize all the HTML file before the JavaScript file. And for that, we have an attribute defer that we can put after the source attribute. Now I save this file and you see that our error is gone. And if you look at our page, you will see 1 instead of count column 0. So let's add count column in our JavaScript file as well. And now if I save this file, you see that our count is equal to 1. We want to change the count only when a user clicks on a cookie. For that, we need to track the state of the cookie. When a user clicks, he changes the state of this element. And on this change, we can increase our counter by 1. So let's do it step by step. First of all, we need to access the image element in the JavaScript file. For that, I will use getElementById method. I use the ID cookie, so let's add this ID to our image tag. Right after this tag, I add ID. Then I save this file. Now I wrote a large line. Cookie element has a method add event listener. And this is a complicated method that can track the state of our element. Generally, we provide two parameters. The first parameter is what we are controlling. We are controlling the click of the user. So when this element is clicked, then we execute the second parameter. In our case, the second parameter changes the text content of the count element to a new count that we calculate in this file. If you remove the first property and add quotes, you will see all other options that we can control. I choose the click option. And when I save it, I see that our counter is equal to 1. And if we click our cookie, we don't see any changes. This is because when we provide our second parameter without wrapping it into a function, we immediately execute it. So let's wrap our parameter into a function. Now we increase our counter inside of this function, and then we set our text element to a new counter. When I save this file, you see that our counter is equal to 0. And if I click our cookie, we see that our counter is changing. Here is also one important detail. If you refer to your function, like here we have increase count name, so this is the name of our function, I don't use parentheses. If I type this parenthesis, it means that I immediately want to execute this function. So if I save this file, you will again see that our counter equal to 1. If I click the cookie, nothing changed. This small detail is very important because when you don't add this parenthesis, you refer to your function, and add event listener function can automatically call it if a user clicks on the element. So I can click cookie and my count will be incremented. But this game is very plain, so we don't have any styles. Actually, to change the styles of this game, we will use a CSS file. First of all, open the folder where your project is located, and here create a new file. I click new file icon, then type style.css. Now I can hide the Explorer. And this is a plain CSS file. So now we need to connect it to our HTML. For that, in the head, right after the title, I can write link column CSS. Then press enter. It creates a link to your CSS file with all the necessary fields. Now I can just save this file. Now I go to our CSS file, and now we can try to change something. I've changed the background of our game, so I'm sure that this file is connected correctly. So this is the basic structure of CSS. We always use a selector, which is generally a tag from our HTML file. So as you see, we have a body tag that contains all the visible elements on our page, and I use this tag to apply the property of background color. And then the value of this property is gray. As you see, we have a lot of text that explains what it does. For example, I also want to change the font color. For that, I have a color property. I type color, then press enter, and now I see the list of all options for the color. I type white. If I save this file, you see that currently our font is white. These properties are applied to the body tag. But if you look at our HTML, you will see that actually body tag doesn't have any text. It has another tag B that contains the text count column 0. And this text also have been changed even though that we haven't applied any properties directly to the B tag. When we don't specify any direct properties for the B tag, it tries to inherit the properties from the parent elements. In this case, the parent element is body. So for example, if I add the tag B, and if I change this color to another one, now we see that the text is green. And this is because we directly specified the property for the B tag. Also, I see that we have one property width that is equal to 100 pixels in the HTML. But generally, we write such properties in CSS file. So let's delete it from the HTML. And now let's apply it to CSS. So I add a new tag image. And here I change the width to 100 pixels. and now we see absolutely the same result. Actually, my elements are very small. So currently I have the zoom of 500. If you click the zoom button, you can see that my current zoom is 500. So let's reset it. And now let's change the sizes that we don't need to zoom this page. So for example, the image size can be 250 pixels. And now let's change the font size. Inside of the P tag, I type font. And now you see the list of different properties that the font has. The first property after the font is font size. And here I can use the default values like large, medium, small, or I can type pixels. For example, I put 50 pixels. I save this file and now we see that our font is much bigger. Let's try 100 pixels. I also don't like this color, so let's delete green color. So now I like the size of our font, but if you Google for any CSS code, probably you will see rems instead of pixels. Rems are also the static units, so one rem is the same as 60 pixels, but I return back 100 pixels. Then let's look at other font properties. I type font again, and right after the size, I see font family property. And here I have different font family options. For example, I can choose Arial, and now you see that our font family have been changed. Currently, the Arial font family is applied, but you see that we have provided 3 different options. If the Arial option is incompatible with the user's browser, it will try to use Helvetica. If this font size is also incompatible, it will use the last option. And if all these font family options are incompatible, it will use the default option that any browser has. So when we don't provide any font family, we also see the default option of the Google Chrome. The next property is font weight. And here you see different numerical options, as well as bold, lighter, or normal. So by default, normal is applied. So it doesn't change anything. But for example, I can use bold. And now you see that my font weight is much bolder. And actually not all the options will change something. So for example, if I put bolder, we will not see any changes. And this is because Arial doesn't have bolder font weight. All these options depends on the font weights that a specific font family has. I know that Arial has only 3 different options, so this is the reason why I can use bold, lighter, or normal. But if a font family has more options, you can use these numerical options, where 100 is the lighter option and 800 is the most bold option that this font family has. So in this way, you can discover different options. So you just type something like font, and then you see a list of filtered options by the popularity. The font size is the most popular option that we change. Then we change font family, font weight, font style, and so on. So you can discover different options to see what you can change. Now let's talk about positions of the elements. Currently, the position is in the top left corner, but for example, we want to change it to the middle. So the simplest option is to use margin. So I have margin property, then I press enter. And here I can type the value in pixels or rems. For example, I type 100 pixels. And now you see that our text have been shifted to the right side. So for example, I type 300 pixels. And currently we see that our text is almost in the middle. So margin actually adds an invisible border. If you inspect the page by right click, then choose the inspect property. Here you can inspect different options. So you can choose elements, and I can hover over P, and now you see this orange border. If I choose computed option, you will see that this is the margin of 300 pixels. And now you see that actually we have created this invisible border around the P tag. So, and this is the reason why the position have been shifted. Let's also add something to our cookie. I will also add margin of 300 pixels. And now we see that our cookie in the bottom of this page and our elements are very far away from each other. So actually I want to apply margin only to the body tag. I don't want to add margin inside of the p tag or image tags. So I delete the current margin. Now we see that our elements are close to each other. And now inside of the body tag, I add margin of 300 pixels. And now we see that our elements are around the middle of the screen. Now, if you look at body tag, you can see that we have this orange border around our elements. And you see that actually margin property applies the border from all the sides. But what you can do in CSS, for example, instead of the margin property, you can choose margin top, bottom, left, or right. It will add the border only to one side. So for example, I can choose margin left property, and now I will write 300 pixels. And now you see that our elements have been shifted from the left side, but it is still very close to the top of this page. And now if I want to move it from the top of this page, I can separately set the margin of the top. So for example, I put minus 100 pixels. And now you see that our elements have been shifted up because we used negative value. How to change the position of elements using the display flags property. We will also add an animation to the cookie when we click it. If you inspect the page by right click and inspect, you will see that our elements are not centered. And this is because we used fixed pixels to change the position of our elements. So let's delete margin left and margin top. Now we see that our elements in the beginning of the page. Also, if you hover over HTML tag, you will see that our page is only 600 pixels. So I click HTML and now I can hover over blue rectangle and I see the sizes of our page. I want the page with the same size as the user's screen size. For that, I will add HTML tag and here I define height property. In this case, I use 100 view height units. View height units are the dynamic units that depends on the height. We also have view width units. And in this case, our height will be the 100% of our width. So if I hover over this blue rectangle, I see that the width and the height are the same. But I want to use view height units. And in this case, I see that the height of our page is the same as the screen size. We can change the screen size and I see that this number changes automatically. Now I will show you how to center our objects. If I hover over body, I see that it also takes only some part of the screen, but I want our body to be with the same height as our HTML page. At first, I add the same property to our body, and now I will write the combination of properties that center our objects. Now we see that our objects are centered on this page, but you see that the alignment is different. By default, our elements are aligned in the same way as they are written in the HTML. So we have p, then image, and the default alignment is p tag with the content of count, and then we have the image. But if I use the display flags property, it changes the default alignment to the row, and I can change it with flags direction property. Now my flags direction is equal to column, and you see that our elements aligned in one column. Now let's talk a bit about justified content. This property changes the position of elements depending on the flags direction. If the flags direction is column, it changes the direction on the column. Currently it is center, but for example, I can set flag start. Now you see that the position of our elements have been changed to the beginning of the column. The same will happen if I use flags end. But I will choose flags start. Now about align items. This property changes the direction along the cross axis. So cross axes are the opposite from our flags direction. If our flags direction is column, align items changes the direction along the row. So for example, I will use flag start. And now you see that along the row, our elements have been changed to the start of the screen. So the same if I use flags end, but I want to center. If you want to learn more about this powerful tool, back when I was learning, the Flexbox Froggy game helped me a lot. Here you can read the description of different properties, and then you need to write the code that moves the froggy to the lily pad. So for example here, we need to write justify content flex end. And now we see that our froggy is on the lily pad. And in the same way, you can learn about other properties of the display flags. We also want to add a small animation to our cookie when we click it. Currently, if we click, only the count will be incremented. So at first, I think that we need to increase the width of our image. So for example, let's put 350 pixels. And actually the topic of animations in CSS is advanced. But I found the way how to easily explain you a very simple animation. Each element on our page has several states. For example, image has the default state and the active state. When I click on the image, I change the state to the active. I can click and then I grab this image, and while I grab this image, the state of this image is active. What we want to do is actually to change the size of the image when it is in the active state. Right after the image, let's add a new selector. To change the properties of the active state, I add column active to my tag. So this is a complicated selector that activates some style properties only when our image is in the active state. And for example, let's change the width to 330 pixels. And now let's try to click. So you see that we have this simple animation, and while I'm holding the image, the size of this image is 330 pixels. I see that it changes relative to the top of the image, but I want to change this animation relative to the center of this image. A very simple solution is to add a margin to the top. For example, I add 10 pixels. And now we see that our animation is relative to the center, but I still think that this is too plain. So let's rotate this image a bit. So deg means degrees and -2 means to change the rotation to the left by 2 degrees. And now if I click, you see that we have a very interesting and simple animation. But this is not the proper way how we should write animations in CSS. So the proper way of the same animation is much more complex, but I think that currently you can understand what it means. So if I click the cookie, we have almost the same animation, but this is a bit smoother. You see that we have the same image active tag that changes the scale to 92%. So we decrease the scale by 8% and we rotate the image by 2 degrees. And then we have additional transition property in the image that adds a smooth transition that lasts 0.5 seconds. Let's also remove the scrolling bar. In the HTML tag, I can add scroll bar width property with non-value. And now we see that we don't have any scroll bar, but we still can scroll it a bit. Also, when you click the cookie a lot, at some point you can hold this image. I want to remove this property, and the easiest way how to do it is actually to go to the HTML. And here I pressed Alt-Z to wrap the file, and now in the image tag right after the ID I can add draggable false. And now if I save this file, I hold this image, but I don't see the picture of this image. Let's also change the background of this page. Currently our background is gray. I want to add this custom color. You can hover over this square and here you can change the color, and then the code will be updated automatically. If I save the file, you see that we have another color, but I like this dark blue color. The same with the font color. I want to change it to a bit darker white color. Again, you can hover over it and change as you like. In today's video, you will add the feature that increases the clicking power. You can click the cookie, and if you have enough count, you can buy an upgrade. And now your clicking power is 2. So each time when I click cookie, it adds the count of 2. And we need to add buttons for increase click power and increase auto click power. It seems that we need to add only 2 buttons, but actually each text that you see is a separate HTML element. Let's start from the adding buttons. So currently in my HTML file, we have only p tag for the count and the image tag. Now I will add a button tag. Now you see that we have 2 buttons and they already have some default styles. The first problem that we have that we want to change the alignment of these buttons. If you look at our CSS file, you will see that currently our body has the display of flags with the flags direction of column. This is important to understand that our body is all the page that we see, and all elements that are inside the body will have the alignment of column. But we want to add both buttons on the same level. So how to do it? These are the elements that we have in our HTML, and we need to group them in order to change the alignment. All this page is our body, and the body should see only 3 elements. So we have to group last 2 elements in order to change their alignment. So if we inspect this page by right click, then inspect, this is the HTML code for this project. So inside of the body, we have only 3 elements: our p tag for count, our cookie image, and the section for our buttons. So when the body tag adjusts the position of elements, it adjusts only the position of these 3 elements. And then inside of the section, we can put our buttons and change the position of these buttons. To make a group of elements, I have to add a section tag. Now inside of the body, we have only 3 elements. We have our p tag, then our image, and then our section. And now when I save this file, you see that the position of our elements have been changed. Currently, the default position for buttons suits very well, but let's clearly define the right position. So in the CSS file, right after all this code, we will write the CSS in a slightly different way. All this code that we have in the CSS applied directly to HTML tags, body tag, p tag, or image tag. But if we have a lot of elements on our page, it is very difficult to manage styles. And for that, you use classes. Generally, we apply most of our styles to classes. For that, in the HTML, I add a new attribute class. In this section, I will write class, then press enter. And now I can give the name for this section. For example, I can call it shop. Then I save this file, and now I can change our styles. To access a specific style, we need to put a dot and then to write the name of the class. So in our case, this is shop. And now I can apply style properties. We want to apply display flags with the flags direction of raw. So now we explicitly defined the alignment for these elements, and if we add more elements, it will not break the alignment. Now let's add all the remaining elements. We should add all these p tags with the specific text. So in our HTML, we should add the text for our current click power. And let's also add the text for our auto click power. Now we see that our font is too big, and this is because we applied the font size of 100 pixels directly to all p tags. I don't want to change our previously written CSS, but let's change the font size of these 2 elements. This selector applies only to p tags that are inside of the shop class. If you hover over this selector, you will see that no matter which HTML element that has the class of shop and that has p tags inside will have these styles. And you see that the font size of our text have been changed. Let's also change the font weight. And now again we have the same problem that we want to align these elements in the column. So they should be above our button. All these elements have the alignment of column. Currently we have 3 groups of elements. Now in the last group we have elements that should be aligned in the row. And then these 2 elements should be aligned in the column. The same with these 2 elements. It means that we need to create 2 additional groups. And now you see that they have the right alignment, but again, we can define the explicit alignment of these elements. For that, I need to give a class for each section. So I will give the same class for them. And both these classes will share the same styles. So I added the display of flags with the flags direction of column, and now you see that we have the right alignment. For the last text elements, we don't need to create a new section, we can add them inside of the button element. In this case, we will need to write less CSS code, but it is also possible to group them with the section element, but I think that this is a slightly more complex way. Inside of our button, I delete the text, I expand this tag, and now I will add p tags with the same text as we have on this page. So now we have the text inside of our first button. Let's do the same with the second button. Now we have all the HTML elements that we need. Now let's style these elements in the same way. If you inspect this page, you will see that all these p tags has the default margin of 60 pixels. So let's remove it. I want to remove this margin only for p tags that are inside of our shop class. Now I put margin 0, but I want to add the additional space inside of these buttons. So let's choose the button tag. Again, we choose only buttons which are inside the shop class. And now I can add additional padding. Also, I want to increase the size of this button. And now I want to align our text to the left side. For that, we have a shorthand text align. So we don't need to provide the display flags property. And I also think that these buttons are too close to each other. So I want to add additional margin. But if I use the common margin property, I don't like the position of our button's title. So we want to create only this space between 2 buttons. And for that, I can use margin left. Or it is better to use margin right. So now I like the position of our buttons, but let's change the background color of these buttons. Now our buttons are too dark, so I will change the color of our font. And also I want to change the border. You can use another color. So for example, instead of this border color, you can write blue color. And then you will see the square. And if you change this color, you can see RGB color, or you can click on this header and then it will be changed to a hexadecimal code. So you can use whatever colors you like. I just like to use very specific colors, and this is the reason why I use hexadecimal code. I return back the color for our border, and I also can round our borders. And for that, I have the property of border radius. In our final version, you also can see that I have the animation when I hover over the button. Let's add the same animation. For that, I need to use a complex selector, which is very similar to this selector that we used for our cookie. This is called pseudo selector. And now instead of the active selector, I use hover selector. It triggers the body when we hover over our buttons. And now you see that the color of our border becomes a bit lighter. Also, I want to slightly increase the size of the button. For that, I can use the scale property of 1.01. So it means that we increase the scale of our button in 1%. And now if I hover over our button, you see a nice little animation. In our image, we used an active selector, which triggers the body if we click on the element. but for the animation for our buttons, we use the hover selector, and it triggers the body if we hover over the button. When I click this button, we don't have any animation, but you can add additional animation when you click on the button, and for that you need to write a new complex selector with the active selector. So something like that. You can change the color to red, and when you hover over, you see that your border becomes a bit lighter, but if you click this button, you see that the border changes to the red. But I don't like the styles for this project. I delete the active state. We also see that the color of the text in the button is different. So for that, let's add new classes for each p tag. So in our HTML, for our cost, let's add a new class cost. And for our description, I add a new class description. And the same classes I will add for our auto-click button. And now in the CSS, let's change the colors of these buttons. And for our cost, I can use the built-in gold color. And for our description, I can use the same color as for the borders. Actually, I think that our text is too close to each other, so I want to increase margin a bit. Here, when we changed the margin of our p tags, I will add a small margin of 4 pixels. And now if I compare it with the result, I see that this shop section has additional space between the cookie image. Let's add this additional space. Inside of the shop tag, I will add margin top of 52 pixels. And now you see that our styles are absolutely the same as in the result. So now we can click our cookie and we can click our button, but it doesn't do anything. So let's define the behavior of our buttons in the JavaScript file. Let's go to our JavaScript file, and here we have the code that increases the count when we click our image. So let's separate them with the comments. Now we can write the code for our click power button. The structure will be the same. As you remember, we should initialize variables in the JavaScript, and then we need to change the HTML based on these variables. So for our cookie, we initialized the count, then we accessed two elements, count and the cookie, from the HTML file. Then we wrote a function that increases the count, and then we wrote the trigger when this function must be executed. These are 4 basic steps that we need to do. So let's start from the variables. Which numbers we want to change on this page? The current click power shows the current power of our click, and we want to change this number. The same with auto click power. Also, we want to increase the cost every time when user upgrade his power to increase the difficulty. So let's add these variables into JavaScript. For these variables, I use the keyword let because I need to change these variables later. Now let's access the elements that we want to change in the HTML. For that, I will use the same document getElementById function. But to access elements by ID, we need to add these IDs in our HTML file. I want to access current click power tag, current auto click power tag, costs, and also buttons. So in the HTML file, let's add ID to all these elements. So this is our current click power, and I add the attribute ID, which is generally the first attribute after our text name. And also you might have a question why I separate words with uppercase. For IDs, I use camel case if I want to use these IDs in JavaScript. So this is the convention. For classes, I used kebab case that separate words with a hyphen because this is the convention for CSS. But if I want to use the same IDs in the CSS, in this case, it is better to use kebab case for the consistency. In this project, I use IDs only in the JavaScript file, so I use the camel case. I also added the ID for our click cost, and here is one important moment that all IDs should be unique. So if you add an ID, be sure that this ID is unique. So this is the reason why I can't use the name cost for our ID, because in this case I can't recognize the click power button cost and auto click power button cost. And also I want to add IDs for our buttons. Totally I added 6 different IDs. And now we can access these elements in our JavaScript. I added first 3 elements from our click power button. Be sure that the IDs that you write in the getElementById function matches the IDs that you set in your HTML file. Now I added all these elements to our JavaScript file, and I found that in index.html I wrote AutoClickButtons ID, but I want to change it to AutoClickButton. So be careful when you name your IDs. In the next step, I want to write a function that will define the behavior for our buttons. First of all, let's think of what we want to add to this function. So first of all, because our button has a specific cost, we need to validate if the user has enough cookies. The second step is to update all the variables that we have in JavaScript. And then we need to update the corresponding HTML elements. So now you see the steps. Try to write this function yourself. But now let's write it together. For the validation, we can use if statement. And we need to check that if the count is more or equal to the click cost. If the user has enough cookies, we can update our GS variables. So we need to update the count, the price, and the current click power. A new count is equal to count minus click cost. And for that, we have a shorthand count minus equal click cost. So we just subtract the cost from the total count. Then we can increase the click power by 1. And then I update our click cost, and for that I use the multiplier of 1.4. The initial click cost is 10, and then we multiply 10 by 1.4, so the next click cost is 14. If you want to increase the difficulty, you can change this multiplier, for example, to 1.6. Or if you want to decrease the difficulty, you can decrease this multiplier. I want to use 1.4. You also can create a new variable multiplier where you will store this value, especially if you want to use it for the auto click cost power. But I want to use 2 different multipliers, and just for the simplicity, I would hard code this value to 1.4. Now let's update the HTML elements. For the count, I have the count element from the beginning. And then we change the text content of these elements. And here we have the static part of count plus our variable. And eventually this line will be count 1, count 2, and so on. Then I want to change the click power title. The static part will be current click power, and the dynamical part will be the click power variables that we have in our JavaScript. And in the same way, we change the cost element. So now our function is finished, and the last step is to write the trigger when this function must be executed. So we want to execute this function when we click our button. So our button needs the trigger, and for that we will use addEventListener function, where we define the trigger when it is executed. So in our case this is clicked, and then we pass the function's name without the parenthesis. So if you add parenthesis to the function's name, it is executed immediately. So I use click button element. Here I add event listener. Our target is click, and the function that we must execute is increase click power. So now we can test our game. So the initial power is 1. So when I click the cookie, it increased by 1. Now my count is 10 and I want to buy the upgrade. So now I have the click power of 2, the count of 0 and the cost of 14. But if I click the cookie, the count still grows by 1. The mistake that we have in our project is related to our previous code. So in our cookie and count part, if we look at the increase count function, we can see that we actually increase the count by 1. But we want to increase our count by the click power. So let's change this line to count plus equal click power. Now I test this game again. I have the count of 10. I can upgrade our click power. And now when I click my cookie, the count grows by 2. Now my count is 14. I can buy a new cost. Now you see that our cost has a lot of decimal numbers. Let's round the cost to the integer. For that, in our increase click power function, we can add the math.round function. So this function rounds our number to the integer using the mathematical rules. And now if I test our game again, it works correctly. We already have added the click power upgrade button, and now we can earn cookies and buy upgrades to increase the click power. Let's implement the auto click power button. In our JavaScript file, we have several sections. The first section is responsible for cookie and count. The second section is responsible for click power button. In the end of this code, let's add a new section that is responsible for the auto click power button. And we will build it in the same pattern as we built our click power button. So we have variables for JavaScript, then we access the HTML elements, then we have functions, and then we have triggers. The first thing is that I already have added the variables and HTML elements for the auto click button. Let's bring all these elements into a new section. So now we have two variables that are responsible for the autoclick, and we have 3 HTML elements that we will change. So now we need to write the function that would increment the autoclick power, and then we need to attach the trigger to the autoclick HTML element. Try writing it your own using the same pattern that we used for the click power button. But now let's implement it together. Let's start from the function. I call my function increase autoclick power, and here we need to do the same steps. So the first step will be the validation. In this step, we need to check that the user has enough cookies and he can buy this upgrade. The second step is to update the JavaScript variables. And the last step is to update our HTML elements. So let's start from the validation. In the validation, I check that the count is more or equal to autoclick cost. And if this condition is true, we subtract the autoclick cost from the total count. And now we can update JavaScript variables. We do the changes only inside of this if statement because we don't want to update anything if the user doesn't have enough count. Here I increase the autoclick power by 1, and now I need to set a new cost. So we want to increase the difficulty, and for that I will use a multiplier for the autoclick cost. In the increase click power, we used the multiplier of 1.4, but I think that the difficulty of the autoclick cost should be higher. And this is the reason why I will use the multiplier of 1.6. So here you can change the multiplier if you want to change the difficulty. Now we are ready to change the HTML elements. For all our variables, we have the responsible HTML element. It means that we need to change the corresponding HTML elements. So the first element is for the count. I assign a new text content, and this is the same update as we did in our increase click power. Then let's update the autoclick power. And here I need to be sure that this text that I add is the same as we used in our HTML. So let's check. And I see that in the HTML I have current autoclick power, then column, space, and 0. So here I use the same pattern, current autoclick power, column, space, and our dynamic variable. And the last element is autoclick cost. So now our function is done and we are ready to write our trigger. So again, we need to write our trigger because currently our button doesn't know what to do if we click it. And for our trigger, I will use add_event_listener as we did it before. So now we wrote our trigger and we can test how our function works. So my count is more than 50 and now I can upgrade my autoclick power. So we see that our UI elements have been updated and we see that our current autoclick power is 1, the previous was 0, and a new cost is 80. But as you see, it doesn't influence our game because we didn't write a function that will repeatedly click our cookie. After some interval, autoclick works in the way that after some interval, it clicks the cookie. So for example, our interval is 1 second. So after each second, it clicks the cookie. For that, in JavaScript, we have a function setInterval. I write the name setInterval and the first parameter is the function that we want to execute. If we look to the top of our file, you will see that after each click, we invoke the increase count, but increase count depends on the click power. We want to increase our count based on the autoclick power. And for that, we need to write a new function, increase count by autoclick. Let's write this function after increase autoclick power. So here I increase the count by autoclick. And then I update the HTML count element. And now we can provide this function to the setInterval. And the second parameter is the amount of milliseconds after which we want to execute our function. If we want to execute it after each second, we need to provide 1000 milliseconds. And to test how it works, we can add a new console log in our increase count by autoclick power button. So now if I inspect this page, in the console, you will see that we have the click message that appears in our console. So it means that from the beginning of our game, we execute this function once in a 1000 milliseconds, and this function adds the autoclick power to the count, but our autoclick power is 0, so the sum of our count remains the same, and this is the reason why we don't see any changes in our web. But if I earn enough cookies to buy this upgrade, now I see that our count starts to increment, and at the same time I can click as well. Now I have enough cookies to update our autoclick power, and now you see that we earn 2 cookies per second. My congratulations! Now you have built a working cookie clicker game with both upgrades and an autoclick feature. Learn objects in JavaScript. At first, I will show you the example why we need objects. Let's start from variables. We will create an enemy and a hero. Both of them have health points and damage. And now let's create a function where both these units can fight. So I create a function battle, and here I decrease the HP of hero and HP of enemy. New hero HP equals to the current hero HP minus enemy damage. We also have a shorthand for that, which is just hero HP minus equal enemy damage. Now let's do the same with enemy. And finally, I want to log the result to the console. And now let's call this function. Now we see the result of the battle in the console. So now we see the result before the battle. So hero health is 100, enemy health is 50, and then the result after the battle. But what if we want to add a new hero or new enemy? So for example, let's add a new enemy. And now I must modify my function to add this second enemy. And now we see the result in the console. But do you see how many changes we need to do? to just add a new enemy. This logic is the same. The logging logic is the same. I need to write very similar lines where the only change that we have is the data. So now let's delete it and let's try to do the same thing with objects. Let's create a hero object. I start absolutely the same as I declare a variable. And then to show that this is an object, I have to put curly braces. And now inside of the curly braces, I can add new properties. So let's add HP. And if I write in this way, you will see a warning that did you mean to use column? Because when we declare properties inside of the object, we use column instead of the equal sign. And in the end of this variable, I put comma, and now I can add a new property, for example, damage. If the property is the last one, we might leave the last comma. But I really recommend you to always put this trailing comma, because if you want to add a new property and if you leave this comma, you will see an error. And if you hover over this red wiggle, you will see that comma expected. Now let's add an enemy object. So I declare a new object, and here I can use the same names for the enemy properties. And we don't have any naming conflict, because if you try to access HP, and if you just type HP, it means that you have declared a variable somewhere outside of the object. And you must declare it in the global scope. Only in this case you can access HP. But to access HP from hero, you must write the parent's name, hero. Then you put a dot, and then Visual Studio Code gives you a list of all options that this object has. So for example, here I see HP. If I want to access the HP from enemy, I write the parent's name enemy. Then I put dot. And here I see a new list of all possible options. And eventually you see that you can differentiate both these HPs because the parent's name is different. And now let's also write the battle function, but instead of the hard coding all the possible variables inside of the battle, let's declare the attacker and defender parameters. And now I can write that the defender HP is minus equal attacker.damage. And then I can also log the result to the console. And now let's call this function. And now you see that we must pass attacker and defender arguments. The attacker is enemy and the defender is hero. And now you see the message that defender health is 85. So, but here we don't actually understand who is a defender. Let's also add a name property to both hero and enemy objects. And now in the battle function, instead of the writing defender, we can call defender.name. And now you see that we have hero health is 85 in the console. Now let's call the same function with other arguments. Now the attacker is hero and the defender is enemy. And now you see absolutely another message in the console that enemy health is 40. And now think how to create the same function with variables. It is possible, but the function will look like. Now you need to declare all these parameters separately. So this function will have 6 parameters. And now imagine how difficult to read this function when you have so many parameters. And the main disadvantage that if I want to add a new property, so for example, I add speed, in this case, I also must change the parameters of my battle. So somewhere here, I need to add hero speed. And then if I call this function in my code, I also have to add the speed there. So you add a lot of additional code that is very difficult to maintain. And for that, instead of passing all these properties separately, you add them in the group that calls object. And then you pass the entire group as attacker, defender, and then you can access these parameters directly inside of the function. So if I want to access the speed in the battle, all what I need to do is just add this line in the function. And that's it. I don't have to pass a new argument to this function. Now write a new object healer that has name, HP, and heal properties, and then write the function heal, where the first parameter is a healer and the second parameter is a healed. So try writing it your own using the same code pattern as we used before. But now let's write it together. So let's start from the healer object. And now I write all these properties. So now instead of the damage property, I wrote heal property. And now right after our battle function, I add a new heal function with two parameters, healer and healed. And now I need to increase the health of the healed by the heal of the healer. And then I also log the result to the console. Let's also delete the speed from the battle function. And now let's call the heal function. So the healer is the healer and the healed is our hero. And now we see another message that hero health is 90. Let's also heal the enemy. And now we see that this function works correctly. Now we stored only simple data types in the object, but we can also store functions. So for example, let's create a new function sound in our enemy object. I start from calling the name of this property, sound, and then I declare a common function, but I omit the name of this function because the name of this function is sound. And here I can write something like console.log and a sound. And now if I want to access this property, I can write enemy.sound, and I also must put parentheses if I want to execute this function. And now we see the sound in the console. Let's also put the comma after sound. Can you write the function regenerate that increases the health of this enemy by 5? Use the same pattern as for sound, but let's write it together as well. I start from the name of this property, then I declare a function, and now I want to access the HP of this enemy. So I can write enemy.hp. For this case, when you want to access properties from the same object, we have the keyword this. Instead of writing enemy.hp, I write this.hp. And now it refers to the HP in the enemy object. And now I can increase it by 5, and if I want, I also can log the result to the console. And you can write it as enemy health is plus this.hp, but in this case, if you change the name of this enemy, you also should change the name in this function. So let's declare this name dynamically. And now let's call this function. Right after my sound, I write enemy.regenerate. And now we see that the previous health was 45, and after the regenerate function, the enemy health is 50. Practice JavaScript objects with these code challenges. In the previous video, we covered the basics of objects, but today we will clarify one more concept you will need for these challenges. So I start from the blank script.js file, and this is my HTML file that is connected to the script.js. Let's recall what are objects in JavaScript. Object is a data structure that contains key value pairs. When we declare objects, these are not variables, these are properties. So this is actually a pair of string banana to a number 1. You also can declare the string with quotes as a general string, but in JavaScript we can omit these quotes when we declare a property. I have two objects, fruit1 with the explicit string banana and fruit2 with the string banana without quotes. And if I log both these objects to the console, we see that they're absolutely identical. So I can expand them. You see the key banana and the value 1, and the same you see in the second object. And one more thing that you need to know, that there are two main methods how you can access the value of an object. The first method you know, after the name of the object, you put a dot, and now you see the list of all properties that this object has. So we can choose, for example, banana, by pressing enter, and now if I save this file, you see the value of fruit1 banana, which is equal to 1. This method suits very well if we know the exact name that we want to access. But what if the name is stored in a variable and we want to access values dynamically from the variables? So I also can access the same value by putting curly braces. And here I can pass the name of our key. Here I must use quotes if I want to pass a string. And as you see, we have 1 in the console, or I can pass a variable. And as you see, it also works. So if I hover over key, you see that this is a constant that has the value of banana. But in this case, if the variable doesn't exist, we have an error that the variable key is not defined. So it can be tricky that sometimes we use quotes and sometimes we omit them, but with experience it will be easier. So just remember that if you use key value pairs inside of the object, you can omit quotes for the key strings. So you can't omit it if you use it in the value. If you want to have the value with the type of string, you must put quotes because this refers to a variable. And as you see, we again have the same error that variable myBanana is not defined. So you must put quotes if you use strings as a value of your object. For this challenge, I made a file where you need to complete all methods. So as you see, you have different methods that don't have any body and you need to implement them. And then you have different logs where I call all those methods, and you also see comments with the right results. So let's go to our index.html file. Here I change our script to mol.js. And now you can see the initial result in the console. To get this file, you can go to the description of this video, and there you will see the first link on the GitHub. I will also add this code to the comments of this video, so you can just copy and paste it from the comments of this video. So in this challenge, you have the initial inventory with different elements and with the initial values of 0. In the code, you see that you have an object inventory with the initial properties of water, fire, air, and earth. And the first method that you need to implement is add elements. This method has one property list that can contain different elements. This can be valid elements that you have in the inventory and absolutely random elements that you must ignore. And then for each element in the list, you need to increase the corresponding value in the inventory object. So as you see, we have 1 water essence in our list. So I increase water by 1. We have 2 air essences in the list. So I increase the air value by 2. As you see, we have many logs in our console. So let's comment out all the logs that currently we don't need. The first log is part 1 build inventory. So this is just a title. Then we call the function add elements, and then we log to the console the result. So this is all what we need. And currently we can comment out all the remaining code. And now you see in the console that inventory after add elements, and then we have our initial objects with the value of 0. Try writing add elements method your own, but now let's do it together. So we have a list of elements and we need to iterate through each element to increase the count in our inventory. So let's start from the for loop. So this is the most common for loop to iterate through each element in the list. I have a variable element. Then I can write an if statement where I compare the name of the current element with all the valid elements that we have. The first variable name is water. And if this element is equal to water, we need to increase the count by 1. So I can just write water. And if I press enter, that VS Code automatically adds this keyword before the water, and it means that we are referring to the property that is declared inside of this object. And now we can increase it by 1 by writing plus equal 1 or just plus plus. Then let's do the same with all other elements. So now I wrote if statements for all the remaining elements, and if you look to the console, you will see that we have 2 water, 3 fire, 2 air, and 2 earth essences. So let's scroll a little bit down to see the right answer. And here you see that inventory after add elements has 2 water, 3 fire, 2 air, and 2 earth. So it means that our function works correctly. The next method that we need to implement is add element. So let's comment out all the part that is responsible for add element method. And now we see a new log that inventory after add element. And currently we see absolutely the same result because this function haven't implemented yet. So here you should add only one element to the inventory object. And you also ignore invalid elements. So the simplest solution is just to copy all these if statements and paste them into this function. And now if you look to the console, you will see that we added some elements. So it works, but do you see how many repetitions we have? So we have 4 if statements which are the same. Only one thing that we change are the names that we check. Now let's try writing it in a correct way when you do it in one if statement. So think how you can access the object by a variable that is sent, and as always, try implementing it your own. So I delete all these if statements. Do you understand what means line this element? So in the beginning of this video, I showed you that you can access values of the object using the variable. And here we do the same thing. So this refers to the inventory object that has 4 different properties and 3 different methods. So then we pass the parameter element, and we know that this is a string. So this is the same as passing string into inventory. In this case, you get the count, the number of elements that you have in this object. So we just change the inventory to the keyword this. And then instead of passing a literal string, we pass the variable. So, and this variable gives us a number. And now we can increase it by 1. So if I save this file, you will see that now inventory after add element also added some elements. So this one line replaces all these if statements. But we still have one bug that is difficult to notice. Element is a random string. So for example, this is a string with a name that we don't have in our inventory. What this line does if we pass a random string? So instead of the element, we pass papaya string. And if you look to our inventory, you see that we don't have this pair. When you don't have this name, JavaScript automatically creates a new pair with the default value of undefined. So when we access this with the string papaya, we get undefined. And then we try to increment the undefined. When we try to do any mathematical operations on an incorrect data type, we have the result none, which stands for not a number. And now let's look to the console and let's expand this object. And now you see that we have a new pair papaya with the value of not a number. So to fix this bug, we need to handle the case when we have a random string that gives the value of undefined. Now we increment our value only if this value is not equal to undefined. Let's open our object again, and now you see that we don't have papaya pear anymore. Now let's continue with our takeElement function. So let's comment out all the code that is responsible for this part. And now in the console we see a new log that inventory after takeElement, and you see the same inventory as you had before. As always, try implementing this method your own, but now let's implement it together. So the method takeElement is very similar to addElement, but instead of increasing the count, we decrease the count. And we also need to handle one case when the count is equal to 0. So in this case, we should write the message that you don't have this resource. Look how I call this function. I call inventory takeElement fire, it decreases the count, then I pass banana, and in this case this is invalid input, we do nothing. Then I pass air, and on the third time we hit 0, so it means that we need to write that you don't have this resource. Once again, if we have undefined, like we pass banana and we don't have this in our inventory, we just do nothing. But if we pass air and we have it in our inventory, just the value of air is equal to 0, we show the message you don't have this resource. So I start from the same if statement to check if this value exists in our object. This value might be 0. And 0 is not equal to undefined. So let's handle this case as well. So if this equal to 0, we need to log the message to the console that you don't have this resource. And here we also need to write else statement. That means that we have this value in our object and the count is not equal to 0. So in this case, we can decrease the count of this element. And now let's compare it to the answer. So we had the fire of 4, then we take one fire, and now we have fire equals to 3. Then we take banana, so this is invalid input, and we just ignore it. And then we had 2 airs, so we can take 2 airs. But on the third one, we hit 0, and we display the message that you don't have this resource. And the final result is the same. So we have 4 water, 3 fire, 0 air, and 2 earth. So if you scroll a little bit down, you will see that the second part is commented out. And now in the console we see that craft potions and then craft results undefined, 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 and inventory after crafting, and currently it has the same inventory as we have above. So here we need to implement only one function, craft potion. Here we have some recipes. So for example, this is the recipe for the speed potion. So it requires 1 water and 2 air essences, and the function itself has 2 parameters, potion name and inventory. So here's the example how it looks like. So for example, you want to craft a power potion. For that you have a recipe with 2 fire and 1 earth essences. And eventually you return an object which is a potion. In the code it looks like this. You have a simple object where you have only one pair, the effect name and the value. So then you have 2 parameters, the recipe and the inventory. And this function should update the inventory and craft a new potion. For example, we had 5 fire essences. Our recipe requires 2, so we update the inventory and now it has only 3 fire essences. And also you should check that if in the recipe is more resources than in the inventory, you just show a message that you don't have enough resources. As always, try solving it your own, but right now, let's solve it together. So the first point that we have is to craft a potion using the recipes. And we also must ignore invalid names. So for example, if I ask for regenerate potion, but we don't have this recipe, our function does nothing. So I start from checking that our potion name is in our list. So I check with the first name, which is a speed potion, and if our potion name is speed potion, we need to craft this potion. So I craft a new potion and then I return it. But we also need to update the resources in the inventory. So before crafting the potion, let's update the inventory. Our recipe needs 1 water and 2 air. I subtract 1 water and 2 air from the inventory. But we also need to check that there is enough resources in the inventory. So now I check that the inventory contains more than 1 water and more than 2 air. I compare it using the more or equal operator, because even if we have only 1 water, we anyway can craft this potion. But if we don't have enough resources, we need to show the message. And now if I save this file, you see that the craft result is still undefined, but now we have the message that you don't have enough resources. And this is because in our previous log, we had 0 air, so we can't craft this potion. Now let's write the same pattern for the power potion. So I write that if the potion name is equal to power potion, and now let's copy this recipe and paste it above this part, so we can easily see which resources we need. Now I check that the inventory has more than 2 fire and more than 1 earth. Then I update the resources and craft a new potion. Now in the console, in the craft results, we see a new potion with a damage of 5. And also we see that before we had 3 fire, but now we have 1 fire. And the same with earth. We had 2 earth, but now we have only 1. Now I think that you can do the same for the third potion. I wrote the part for the health potion, and now as you see we have craft results undefined, then our power potion, and then our health potion. And now in the inventory after crafting, we see that all resources have been updated. I also found that I forgot to add this message, so I update my power potion and health potion parts. And as you see, this is not the best way how to write a function, because we have many repetitions. So the same line, you don't have enough resources, repeats 3 times, and the pattern for each part is the same. But I think that this is much easier to understand how this function works, and with experience, you will learn writing better functions. So ideally, this function shouldn't be updated if we add a new potion. But currently, if we want to add a new potion, we need to update this function as well. Primitive or value data types versus reference data types. Maybe you have noticed this before. I have the same object inventory and then I log it several times. And between these logs, I have a change. In our case, I add 1 air. And from the first point of view, it seems that nothing strange. The first object values are 0, and in the second object we see air equals to 1. But if I expand it, you will see something strange if you don't know what are reference data types. You see that our air is equal to 1. For understanding this problem, let's start from the primitive data types, which also calls value data types. Numbers, strings, boolean, undefined, and null are primitive data types. So they are stored somewhere in the memory, and when I create a new variable, for example, let n equal to 3, I allocate some memory for this variable n, and then I go to the pool of all primitive data types. Here I can find 3, and then I copy and paste it into the memory of the variable n, which has its own data cell in the memory with the duplicated data of 3. And now I declare the second variable m that is equal to n. So in this case, JavaScript tries to find the variable n. We see that we have this variable, then it looks to the data of this variable. Variable n contains a number, which is a primitive data type. And in this case, we allocate a new memory cell to the variable m. And then we copy and paste the value from the variable n. And now we have 2 different variables with duplicated data. So in the real memory on your computer, you have several cells with the value of 3. And this is a very straightforward and logical way how we create new variables. So each variable has its own memory with some data. What happens with reference data types? Arrays, objects, and functions have reference data types. For example, I want to create the variable t, which is an array of values 1, 2, and 3. And the beginning is absolutely the same as with primitive data types. And some difference I can see only when I want to create a new variable p, which is equal to t. So in this case, JavaScript tries to find the variable t, then it looks to the data type that this variable has. In our case, this is an array, which is a reference data type. So, and at this point, JavaScript doesn't allocate any new memory for this variable. And then we just put this variable in front of the previous variable. And it means that both these variables, p and t, share the same memory. I did the same steps in the code. So we have the variable t, which is an array of 1, 2, and 3. And then we have the variable p, which is equal to t. And now I log to the console both these variables. And at this point, we see that both these variables has the same data. So we have a feeling that p just cloned the data from t. But then I add a new element 4 only to the t array. And then I log to the console both these arrays again. And now we see that even though that I pushed only to one array t, both arrays have been changed. And this is because they share the same memory. If I really want to create a new array with the same values, I need to copy an entire array with all these values and paste them to the second variable. And in this case, we see that my push to array t affects only the t array. And if I expand logs, you can see that the first array, which is t array, contains 4 values, and the second array, which is p array, contains only 3 values. And now it means that they don't share any memory. Also, a small clarification why we see different data in the log if we expand it. When we create a new array and then log it to the console, here we see the snapshot of the current state of this array. And if I expand it, I see the actual state of this array. So the lastly changed state of this array. So I add a new element 4 to this array, and now I see 2 different snapshots of the same array. But if I expand them, they contain the same data because this data refers to the actual state of this array. Now let's do a small quiz to check your understanding of this topic. You can pause the video and think as much as you need. The first question is, which data type has null in JavaScript? Null is a primitive data type. So what about true? True is also a primitive data type. Now I will show you a small snippet of code and you need to answer, do these variables share any memory or not? These variables don't share any memory. The first variable is my variable, which contains the number of 22, and numbers are primitive data types, so it means that when the variable num is equal to my variable, we actually copy and paste the value of 22 into a new memory cell. And we also have a variable myArray, which is equal to an empty array. So this is a reference data type, but it doesn't share this array with other variables. So it means that we don't have any shared memory between these variables. Now what you can say about these variables? These variables also don't share any memory. All these variables contain reference data types. However, numbers contain an array and it doesn't share it with anyone. Object 1 and object 2 contain objects. Even though that the data is the same, they are allocated in different memory cells because we manually copied an entire object. And we can easily prove it by adding a new element to the object 1. So before my logs, I add a new property letter with the value of a to the object 1. And now in the console we see that object 1 contains 2 properties, number and letter. And if I expand it, we also see both these properties. And object 2 contains only one property, number. number. And when I expand it, you see only one property. These objects can share the same data, but it happens when I write that object 2 is equal to object 1. So here, instead of the data of the object 2, I type that this is equal to object 1, and now they share the same data, and in the console you see that even though that I changed only the object 1, both these objects have a new property. Learn classes in JavaScript. In the previous episodes, we learned about objects. So here I manually created a new object enemy that has two properties, HP and damage. But what if I want to create many objects and I want to create them dynamically? So for example, in the beginning, I don't know how many objects I need. So for that, we can use classes. So like in this example, class is a building that generates objects. So for example, here, this class generates 5 different units and they are all very similar. For example, this unit has a sword and shield. This unit has another sword and the same shield, and this unit has the same sword but another shield, and so on. So all these objects are very similar and there are many, so we can dynamically create them. Let's write a class for this object enemy. For that, I start from the keyword class. Then I write the name of this class. Typically, we start from capital letters. So I will write enemy with a capital letter. And then I put curly braces. So and now inside of the class, I can define different properties. So let's define HP and damage. So you see that both these structures are very similar and there are many mistakes that you might have. So let's quickly cover them. So for example, when you create a class, you add an equal sign. And in this case, you will have the error that curly brace expected. So when you have this kind of error, you need to understand that you need to remove this letter that has this kind of error. In our case, this is an equal sign. So let's remove it. Also, as you see, we define properties differently. So we define them absolutely the same as common variables, but we don't use let or const keywords. So for example, I defined HP and damage variables, and now you see that in the same way, we define properties inside of the class. What happens if we try adding let or const keywords? If I add let, you will see that this is unexpected token. And if I add const, you will see that const modifier can only be used in TypeScript. And also let's cover what if you change equal sign to a colon. In this case, you will see that type annotation can only be used in TypeScript. So in the future, when you learn TypeScript, you will understand what it means. But currently, you need to understand that you need to remove your colon and replace it with an equal sign. But typically, we don't hard code values inside of the class. So we want to pass our values dynamically, and for that, we are using constructor. So let's remove these values. So here we keep only keys of our pairs. As you see, they are the same as we have in our object. And then I write the keyword constructor. And then I put parentheses and curly braces. And now inside of the parentheses, I can pass all these values. So I need to pass a value for our HP and the value of our damage. And now you need to clearly differentiate them. Even though that the names are the same, these names are referring to the name of the key. So this is the same as in our object, you see HP and damage are the names of these pairs. And these names that you are passing into the constructor are the values. So they represent 110 from our object. And then you assign these values to the keys. For that, I am using a typical construction, this.hp, which is referring to the key that is defined inside of the class. And then this is equal to hp, and this is the parameter that I pass to the constructor. And let's write the same for the damage. And this is how a typical constructor looks like. So if you want to add new properties to this class, here you type the name of the key, and then you type the same name to the constructor, and this would be a value of this pair. So now let's generate our object using our class. So the name of this variable is enemy from class, and then I need to write a keyword new, and then the name of the class. And then I also add parentheses. And now you will see that you have several options, so we can pass HP and damage, and these options are the same as we defined in the constructor. So at first, let's log to the console this object. And now you see that we have an object with two key value pairs. So the first key is HP and the second key is damage, but we haven't passed any values for these keys, and this is the reason why they have default values of undefined. And even if I expand this object, you will see that these values are undefined. So now let's pass the real values. And now you see that we have the same object as we defined above our class. So let's also log to the console our manually created object. From the first view, you see some difference. So our object that is generated from the class has the name of this class. But if you expand both these objects, you will see that they both have the same key value pairs, and also the third option is prototype object. So it means that the type of this variable is an object. Now to show you the power of classes, let's create a function that generates 100 enemies. So I define a new function generate 100 enemies, and here I will create a for loop for 100 iterations. And now I can create a new object and then log it to the console. And now let's call this function. And in the console you see that we have 100 units, but currently they are all the same. So actually we can change the values for HP and damage for each unit. So for example, instead of the damage 10, let's use our variable I. And now you see that all units have different damage. So let's do the same for our HP. And now in the console, we have 100 different units. Once again, let's talk the difference between class and object. I log to the console our class and object enemies, and now you see that a class is the constructor for our objects. And the result that this class returns is an object. So what you can see that if I log to the console enemy from the capital letter, you see that this is a class and we just see the block of code. So we can't do anything with that. Then I'm using the same class for generating a new enemy object. So when I'm talking about objects, I'm referring to the variables. And when I'm talking about the class, I'm referring to this block of code that starts from the keyword class. Now we stored only properties in our class, but we also can store methods. So methods are functions that are defined in the class. For example, let's create a new method getHP. As you see, I don't use a keyword function, I just write the name of the method that I want and then I put parentheses. And when I put parentheses, VS Code can automatically detect that this is a method and the full name of this method is enemy.getHP. So this is the reason why we can have the same methods in different classes. So let's create a new object and then call this method. Now I called our method getHP, and as you see in the console, we have the result of 100. These kind of methods that are returning some properties from the class are called getters. Now let's write a function that assign a new value for our properties. So this function is called setter because this method assigns a new value for our property. So, and as you see, it works absolutely the same as our constructor. Our constructor is the default setter for our class. And now we can use this function to assign a new value for our HP. And now you see that from the first log, the HP of our enemy is 100. So this is what we defined in our constructor. And then I set a new HP for this enemy using the setter. And in the second log, you see that our HP is 150. So it means that our HP have been updated successfully. Also, there is one rule that you need to know. When you type the name of the object and then put dot, you will see the list of all properties and methods that this object has. And you shouldn't access properties outside of the class. You should access only methods. Even though that I can access damage property and then I can set a new value for this damage, I shouldn't do it. This code will be much more difficult to maintain in the future. So every time when I want to assign a new value or when I want to get the value, I need to use getters and setters. I have one trick for memorizing this rule. So inside of the class, you can access properties and you access them using the keyword this. So for example, in our getter, we have this.hp and then in our setter, we also have this.hp, which are referring to the property that we have inside of this class. And when you access a property using this dot and the name of the property, you are good to go. You don't break any rules and this is a secure way of changing your properties. But then outside of the class, you see that I can't write this dot name of the property. I write the name of the class enemy, then I put dot, then I write the name of the property damage. So when you see this construction that you are accessing properties using the direct name of the class, you need to understand that you are breaking rules. Instead of the writing enemy.damage, you should write enemy.getDamage method. And now let's define this method inside of our class. And once again, inside of our class, I access damage using the keyword this, so it means that I don't break any rules. And for practicing this rule, let's write a new function battle. And for this function, I want to create two units, an ally and an enemy. We can create a separate class for ally. But in this case, you will see that we have two very similar classes. So we have a lot of repetition. In order to prevent this repetition, we can create both units using our first class enemy. And as I want to create ally and enemy, let's change the name of this class to a more generical name, something like unit. And now it means that this class can generate all kind of units that we need for our battle. Now let's create both these units. Now I have two different objects using the same class unit. And now let's imagine that our enemy hits first, so we need to decrease the HP of our ally. For that, I type ally, and then I want to change the HP of this unit, so I shouldn't access property. For that, I have a method setHP. So let's use this method. And now from the initial amount of HP, we want to decrease the damage of our enemy. So for accessing our HP, I'm using the getter. And for accessing our damage, I also use a getter. Then let's imagine that our ally hits the enemy and now we need to decrease the HP of our enemy. I also use setHP method and here I access the initial HP of our enemy and then I subtract the damage of our ally. And now let's log to the console our units and then call our function. And now you see in the console the initial HP of our units, and then you see that they have been decreased by 20 and 10. This is also difficult to differentiate who is an enemy and who is an ally, so let's create a new property name inside of our class. So I want to have the first property name, and this is the reason why I will add it in the beginning of our properties. Then inside of the constructor, I also add this parameter. So the order of my properties and parameters are the same. And then I assigned our name to a new value. And now when I generate our objects, let's also write the name of this object. And now in the console we see that the first unit is our enemy and the second unit is our ally. So we can easily differentiate them. Practice classes in JavaScript with a mini battle game project. You will need to use the skills from the previous video. So in this project, you have a one button attack, and if I click it, you see a log in the console. So player attacked enemy HP is 90, and enemy attacked player, so player HP is 100. And if I continue clicking this button, you will see how the HP bar goes down until the enemy is dead. This is the basic setup that we have. This is our HTML file and it will use style.css and script.js files. So style.css right now is pretty simple, and I think that you can understand here everything. So here we have font family, some colors, basic alignment, and also we have cursor to pointer. So when I hover over a tag, you see that the cursor changes to the pointer. And also we have a text alignment, which is center. So this is a shorthand. Instead of writing display flags and then justify content center, you can write text align center for the text. And I also have fancy.css. This is a complex CSS that makes this game much more attractive. Eventually, when you finish with your JavaScript, you can switch the style.css to fancy.css. And in this case, you will see this fancy look of a simple game. But we will not go into details how fancy.css works, so you can just download it from the link in the description. Right now, I return back to style.css, and now we can be focused on our JavaScript file. So JavaScript has a default class unit with 3 properties, name, HP, and damage. And then you have 6 to-do comments that you need to implement. During this video, I will explain you what a certain to-do means, and then you need to try implementing it your own. And after that, we will implement it together. So let's start from the first to-do. Here you see that you need to implement player and enemy objects using the unit class. For that, you need to create 2 variables, player and enemy. And then you need to use our class for implementing these units. For the HP and damage, you can put whatever parameters you want. Let's start from creating the player. So I write const player equal to new unit, and then I have 3 parameters that I need to fill, name, HP, and damage. So for the HP, I choose the number 110, and for the damage, I choose the number 10. You can choose other numbers if you want. And let's do the same with the enemy. In my case, enemy has 100 HP and 10 damage. So the first to-do is implemented. Now let's continue with the second one. In the second to-do, you need to get HTML elements, and in the parentheses, you see the exact elements that you need to get. So what we see in the web is just an HTML. And in JavaScript, we need to access all these elements separately. So what we need to access? During our game, we want to access player HP, enemy HP, and also we want to set our trigger to the attack button. So if you look to our HTML, you will find all these elements. So let's start from the HP, and now you can see that inside of the P tag, we have a new span tag. So what it means? So span tag is just a helper in HTML for accessing the number HP that is inside of the P tag. For example, if I delete it, you will not see any changes. But in this case, I need to access an entire string, so an entire P tag with the static part HP column. But there is only one thing that changes, so the number, player HP. And this is the reason why I put a span tag with the ID player HP. So now we can access this element in JavaScript and then we can update it. So the same I have with the HP tag for our enemy. Almost in the end of this file, I have a new P tag with the ID log. Currently this is empty, but we can write something. And now you see that when we add a text to this P tag, it is displayed on our page. So we also need to access this tag because we want to write different messages when user clicks on the attack button. So for example, we want to write that player attacks enemy and enemy attacks player. Now try implementing the second step using getElementById methods. At first, I access HP spans. So I write const player HP is equal to document.getElementById, and now I need to provide this ID. Let's look to our index.html file, and here you see that span contains the ID player HP. So here I will write this ID. Now let's do the same for the enemy HP. Now I also need to check the ID in the HTML. So I see that for enemy HP, I'm using enemy-HP ID. Then I'm accessing the button. Button has this ID, so let's just copy and paste it. And the last element is our log. Now let's continue with the third step, where you need to implement the battle logic. So for that, you will write a function battle that will access our player and decrease the HP of the player by the damage of the enemy. And then you need to decrease the HP of the enemy based on the damage of the player. But you shouldn't access elements from the class directly. So for that, you need to write getters and setters. Now let's implement this step. I will write getters for our HP and damage, and also the setter for our HP. And now let's write the function battle. So this function will not get any parameters, and it will access our player and enemy directly inside of the function. So at first, let's imagine that player hits the enemy first, so we need to decrease the HP of the enemy. And for that, I access the current HP of the enemy, and then I decrease the damage of the player. And now I need to do the same for the player. Now let's continue with the step number 4. Here you need to write a function that will update UI elements. UI means user interface, or simply all the elements that you see in the web. In the step number 1, we created 2 objects in JavaScript, and now we need to synchronize them with the HTML elements. So then in the step number 3, we have a function that can change our enemy and player objects. And then in the step number 4, you need to synchronize these changes with the HTML elements from the step number 2. Also, you see that we have a log element, so we need to write some kind of message, and for that you can add a return statement to the battle function, and in this case, if you call the function battle, it will also return you a message. And then you can use this message in the update UI function that will display this message in the web. So at first I create a new function, update UI. Now let's update our player HP element. For updating the text that HTML elements have, you have a text context property. And now I can assign this property to a new value. So now let's do the same for the enemy. And now let's update our log. So for example, I can write log.textContent is equal to message, but at this point we don't have any message. So let's pass this message to the function update UI. So now when I call this function, I can pass a message. So to test how it works, let's call this function. And now you see some changes on the web. So for example, the HP of our player have been updated to 110, and also we have a logging message attacked. So, but I don't want to manually write these messages. And as I said, let's write this message inside of the battle function. So in this function, let's create a new message and then let's return it. And then we can write that player attacked enemy, and then let's log a new HP. So for example, I write player attacked enemy, and then I write enemy HP column, and then I concatenate the dynamical value from the object enemy. And now let's extend this string on the next line. Now let's call the function battle and update UI to see how it works. So before the update UI function, let's call the battle function. And now you see that the HP of the player and the HP of the enemy have been changed. We still don't see any messages because we haven't stored this message from the battle function. So let's create a new variable message. So now this variable stores the data from the battle function, and now I can pass this variable to the update UI function. And now in the console you see two messages: player attacked enemy, then the enemy HP, and also enemy attacked player, and then the player HP. Now let's continue with the step number 5. In this step you need to write the winning check function. If the HP of any unit is equal to 0, in this case we want to finish this game, and then write the message to the console that player is dead, or enemy is dead, or both are dead. So let's start from writing the winning check function. This function doesn't receive any parameters, but I want to send the message. So let's return a default message. I think that I want to return an empty string that represents that we don't have any winners. So before this return, let's check that player is dead. So if the player HP is less or equal to 0, in this case we can write that player is dead. Now let's check the same for the enemy. And now let's check that if player.getHP is less or equal to 0 and enemy.getHP is less or equal to 0, we return a message that both are dead. And now let's think what happens if both units are dead. So we are going to the first if, where the player HP is less or equal to 0, which is true, so we return the message that player is dead. And when we return a message, it means that we finished this function, so it means that we don't check all the remaining branches. And this is the reason why this check should be in the beginning. So now, if only player is dead, this function will give us false, and we will go to the next function. And then the second if statement gives true, so we return the message that player is dead. Let's also delete the calls of our battle and update UI functions. And now we can continue with the step number 6. In the last step, you need to write the function gameloop. So this function needs to call all the functions that we wrote before in the right order. And then you need to write the trigger for our button. So when a user clicks the button attack, we need to call the function gameloop. So at first, let's write a new function gameloop. This function doesn't have any parameters, and as I said, we need to call all the remaining functions in the right order. So the first function that I want to call is a battle. So this function sets a new value for our HP and damage, and also it returns a message. So let's store the message that we received from the battle function. After updating our variables, I want to check if there is any winner. So I call the winning check function. This function also sends a message, so let's save it in a separate variable. And then I want to update the corresponding UI elements using the update UI function. So in this function we need to pass a message, but now I have two messages that I can pass. So we need to think about the logic, which message and when we show. So the winning message can also be empty. As you see from this function, the default return is empty. So I think that I want to show a battle message until someone is dead. And if someone is dead, I want to show the winning message. So let's write an if statement that if the winning message is equal to empty string, we want to pass battle message. And then I want to write the else statement. So if we have the winning message, I will pass the winning message. And finally, let's add a trigger to our attack button. So for that, we will use @EventListener function. So when the user clicks on the button, we call the game loop. And now let's check how it works. So now I see that player has 100 HP, but it should have 110 HP. So it means that our UI elements haven't updated yet. So let's also call update UI function. So now you see that our elements have been updated. And now if I click the attack button, you see that we have the message that player attacked enemy and enemy attacked player, and the HP of these units have been decreased. I can continue clicking. And at some point, I see that enemy is dead. But here I have one bug that even though that my enemy is dead, I can continue attacking my units and now they have negative HPs. But we can easily fix this bug by blocking our attack button if one of the units is dead. So in the game loop, we have the else statement, which means that our winning message is not empty. And here I will add a new line. Buttons in JavaScript have a default value of disabled that is equal to false, and then I can set it to true, and in this case, user won't be able to click this button. So let's test it again. And now you see that if the enemy HP is equal to 0, our button is disabled, and even though that I continue clicking on this button, our @EventListener doesn't listen these clicks anymore. So you have implemented all 6 steps of this game, and now let's plug our fancy CSS. For that you need to download the fancy.css file from my GitHub. In the index.html, Let's change the style.css. And now you see updated styles in the web. So if you click this button, you will see logs, and also you will see that the numbers are changing, but the HP bar remains on the same place. Let's add some lines for animating our HP bar. At first, go to the step number 1, and here you need to write 2 additional constants. So player max HP, which is equal to player.getHP, and then the enemy max HP, which is equal to enemy.getHP. So these variables stores the initial amount of HP of our units, and then we will use these variables in our animation. Now in the step number 2, you need to access 2 elements. So player bar and enemy bar. And finally, you need to add 2 additional lines to our update UI function. So the first line takes the width of our progress bar, and then it sets a new width by dividing the current HP to the maximum HP. And then we convert it to the percentages. So and the same with the enemy bar. And after making these changes, you have a fully implemented mini battle game project. So here you can click your attack until one of the enemies is dead. A quick guide on ternary operators in JavaScript. So imagine that you have a pet, and then you have a variable isLazy that shows the current condition of your pet. And if he is lazy right now, we log to the console the sleepy emoji. And otherwise, if our condition is false, we log to the console the emoji of a walking dog. For this condition isLazy is equal to true, we have a shorthand, which is just isLazy, and we also have a shorthand for an entire block, which calls a ternary operator. So let's rewrite the same block using the ternary operator. So I start from the condition inside of the if statement, isLazy. Then I want to ask a question, and for that I'm putting a question mark. So we ask a question if this condition is true, and then we need to put a true result. In our case, this is the first log with a sleep emoji. And then I have the else statement, and instead of the else, I put a colon. And then I put the else statement result. And now if I save the file, in the console you can see that we have 2 emojis. The first one you have from the 6th line, this is our else condition, and the second one you see from the 9th line. So this is our ternary operator. And now if I change the value of isLazy to true, in the console you can see 2 sleepy emojis. So you can rewrite your if-else statement block using the ternary operator for improving the readability. For example, I can store the result of our ternary operator into the variable, and in this case our result will be even more pretty. Now the result is stored into the pet emoji variable. If you hover over this variable, you will see that this variable can be equal to the sleepy emoji or the walking dog emoji. And now this is incredibly easy to read this code, because you know that this is the result of the true statement and this is the result of the else statement, and you see them together on the one line. When you shouldn't use ternary operator instead of the if statements. For example, your if statement is too long. As I said, the first part of our ternary operator is the condition that we have inside of the if statement. If our condition is extremely long, it will be difficult to read the result. Technically, I can write the ternary operator for this if statement. For that, I need to take an entire condition that we have inside of the if statement. And then I ask a question putting the question mark. And then I write the result of the true condition. In our case, this is a console log. And then you will see the second problem of this if statement. In our if condition, we don't have any else statement, but if you use ternary operator, you must provide the result of the else statement. So in the end of our ternary operator, we see an error that column expected. When I see this mistake, I need to put column. And then I need to imagine the else statement. So for example, I can put an empty string. And even though that it works the same, this is much more difficult to read this line of code. So I don't recommend you to use ternary operators for if statements where the condition is too long or that don't have the else statement. Template literals in JavaScript. You know that we can join different strings using a plus operator between a string and a variable. But sometimes, if we have a lot of variables, it can be extremely difficult to read. And for solving this problem, we have template literals in JavaScript. So let's rewrite the same sentence using template literal. At first, I need to put backticks. This symbol might be difficult to find on your keyboard. Generally, it has a tilde sign on the same key, but if you can't find this symbol on your keyboard, there is another way how to put it. You can hold Alt and 96 at the same time, and in this case you will put this symbol. I use this method when I can't find backticks on a keyboard. And now, inside of the backticks, we can write a common string. So let's write the same sentence. And now in the console we have two identical sentences. But the problem of the second sentence that we hard-coded values like Bob and 30 directly to our string. So actually we want to use our variables. If I change the value of our variable from Bob to Dave, now you see that only the first sentence have been changed in the console and the second sentence still has the name Bob. So it means that instead of the Bob, we need to use the variable my name. And for that, I need to write the name of our variable. Now, if we save this file, you will see that JavaScript can understand is it a string or a variable. So we need to add a special symbol to distinct is it a string or is it a variable. And for that, I need to put a $ and curly braces. And now if you save the file, you will see that in the console we have the name Dave. And if you hover over this variable, you will see that this is a const my name with the value of Dave. So let's do the same with our age. So instead of the 30, I add $ and curly braces. And now inside of the curly braces, I can write my variable. And now if we compare both the sentences, you see that it is more difficult to read the first sentence because it has additional plus signs, and also it has a lot of quotes because every time when we add a string, we need to add quotes. But if we use template literals, we write the sentence in the way that we want to see it on our page. So you add a $, curly braces, and inside of the curly braces, you write the name of the variable. Now I wrote a short sentence, my age is 30, using both string concatenation and template literal. And now let's compare what happens if I want to add 1 to this variable. So in the first sentence, let's add 1 after the variable my age. And now in the console you see that my age is equal to 301. So now let's do the same in the template literal. So after the variable my age, I add 1. And now you see that template literal behaves differently because my new age is equal to 31. And it happens because in the first sentence, when you use string concatenation, it changes all the variables to strings. So my age is equal to 30. Then it sees that in the beginning of the sentence, we have at least one string. So it decides to change all our numbers to strings. And then it joined them together. And eventually you see a sentence that my age is 301. But template literal works differently because at first it goes inside of the curly braces. So, and here it works as absolutely a new sentence. So my age is equal to 30. And then it says that inside of the curly braces, we have 30 plus 1 and we don't have any strings. So it means that our plus operator works at the mathematical addition, and when this expression is equal to 31, it changes the number to the string. And eventually we see the sentence that my age is equal to 31. And one small bonus, if you want to write a sentence that quotes are and then you want to show the double quote symbol, in this case you can use template literal to show the symbols. If you will try to put them inside of the double quotes, you will see a syntax error. So if you need to show quotes as a symbol, you can use this trick. Learn switch statements in JavaScript. I have an example with if statements. In this block of code, you have two variables, food amount and dog name. And based on the dog name, we set the food amount and then we log to the console the message that your food is ready. So for example, if our dog name is Bob, our food amount is equal to 1 and we log to the console that your food is ready, Bob. Then if our dog name is equal to Gary, you see a message that have a nice meal, Gary. And then if we have a known name, so for example, Billy, we have the default case and the message default food amount for a new dog. This construction starts from the keyword if, and then each new case we write from the keyword else if. So for example, we might have much more other cases, and all of them we will write with the construction if, else if, and finally we write the else statement. So the else statement is some kind of default outcome if previous branches haven't been chosen yet. And here we have one problem, that if we have many cases, it becomes difficult to read. So for maintaining this kind of structure, we have the switch statement. So let's rewrite the same code snippet using the switch statements. So I start from the keyword switch. Then I put parentheses, and inside of the parentheses, I doesn't put the condition, I put only the variable that I want to compare to other cases. So in this case, I will write just doc name. And then I put curly braces. So the beginning is the same as with if statements, but then we need to write different cases. For that, I write the keyword case. And then I write the name of the value when this case must be executed. So let's write Bob, then I put colon, and then on a new line, I can write this case. So we had food amount is equal to 1, and also console log. And now if we change the name of the variable doc name to the Bob, you see two messages in the console. So the first message is from the line 8. This is from our if statements. And the second message is from the line 20. This is from our switch case. Now you see that I don't put equal sign. So we omit the strict equal comparison because switch statements imply that you have this strict comparison. When you write case Bob, this is the same as writing doc name, then strict comparison to Bob. Then let's write the second case using the same pattern. Again, I start from the keyword case. Then I write the value of the doc name when this case must be executed. So I write Gary. And now I can write the content of this branch. So food amount is equal to 3, and then a new console log. And now if you save this file, you will see one strange thing. Now in the console we have this new message. So have a nice meal, Gary, even though that our doc name is equal to Bob. And this is because in switch case, if one condition is true, the first case checks that our doc name is equal to Bob. This is equal to true. Then it means that all the remaining code in the switch case will be executed. So no matter do we have the second case or the third case, all the block will be executed. And this is a behavior that we want to prevent because in switch case, we want to choose only one branch. And to prevent that, we need to add the break keyword to the end of the case. After our console log, let's write the break keyword. So this is the same keyword as we use in loops for finishing the execution of the loop. Essentially, it means exit. Now let's also add the break keyword after the second case. And finally, let's write our else statement. Our else statement is a default case. It doesn't compare the doc name to any value. And to represent it in switch cases, we have a default keyword. So now instead of the keyword case, let's write the keyword default. And then I put column without any value, and then I write the default case. In our case, I will write that food amount is equal to 2, and then a console log. And then in the end of the default case, I might write break keyword, but actually this keyword does nothing because right after the default case, we see the ending curly brace. It means that this is the end of our switch case, and we anyway finish our switch case. But for the consistency, if you like, you can add this keyword. Let's change our doc name to a new one to check how our default case works. And now in the console, you see that default food amount for a new doc. So it means that our default case works correctly. I also want to clarify the most common mistakes that people do when write switch statements. The first one is to write any kind of comparison in the switch statements parentheses. So here, when we have the doc name, you shouldn't write any comparisons like doc name equals to Billy or something like doc name is less than 0. It will not work with switch statements. We use switch statements only when we compare values with the strict equal sign. If you want to compare using the less or more operators, you must use if statements. So the second mistake is a little bit more complicated, and for that let's comment our switch case. Now we have only if statement block, and here let's change the second case. Let's change the name Gary to Bob. So now, what do you think we will have in the console if our dog name will be equal to Bob? Even though that we have two comparisons of dog name equals to Bob, we see only our first branch. And this is because we start a new statement from the keyword else. Else keyword is executed only when if statement is equal to false. So if instead of this comparison we have true, now you see that all this block becomes a little bit darker because Visual Studio Code shows that this block will never be executed. Now let's change this value to false. And now you see that the if statement will never be executed. I returned back the keyword to true, and now let's see what happens if we delete the else keyword. Now you see that everything is okay, and if I save this file, you see two messages in the console. And this is because our first statement is equal to true, so we execute it, and then we don't have else keywords. So we start from the new if statement. So essentially this is the same as separating them into two different if statements, and here we check the condition that dog name is equal to Bob. This is also true, and this is the reason why we execute this body also. So let's change this true value to dog name equals to Bob, and you see that anyway we see two messages in the console. Here you need to understand that even though that you have the same comparison in if statements, your code can choose two branches. If you write it in the way if, then else if, else if, else if, and finally you write else statement, this is the block when only one branch will be chosen. So no matter which comparisons you have, only one branch can be chosen. This is the case when we can use switch statements for better readability. And now a small summary. All the time you can use only if statements. But if you have many values to compare, it will be difficult to maintain this code. And for better readability, you can use switch cases, especially if you have many values like 10 or more. In JavaScript we have 2 = and 3 = but what is the difference between them? I start from the strict equal comparison. If I compare 10 number and 10 string using the 3 = we will get false. But if I use 2 = we get true. And this is because when we use 3 = we compare the data considering the current type of the item. Our first item is 10, which is a number, and we compare it to the 10, which is a string. So the data is the same. We have 10 and 10, but the type is different, and this is the reason why we have false. When we use 3 = we get true only if both the data and the type are equal. So if I compare 10 number with the 10 number, I get true. But when we use 2 = at first it converts the data types into the same one, and then it compares the data. So if we have a number and a string, it converts the string to the number. So our first item is a 10, which is a number, and our second item is a 10, which is a string. So if we use 2 = it converts the string into a number. And then it compares two items. So we see that 10 is equal to 10, and this is the reason why this expression gives true. So when we compare two 10s, it seems to be logical, but sometimes it is difficult to predict the result. So for example, I can compare 5 with a string 05, and anyway, this is equal to true. So we have a number and a string, and we use 2 = operator. So it converts the string into the number. So we have 05, but then the compiler knows that the first 0 is not important, so we can remove it. And eventually we compare 5 to 5, which is true. It also works if we compare 5 to a decimal number, like 5.000. So in this case, the compiler also drops these zeros, and eventually we compare 5 to 5. But if we compare 5 to 5a, if you will try to convert this string into the number, you will find that in the math, you don't have a number 5a. And this is the reason why it will be converted into a none. None means not a number, and it has the data type of number. So every time when you try to convert any string into the number, and this number doesn't exist, it becomes none. And now we see that 5 is not equal to none, and this is the reason why we have false into the console. With numbers, we don't see all the problem of 2 =. But now let's look to the boolean. We can compare true and 1. And if you use 2 = operator, it will be equal to true. So again, we don't understand why it is equal to true. So if you use 3 = you don't have this problem, because again, 3 equals sign compares value and the data type. But let's return back to 2 equals sign. If you use boolean and a number, it converts everything into the boolean. So we convert number 1 to the boolean. But boolean can be only true and false. How to decide what it will be? If you want to convert a number to the boolean, there is a simple rule. We convert 0 to the false and all other numbers to the true. So 1 is not a 0, and this is the reason why we convert it into the true. And then we compare true and true. So they are the same, and this is the reason why the result is true. So if you try to compare true and 0, you will get false, because we convert 0 to the false value. So what happens if we compare boolean and string? Again, we convert strings to the boolean. So if this is 1, it is the same as converting it into the number. So we just remove the quotes and we see the number 1. And then we know that this is not 0, so we can convert it into the true. And again, both these elements are the same. So this is the reason why we have true in the console. But there are more weird examples. So if we use 2 equals sign, and if we compare false and empty string, we get true. So this is just how compiler converts the empty string. And there are also other examples. So all items that create the space, for example, /n is the same as pressing enter on your keyboard. So it creates a new line. And if we compare this string and the 0, it is also true. We can compare false with as many spaces as we want, and it will anyway be equal to true. So now you can see how much problems it can lead, and only one way to prevent these weird results is to use 3 equals sign. But actually, there is one exception where 2 equals sign can be useful. In most of the languages, if we don't have any data, we have the value null. But in JavaScript, we have another nullish data type, which is undefined. So for example, I create a new variable age, and I don't assign any value to this variable. And then if I log this variable to the console, you see undefined. But there are cases where it might be equal to null. For example, if we ask age from the user by using the function prompt, this function sends a pop-up where we can write a value. And here, if I press cancel, you will see null in the console. And for example, I want to create a script that will return this prompt again and again if user doesn't provide any value. So for example, I have this program where I ask the age from the user, and then I have a while loop. And until my age is equal to undefined, I will throw the same prompt again. And if we have any value that is not equal to undefined, we log it to the console. In this case, if I click cancel, now we see null in the console. And this is because in JavaScript, null is not equal to undefined if you use 3 equal operator. If you try to compare null and undefined, you will get false. But if you use 2 equal operator, it is equal to true. Also, we don't have any weird examples. So for example, if we compare null and 0, we will have false in the console. So, and this is the reason why for this script, we can use 2 equal operator. And in this case, if user doesn't provide any age and press cancel, we throw this pop-up again until it provides any value. I can click cancel several times. And then I write a number, for example 10. And now you see this number in the console. But even in this case, you can write the same program using the 3 equal operator. And for that, you need to write a little bit longer expression where age is strictly equal to undefined or age is strictly equal to null. This program works absolutely the same, and this is absolutely valid. Especially for beginners, this condition is much more preferable. Now I will quickly show you what happens with arrays and objects. If we try to compare an empty array to another empty array using the 2 equal sign, we have the false. And the same result we have if we try to use 3 equal sign. But in this case, we also have a warning that this condition will always return false, since JavaScript compares objects by reference, not value. This is another topic. What is the reference difference and value, and I have a video on this topic. So again, let's return back to 2 equals sign, and here it seems to be okay, but there are a lot of weird examples. So for example, empty array compared to 0 is equal to true if our array contains 1, which is a string, and then we will compare it to 1, which is a number, it will also be equal to true. There are many edge cases that can give you true when you don't expect it. With arrays and objects, you must not use 2 equal operator. There is also one interesting edge case. If you try to compare not a number with not a number, no matter what kind of comparison you will use, 3 equal sign or 2 equal sign, it will always be equal to false. So this is just a behavior of a not a number. Each not a number is unique and it is not equal to anything. So for example, I have a variable num and then I want to know, is it equal to none or not? In this case, you can't use comparison operators, and the valid way of checking if the variable is not a number is to use the object number with the method isNone, where you pass your variable. And now you see that it gives true to the console. And finally, let's make a small quiz. You see 10 different console logs, and for each one you should write is it equal to true or false. After 5 seconds, I will show you the answers. So these are the answers. Today you will create a game where you can click the animal to earn the currency, also merge different animals to get a new animal of the next level. Also you can buy new animals, and you have functions like save, load and reset. So this game uses 2 main mechanics. One is clickable, so we have clickable elements like our pets and buttons, and also we are using drag and drop system, so I can take one animal and then I can merge it with others using the drag and drop system. But I think that the drag and drop system is quite advanced, so this is the reason why the first version of this game uses only clickable elements. So in this game, we also can click the animals, then we can merge different animals using the merge button, and then we can buy elements, and also we have save, load and reset functionality. So we will do exactly this game during the first episodes. This game uses HTML, CSS and JavaScript files, so I will give you the HTML and CSS files and we will be focused only on JavaScript, so on the logic of this game. To follow along this project, you need to know the basics of JavaScript, like ifs, loops and functions. Also you need to know the basics of DOM, so how to get the elements from HTML and then how to change them using the JavaScript. If you think that this is too difficult for you, I have a simpler project with a cookie clicker game. And now let's create a game plan for this project. At first, we need to create our game board. Then we need to create our clickable animals. So we generate an animal of the first level on one of the cells, and then we can click it to earn the currency. And if we have enough money, we can buy a new pet. So then we need to work on merging. So we will add this merge button, and if you click it, you see that this button is active, and now we can merge this animal with another one. Now this animal has a new level, so this is the second level animal, and when we click it, it gives 2 poopy currency. So now we can buy more animals, but if you try to merge animals of different level, you will see a message that pet levels are different and nothing will happen. So then we need to implement the save, load and reset functionality, so I can click the save button to save our game state. In this case, we will see the message that game is saved. Then let's reload our page. And now you see that we have a game from the beginning, but we have our saving. So I can press the load and you will see the message that game is load. And now you see that our state is returned back. So also we have the reset button. If you click it, you also see a message that game is reset, and then you will see our empty board. But reset button also deletes all our savings. If I try to click load button, you will see a message that no savings yet, and nothing will change. And finally, we need to implement the auto clicker. So in our shop, we have the auto clicker button and I can buy it. Then I see that our auto clicker is enabled and I start to earn our currency. And this currency is earned based on the best level of our animals. So currently we have animals only of the first level, but if I merge them, you will see that currently the best level of our animals is the second one, and we start to earn 2 currency per second. Let's look to the HTML file that you will use. So at first, you can notice that the file name index.html has this green color. You will not have it. This is because my files are connected to the Git. So it means that I store them on the GitHub and you can download them on the link from the description. So at first we have the metadata of our HTML file. Here you see our title, and then you see the link to our CSS file, and then you see the link to our script.js file, and then starts our body section. Body section contains all the elements that you will see on the page. So you can see that here we have 100 lines, but you don't even need to understand them. Let me connect to the browser and let's see how this file looks like in our browser. In the right bottom corner, I have the Go Live button. If you don't have it, you need to download the Live Server extension. On the left hand side, you can find the Extensions Explorer. Then you need to click it, and in the searching bar, you need to write Live Server. Then you will see the Live Server by Ritwik Day. Download it, and you will see this button in the right bottom corner. So I click this button and now I see my game in the browser. So this is how our pure HTML looks like. It doesn't have any styles except of the default ones. Also here you can see the zoom property, and if you click it, you can change the zoom of our game. Even though that this page doesn't look pretty, this HTML file is the same as we have in the final version of this game. And here we actually have all the data. Here we have our currency counter. Here we store the best animal level. Then you see that we have a shop. So you see the buy button, then enable the auto clicker, and then save, load, and reset buttons. Then you see the small instruction on how to play this game, and then you see our board, which is empty. So now let's connect our CSS, and you will see that this page will be much more beautiful. This is our style.css file. I connected it to the HTML on this line. The name here needs to match with your name of the file. So I have style.css and the name of my file is style.css. Now you clearly can see both panels. So we have the first panel with our UI elements like our counters and buttons, and then you see the right panel with our board, which is empty. CSS adds styles, so we will use it only for styling. This is a long file that you can download from the description. And finally, let's create our script.js file. We connect it to our HTML on this line, and here the name of the attribute must be the same as the name of your file. So I have script.js, and here I create script.js file. This file we will write from scratch. As you see, we don't have our board. So let's create our board. For that, I will create the first variable board. Our board will be an array. If we want to have 4x4 board, we need to fill this array with 16 values. So currently this board is empty, but I want to create 16 new empty cells. And each empty cell I will store as a null. So eventually we want to see something like that. Inside of the array, we want to see nulls separated by comma. So for that, we can write a simple for loop. So we start from the index of 0, and then we go until our I is less than 16. Eventually we'll go through 16 numbers, and for each number we can add a new null to our board. For each cycle, I can push a null to our board. And now if you want to see the result, let's log to the console our board. And now let's open our console in the browser. For that, I need to right click, and then I need to find the inspect property. So here you will see different tabs, and I need to find the console. If you don't see the console choice, you can click this double arrow icon, and here you will find the console. And then I will expand this console. And now you see the result in the console. This is an array with the length of 16. If I expand it, you will see that we have 16 null elements with the indexes from 0 to 15. So if you understand it, you can remain with the same code, but now I will show you how to write it in one line. So I can create a board using the new array constructor, and then I will pass the length of this array, which is 16, and then I call the method .fill with the value of null. Now, if you look to the console, you see that it looks a little bit differently, but if you expand it, you will see that we also have 16 values of nulls. This array looks differently because actually this is a different array. When you create an array with curly braces, you create a dynamical array. So this array has the initial length of 0, and then when you add new elements, it dynamically expands the sizes. But this is a static array where you must pass any number which represents the length of this array. So we can't add a new element out of these boundaries. For our project, this is not too important which array we use, static or dynamic. I just think that this line is easier to read. Again, it will not influence your code in the future, so you can stay with the code that you understand. Then I add a comment game data to separate this block. So here we will have only game data. I also want to delete this console log. So now we have our board in JavaScript, but based on this board, we need to generate our board on the page. So on the page, you see only HTML. So based on our values in JavaScript, we need to generate new HTML elements. So to better understand how it works, let's go to index.html file and then scroll down until you see our grid. So let's expand this div. So, and now inside of this div, I can create a new div with the class of cell, and you will see how one cell appears on our page. So this div is empty, so I don't change the content of this div, but I need to add a new class. And now you see that one cell is appeared on our page. This cell has almost the height of our container, and this is because I use flex properties in CSS for aligning our cells. So I implied that you will use more cells, so let's add new ones. If I have 4 cells, they fill an entire container. Let's add the 5th one, and now you see that they start to stretch. So eventually, if we create 16 cells, they will be aligned beautifully on our page. Why we can't write them manually? At first, if you want to change the board size, so for example, you want a board 5 by 5, you will need to manually add new cells. But the real problem is because we need to track each cell can be empty or it can contain an animal. In JavaScript, you have this variable board, and this is the source of truth. And then if something happens on the page, we can change it in JavaScript board, and then we will regenerate this board again in the HTML. So let's try to generate the same board in JavaScript. For that, let's delete our manually created divs from HTML. So I select all these divs and then I delete them. Now you see only the border of our container, so you don't see any cells. So then for generating these cells on our board, we need to access the container from HTML. Here we will have the section for HTML elements. So now let's access our board. For that, let's create a new constant board element. So I write board L, I use the abbreviation for element for saving the space. If you want, you can write the full name board element. And then we have a function document.getElementById. So now inside of this method, we need to pass the ID of the element that we want to access. Let's go to our HTML file. Now you see that the ID of our board is grid. Let's copy this name and then we will pass it into this function. Now we can access this grid from JavaScript, and now we can start generating new cells. For that, I make a new section rendering. So inside of this section, we will write functions that update our elements on the page. So let's write a first function render. Inside of this function, let's go through all the cells of our board. For that, I use the most common for loop with the condition where I is less than board.length. And now for each cycle, let's create a new div. So I create a variable cell div, and now we have a function document.createElement. So inside of this function, we need to pass the name of the element that we want to create. So we can pass div. Now we created our div element, but the default div doesn't know how it should look like. And for that, we need to attach the class cell. I returned back to our HTML file, and here I manually created a new div, but we don't see it on our page. And this is because div doesn't have any default properties. All styling properties of this div are stored in the class cell. If we add this class cell, you see that it appears on our page. And this is what now we need to do in our JavaScript. I delete this div again. And now inside of the JavaScript, let's add this class to the cell div. And for that, I can write cell div.className, which is equal to cell. So now we have a div that has a specific style properties, but we doesn't attach it to our grid. So let's append it to our board. So I use the appendChild method to add this div inside of our board element. But we still don't see any changes, and this is because we haven't called our function anywhere. For that, I create a new section GameStart, and here I call our initial function. Now, if I save this file, you can see our grid on the page. And now let's spawn our animal on the grid. So this animal is not clickable, but when I refresh our page, we spawn this animal on a random cell on our grid. So let's think how to put our animal on the grid. From the first view, it seems that this object has only the emoji of the chick, but actually it also contains the data about the clicking reward, the current level of the animal, and maybe other properties like name, because you may want to show these details on the page. We have one data structure objects that can contain many properties inside of it. So let's create an example pet, which will be an object. So for example, our pet might look like this. So we have an object with the key emoji and with the value of this emoji, and also other properties like name, which is equal to chick. So this is good, but we want to have multiple pets during our game. So in our final version, we can merge the same pets to get a new pet of the next level. And this pet will have other properties as well as other emoji and name. And for that, we can store pets inside of the array. Let's call our variable pets. Now I can expand it. And now inside of this array, we can add other animals. I added 10 animals and their levels from 1 to 10. The first one is chick, and if we merge two chicks, we get a bunny, and so on until we get the unicorn. This will be our source of truth, and this will be our constants. So capital letters represent constants. And then if you want to add some properties or change our emojis, you can change them inside of this const pets, and it will affect an entire game. So now let's return to our version, and as you see, we have an empty board. So let's create a function for spawning our animals. For that, I will add a new section core actions right after our HTML elements. So inside of this section, we will write all the functions that represent the main logic of our game. So let's create a function spawn new pet. So this function should spawn the first level of animal. So for that, we need to access the first object inside of the constant pets. I can access the first object with the index of 0, and this will create a new variable pet, which is equal to this object. One thing that you need to remember about this variable is not a copy of the object from our pets. This variable is just a link to the same object. It means that if we do any changes on this object, it will also affect the objects inside of the constant pets. If you don't understand why it works in this way, this is just because objects are reference value data types, and I have a short video about it. But let's return back. So what we need to do with this variable pet? We want to put it on our board. So our board is an array of 16 values, which currently are nulls. So we can access the board by index, and then we can put our object pet inside of this index. So this code will put our pet object into the first position on our board. Currently, if you save this file, nothing will happen, and this is because of two reasons. The first, you haven't called this function yet. The second, you don't have any representation of our object inside of our HTML. So to show our animal on our board, we need to create a new div with this animal. So to better understand how it works, let's go to our index.html, and here inside of the grid div, let's create a new pet. So at first we need to create our cell. For that, I create a new div, and then I add the class for this div, which is cell. So now if I save this file, you will see that we have one additional cell on this board. Actually, we generated the first cell, and then more 16 cells have been generated due to our JavaScript code. Then you need to understand that the picture of our chick is just an emoji. So it means that we can copy this emoji, and then if you create a new tab in your browser, you will see that you can paste this emoji here. So it works as a common text. So let's close this tab and return back to our HTML file, and here inside inside of the div cell, let's add our emoji chick. And now if I save this file, you see that a small emoji of our chick is displayed on our page. So this is fine if you want to show only chick. In the final version of this game, you see that we don't have only our emoji, but we also have the level of this pet, the name, and the value how much you earn per click. If you want to display multiple objects on one cell, and if you want to have the full control over them, it means that putting your emoji as the part of the cell will not be enough. You need to create a new div inside of the div cell. So let's remove our emoji, and then let's create a new div. So this div will have the class of pet. And now let's paste our emoji inside of this class. So this div creates a new animal on our page. And you see that the styles of this div is different from the styles of our cell. This is because this div has the class pet, and this class pet contains other styles inside of our style.css file. So this is what we need to generate with our JavaScript. In the first layer, we'll create our grid with cells. And on top of it, we'll create a new layer with our animals. I will delete this code later, but now let's go to our JavaScript file. So our purpose is to create the same div on our page. We have the function render that is responsible for showing all the objects on our board. So inside of this function, let's create a new variable cell data. So this variable can be equal to null because initially our board is filled with nulls, or it can be equal to our pet object. Then we have the code that generates cells, so let's separate them. For that, I add a new comment that this block is responsible for cells, and then let's create a new block that is responsible for pets. Our cell data can be equal to null or our object. Here I check that our cell data is not equal to null, so it means that our cell data is equal to our object. And now, if this is a pet object, let's create a new div that will represent the pet. At first, let's return back inside of our HTML file, and here you see everything what we need to generate. So we need to create a new div with the class pet and with the content type of our chick emoji. So at first, I create a new div. Then let's attach the class pet to this div. And now let's change the content type to chick emoji. We can manually pass the emoji of our chick, but actually we have many other pets with other emojis. So it means that we need to get the emoji from the constant pets. I know that our object has the key emoji, and here I know that our cell data is equal to this object. So let's create a new variable emoji that gets the emoji from this variable. If I know that we definitely have this key, I can access it by writing celldata.emoji. There is also another way how I can access this emoji. I can put square brackets and then I can pass the name of our key. Typically we don't pass the hard-coded strings, we pass the variables. But if I know the exact name of our key, it is easier to access it by putting dot and then the name of the key. And now we can pass this variable into our text content. At this point, we have created the same div with our JavaScript, but we also need to put it inside of the cell div. So for that, let's look to our cells code. The first line is the same. We create a new div. So then we attached the class of cell, and then we appended our cell div to our board. But the problem is that we append this div too early. The cell div at this point doesn't contain the data about our animal. So, and this is the reason why I need to call this line after we generate our pet divs. And now before we append our cell to the board, let's append our pet to the cell. If I save this file, you will see that nothing happens, and this is because we need to call our function spawnPet. So in the end of our file, we have the section gameStart, and now before the render, let's call our spawnNewPet function. And now you see that we have two chicks. So one is from the HTML file. I can go here and delete this manually written chick. And currently you see that we have only one chick. Currently we have another problem that the position of this chick is fixed to be on the first cell. No matter how much I refresh this page, it is always on the same cell. But we want to generate this chick randomly on any cell from the first to the last one. Inside of our spawn new pet function, we have this line that appends our pet on the first cell on the board. Instead of passing 0, we need to pass the index. But at this point, we don't have the variable index, so let's create a new variable. If this variable is equal to 0, it works absolutely the same, but actually we want to generate this index in the range from 0 to 50, because we have 16 cells and the ID of the last cell is 50. Or to be even more correct, the last index is not 50, this is the board.length. So it means that if I change our board size, here where I create our board, I can pass another value, for example 20. And now you see that we have 20 cells on our page, so it means that the last value of this index should be 19. So let's undo these changes. Now let's create a new function that will generate a random index. For that, I will create a new section helpers. This section will contain functions that we are using inside of our core action functions. So let's create a new function, generate pet index. And here we need to create a new variable index that will have a random number. I have a function math.random that generates a random number between 0 to 1. And then I wrap it inside of the math.floor. This function rounds the number to the nearest integer downside. I don't want to have values like 0 point something. I want to have integers like 0, 1, 2, and so on. And now here I can multiply the math random by our board size. And now we can easily calculate what this function will return if we replace the math random with 0 and then with 1. If we replace it with 0, the board length is 16. And 0 multiplied by 16 is 0. So the lowest number that this function will generate will be 0. And now let's replace it with 1, but actually math.random can't generate the 1, it generates the closest number to it. This is actually something like 0.999. And now if we multiply it by our board length, which is 16, we will get the 15.999. And then if we round it down, we will get the 15. And this is actually the range that we want. So it means that our formula works correctly, and now we can return this index. So now we know that this function generates the expected boundaries, and now we can call it inside of our spawn new pet. And if you save this file, you will see a chick on a random cell. So I can refresh this page several times. And you will see that our chick is generated on a random cell. And now let's make our animals clickable. So every time when I click it, you see that my poop counter increases by 1. Also, if I have enough currency, I can buy a new animal. In our current code, we don't have any access for our UI elements, so we don't update them. Currently, our poop counter and the best level counter are 0. And no matter what we do, they are always 0. So at first, let's access these elements and let's make a function for updating our poop currency. So in the game data section, I create a new element poop. This time I'm using a let keyword because poop is a counter and we will change it in the future. Let's also create a variable for the best level. So then we have the HTML element section. So now inside of this section, let's access the corresponding HTML elements. Now I need to find this element in our HTML file. And now I see that inside of the B tag, we have the ID poop that contains the value of 0. This is exactly what we need to change when we update our poop currency. So let's copy this ID and let's paste it inside of this function. Now let's do the same for the best level. You can write the full name of this variable like best level element. I have very few space on my screen, so I need to have short and concise variables. Inside of our HTML element, I see the B tag with the ID of best level. So this is the variable that we need to change in our JavaScript. I paste the ID best level to this function, and now we can write a new function that will update our UI elements. Inside of the rendering section, we have the render function that updates our board, but we also need to update our counters right after the render function. Let's create a new function, update UI. So at first, let's change the text content of our poop currency. So we assign it to our global variable poop that stores how much currency we have in our JavaScript. And then let's do the same for the best level. So now let's check how this function works. And for that, let's change our global counters. So here I changed the poop value to 10 and the best level to 1. And now in the game start, right after our render, we need to call our update UI function. And now you see that our counters have been updated. Then let's create a function that will increase our poop by the level of our animal. I have the section helpers, so inside of this section, I can create a new function, increase poop. So this function needs to increase the global variable poop by a certain amount. So at first, let's increase it by 1. For that, I can write poop++. So this function will not return anything. And then we need to call this function when we click our animal. So in the rendering section, we access each cell from our board. If cell is not equal to null, it means that we have our pet. And now we want to attach a new trigger to this pet. So before we append our pet div to the cell div, let's add our trigger. For that, I have a method addEventListener that I can call for the pet div. This listener expects two values. The first value is the trigger itself. So when we need to call a specific function, I can right click. So it means that when I click this div, I need to call a specific function. Then I put comma, and now as the second parameter, I can pass a function that I want to execute. So we want to execute increase poop function. This is very important to pass this function without parentheses. In this case, the addEventListener will be able to execute this function. Currently, if I click our chick, nothing happens, and this is because inside of the increase poop function, we doesn't call update UI function. So here we need to call our update UI function because poop is just a counter inside of the JavaScript and our user doesn't see it. We need to update our HTML elements to see any change on this page. So I call this function, and now if you try to click our chick, you will see that the counter increases by 1. Let's return back to our trigger. So here, if I add parentheses right after increase poop, you will see that our counter is increased by 1, but then our trigger doesn't work. Because parenthesis means execution of this function. So it is executed once and then we can't execute it again. This is the reason why I need to remove this parenthesis and why I need to pass this function as a parameter. In this case, our event listener can call it. So now it seems that this function works, but as I said, we doesn't need to increase our counter by 1. We need to increase it by the level of our animal. We have an array pets that contains all the data about all the possible animals. Currently, all these objects don't have the level and the reward that you get if you click this animal. So let's add these attributes. So now I extended our array. Each animal inside of this array has its own level and the reward. So now you can see that the last animal, unicorn, has the level of 10 and the reward of 55. And now we need to do in this way that our function increase poop takes the reward of a specific animal that we click, and then it increases our poop counter by this reward. At first, let's go to our increase poop function. So here we need to pass a new parameter, which is reward. And now I can increase poop by this reward. For that, I write poop plus equal reward. So now let's click our animal. You will see that our counter have been changed to something strange. And this is because we don't pass the expected reward. But we don't have this variable yet, so let's create it. So before I create a new div, let's create a new variable reward. So currently I know that our object contains this data. Inside of our array pets, we have a new parameter reward with the value of 1. So it means that our cell data contains all these parameters and one of them is reward. So I know the specific name of this key and I can access it by writing celldata.reward. So now we pass it inside of our trigger. So let's test how it works. And now you see that our counter have been increased by 1, but if we click our animal, it doesn't work anymore. So here is the problem in this parenthesis. Previously, this function haven't asked any parameters. This was the reason why we could pass it without parentheses. There is one problem. For passing a new parameter, we need to put parentheses. But parentheses execute this function immediately. So how to solve this problem? In JavaScript, we have anonymous functions. The syntax is very simple. I just need to add parentheses and then I need to write this arrow. And now if you try clicking our chick, you will see that our counter increases by the level of this chick. So if I go to pets array and if I change the reward to 10, now you will see that each click gives me 10 currency. So let's undo this change. So about this function, anonymous function has a lot of theory behind it, so why it works in this way and why it has this weird syntax. You will understand it with experience, but currently you just need to understand which problem it solves. So if we need to pass our function as a parameter, and if this function expects any parameters, we must put parentheses to write all the parameters that this function expects. But parentheses call the function immediately, and to prevent this behavior, we write the anonymous function. So this function doesn't have any name and it is used only on one line. Also, after our arrow, I can write curly braces. It will work absolutely the same, but now I can expand them. And now inside of the curly braces, I can have multiple lines. So let's call this function twice. So now the reward of our chick is 1, but if I click our chick, you will see that our counter increased by 2 because inside of this trigger, we call our function twice. Currently we don't need it, but you just know that you can put many lines inside of anonymous function. So if you have just one line as we have, you don't even need these curly braces. So we have finished with our animal, but our buy button still doesn't work. So let's implement it. Let's think what we want when we click our buy pet button. We want to generate a new animal on our board. We even have a function spawn new pet. So at first, let's call this function every time when user clicks the buy button. Our button is an HTML element. At first, let's access this element inside of our JavaScript. I found this element inside of our HTML, so let's copy this ID and now I can pass it inside of our function. If you don't understand my variable name, you can call it BuyButtonElement. So then we need to write a new trigger that every time when we click our buy button, we spawn a new animal. Now we have section triggers inside of our render function, but there is one difference. So render function is responsible for our board. It represents our board from the variable that we have in our JavaScript. And then we attach all these triggers to this board. But our buy button is a constant HTML element that is outside of our board. So let's create a new section triggers before the game start for constant elements. And now we can attach our click trigger. So our spawn new pet function doesn't require any parameters, and it means that we can just pass this function without parentheses. So now let's test how it works. If I click our buy button, nothing will change, and this is because inside of our spawn new pet function, we doesn't call the render function that will update the board of our page. So here, let's call the render function. And now, if you save this file, you will see that something weird happens because we have 2 times more elements on our board. And if you click the buy button, you will see more cells on our board. And this is because our render function creates new cells, but it doesn't remove the old cells. So every time before we generate new cells, we need to clear our board. You see that we append all our cells to the board element. So it means that we need to clear this board element before we append new children. For that, in the beginning of this function, I can write board element.innerHTML, which is equal to empty string. Inside of the HTML file, find the div with the ID grid. So this is our board. And what innerHTML means, it means all the content that is inside of our grid. So for example, we have many divs inside of this grid, and then if you call innerHTML, which is equal to empty string, it takes all these divs and removes them. So simply, it removes all the elements, and it means that we start from the new board when we call this function. In JavaScript, we have a variable board and we store all the data inside of this variable. And you need to understand that we actually don't remove the data from this variable. We just remove the previous state of our HTML board. So actually we don't lose any data, we just clear it before generating new board. And now if you click buy button, you will see that it generates a new animal on our board. Currently, our users can click this button as much as they want. So actually, we need to check that our user has enough currency for buying a new animal, and then we need to subtract this cost from the total currency that our user has. So for that, let's change our spawn new pet function. In the beginning, let's add a new section, validation. And the first check that we will do is that our user has enough currency. For that, I can write that our poop is more or equal to 10. If I use the hard-coded value 10, it means that I can change the cost of our pets. So if you want to change this cost every time when user buy a new pet, so to make the progression that each next pet costs more and more, you need to create a new variable where you will store the pet cost, and then you need to create a function that will increase this variable every time when you call it. But for the simplicity, we stay with the constant price. So every time our pet's price will be 10. And this is the reason why I can just use this 10 without making a new variable for that. So, and now if our user has enough poop, we can create a new pet and then we can put it on our board. But actually, here we have one problem. What if we will have several checks? Every time when I add a new if statement, our data goes further and further, and it becomes difficult to read. So, and for preventing it, let's undo our changes. And actually, in the validation, we need to check the negative outcome. So in our case, what if our poop is less than 10? In this case, we need to show some kind of error and then we need to stop our function. So for showing an error, we can use alert function that will generate a new pop-up for our user. For that, I call the function alert, and now inside of this function, I can write a message that I will show to our user. So I will write the message that you don't have enough poop, and then for stopping this function, I can write the keyword return. Now let's test how it works. So at first I will change our poop to 1, and then you will immediately see a pop-up with the message that you don't have enough poop. And this is because in the game start, we call our function spawn new pet immediately. So actually it means that our function works correctly because as you see, we haven't spawned a new animal. So I returned back our poop to 10, and now let's click our button again. So you see that we buy a new pet, but our counter remains the same. So we need to subtract the cost from our counter. So before we call the render function, let's decrease our poop by 10. Now you see that we start our game with 1 pet on the map and with 0 currency. And if I click buy new pet, you will see the message that you don't have enough poop and nothing will change. So it means that our function works correctly. Currently you might think that we have implemented the buy button, but actually there are a few mistakes and edge cases that we need to take into account. Let's increase the initial poop counter to 1000. So we can generate animals easily, and the first problem that you will see that if you buy a new animal, our counter remains the same. And this is because inside of our spawn new pet function, we call the render function that updates our board. But we don't call update UI function that updates our UI elements. So let's call it. Now let's click this button again. So currently we decrease the right amount of currency, but there are still other problems. For example, what if our board is full? In this case, if you click our buy button, you will see that our counter decreases, but a new animal haven't been generated. And this is because our board is full. But what we actually want to show, we want to show to our user that the board is full, so you can't create a new animal. So let's create a new validation that will check that our board is full. For that, I will create a new variable board is full and the default value will be true. So I imply that the board is full in the beginning. And then we need to write a for loop that will go through each cell and check if there is at least one empty cell or not. Here I create the same variable as in our render function, and now we can check if the cell data is equal to null. We can set our board is full variable to be false. If at least one cell is null, it means that our board is not full, so we can buy a new animal. Here I also can write the keyword break. So as we reach this keyword, we stop the execution of our loop. Even if you remove this keyword, you will not see any visual changes, but if you think how it works, when you don't have the keyword break, it means that your for loop goes through an entire board. But actually, if the first cell is null, we set our board is full variable to false, and then there are no sense for continuing this loop. So just for better efficiency, we can add this keyword. And now, after our for loop, we can check that if our board is full, we need to show an error and then we need to stop the function. I can use the same alert function as in our first validation, but I will just change the content of this message. So for example, I can write that board is full and then I write the return keyword to finish this function. Now let's test how it works. Currently, I have a full board, and if I try to buy a new animal, you see a message that board is full. And then you see that our counter remains the same. But there is still one problem that you might notice. If we have many pets and if we want to buy a new one, we need to press the buy button many times. And this is because we have the index overlap. So currently we generate a random index between 0 until the board length. So for example, instead of calling this function, let's put 0. So now all the time our chick is generated on the first cell. And then no matter how much I click this button, there will not be new animals. If two animals have the same index, a new one just overwrites the previous one. Actually, when we call our generate pet index, we want to check that this index is unique. The easiest way to check it is to write a while loop that will check that if the cell with a newly generated index contains a pet, it means that we need to generate a new index. But before writing a while loop, be sure that you wrote the second validation about board is full. Every time when you write a while loop, you need to think, can there be an infinite loop or not? So currently, we want to check that our index is unique. But what happens if our board is full? If our board is full, it means that we don't have any free cells. There are no new index that we can generate. So currently we wrote the validation about the board is full, and it means that we safely can write a while loop. So after we created our index, let's check that if our board with the current index is not equal to null, it means that it contains an animal. We will generate a new index. And now we need to change the keyword const to the keyword let, because we want to reassign the same variable. And now let's test how it works. So currently on my map, I have only one cell, and if I click buy new animal, we should spawn a new animal exactly on this cell. We see a new animal, and we also see that our counter have been updated, so it means that we have implemented our buy button. Eventually, our spawn new pet function became much more complex than we expected, but this is very common in programming. All the time you need to think about edge cases. What if user behaves not as you expect? So now let's add the merging buttons. If you have two animals of the same level, you can merge them, and then you will get a new animal of the next level. At first, let's go to our index.html file, and here let's create this button manually so we can see what we need to generate with our JavaScript. Inside of the div with the ID grid, let's create a new div with the class cell. And now you will see that we can generate new cells manually. And this is because in our JavaScript, inside of the render function, we have this line that clears an entire board before generating new cells. So let's go to our game start and let's comment out these functions for a while. Now you can see only HTML elements that we have created manually. So let's return to our index.html file, and here let's manually create our board. So I added 16 cells, and now inside of the first cell, let's add a new animal. So for that, I created a new div with the class pet and with the text content of our chick emoji. And now let's create a new button inside of this div. So at first I expand this div, and now let's add a new button. Now you can see a very small button right under our chick. Let's write a word merge. And now you can see that we have a normal button right after our check. In the style.css, you can see this block, and this block adds all the styles to the button that is inside of the element with the class cell. So now you can click this button, but nothing will happen because we don't attach any triggers to this button. Let's also add a class drag over for this button. And now you see that our button is highlighted. And this is because in our CSS, we have the style drag over that adds this stroke right after our element. And then this green light that you see is just a box shadow. So what we want to create with our JavaScript, we want to have this default buttons. And then when user clicks this button, we want to attach this class drag over so the user can visually see that this animal is selected. Currently, I don't delete this manually created HTML board, we'll delete it later. So let's use it as a reference so we understand what we need to generate with our JavaScript. So now let's go to our JavaScript file and let's comment out our GameStar functions. And now you see that we have check without our button merge. So we generate our board inside of the render function. Now, if our JavaScript board contains the data about our animal, we need to create all these elements. So the first element is a div with the class cell. So you can see that we create this div in our JavaScript and then we attach the class cell to this div. The next we need to create div with the class pet. And now you see that if our cell data is not null, so it means that our cell data contains the information about our pet. We create a new div pet div and then we attach the class pet and the text content of our emoji. And now we need to create a new HTML element button. So right after our pets and before our trigger section, I create a new section merging. And here let's create a new HTML button. Now we created our merge button element. The next step is to add our text content. So we will add a constant word merge and we will not change it later. Now let's attach the class drag over. As I said, we need to attach this class only when we click this button. For that, inside of the trigger section, I can add a new trigger. In the previous video, we used anonymous function for our trigger. So this is a function without any name and this is used only on one line. One of the advantages of this function is that we can pass it as a variable. So now let's create a new anonymous function, but I also add curly braces and then I expand them. And now we will not call a new function, let's just write all the changes that we want directly inside of this anonymous function. So we want to attach our class drag over. Now we have created our button, but it still doesn't know where it is located. So as you see, our button is a child of the pet div. So now, before we append our pet div to the cell div, let's append our button to the pet div. And now you can see that we have created an animal with the button merge. And if I click this button, now you see that this animal is active. But even if we have many animals, we still can't merge them. So we can just activate these buttons, but we also need to write a logic for merging our animals. Our render function becomes longer and longer, so I don't want to write all the logic inside of this trigger. Let's write a new function try to merge that will be responsible for the merging logic. So I call try to merge function and then I pass the index of the current tile. And now let's create this function. Inside of the section core actions, let's create a new function. This function wants to receive the index about the current cell that have been clicked. So here, let's write a new parameter cell index. And now we know that this index is a number from the 0 until the board.length. But we also need the index of the previously clicked animal because we want to merge two animals together. So for that, we can create two global variables. So the merge cell index 1 and the merge cell index 2. In the beginning of our code, we have the game data. So let's add both these variables. So I added two variables, merge cell index 1 and merge cell index 2, and they put the default value to be equal to null. Now we know that this variable can be equal to null or an index. So inside of the try to merge function, let's try to think about all the possible cases. So the first case, when both these indexes are equal to null. If they both are equal to null, we want to set our current cell index to the variable merge cell index 1. Then we will have all other cases, but we want to finish this function, so let's write the keyword return to finish this function. So now, when I click the merge button, you see that this button is selected, but if I buy a new animal, our board is recreated from scratch, and currently our render function doesn't know which animal have been selected. Currently, we attach our class name only if we click on an animal. Actually, we need to check that if our merge cell index is equal to our current index, it means that this animal have been selected previously, and even when we recreate our board, we want to attach our truck over class. So after the merging, let's add this if statement. If our merge cell index 1 is equal to I, or if our merge cell index 2 is equal to I, it means that the current animal is active and we need to attach our class. Now let's test how it works. I click the merge button and then I buy a new animal. And now you see that we have created a new board, but we preserved the state of the previously clicked animal. So now if I have many animals, I can still select many animals, but if I buy a new animal, you will see that only the first animal preserved the selected state, and this is because in our try to merge function, we save the index only of the first selected animal. Let's think about other cases. The second case is when our merge cell index 1 is not equal to null, so it means that it has any index, but our merge cell index 2 still is equal to null. We want to attach our cell index to the merge cell index 2. And now it means that two animals are selected. In our logic, when we select two animals, there are two possible cases. There can be an error, so for example, their levels are different, or we merge them together. So at first, let's write the merging logic, and then we will work on the validation. Let's create a new animal of the next level. So I have a constant pets that contains all the data about all the possible animals. And here you see that they are sorted in the incremented order. So it means that the first pet we can access with the index 0, the second pet we can access with the index 1, and it has the level 2. We can access the last pet with the index 9 and it has the level 10. So here we have a formula where we can access the next pet using the level of the current pet. So I wrote this formula here that the next pet index is equal to the level of our current pet. But inside of the try to merge function, I don't have access to our current animals. So let's access them. So I know that inside of this if statement, both our variables have index. And it means that I can use this index to access our pet elements inside of the board. And now to get the next level pet, I can write the pet1.level. There is no difference which pet we will use, the pet1 or the pet2, because we imply that for the merging, they must have the same level. So for example, the next level pet can be equal to bunny and it has all the same parameters like emoji name, level and reward. So now when we want to merge two animals, we want to remove the first selected animal from the board and then we want to update the second selected animal to be a new animal of the next level. So let's remove the previously selected animal. So I know that the index of this animal is stored in the merge cell index variable, and I know that in our board we have the permanent data about all our cells. So now we can access our board by the index of the first selected animal and we can set it to null. And now in the same way, let's access the second animal and let's set it to a next level pet. Now let's test how it works. So I select the first animal and now if I click the second animal, you will see that both these animals are selected, but nothing happens. Actually, they have been replaced, but we didn't call the render function yet, so we don't see these changes on our board. For example, our buy button call our render function, so let's buy a new animal. And now you see that we have created an animal of the next level. So at first, let's call the render function. And also you can see that our newly created animal preserves the state of being active. So before the render function, let's reset our merge cell indexes. Now let's test this function again. I can select the first animal, and then if I select the second animal, you see that we create a new animal of the next level and this animal is not selected. So now let's work on the validation. So for example, if I have two animals of different level, I can't merge them. Let's check that the levels of animals are the same. I call this section validation, and now let's create a new if statement. So if their levels are not equal, we want to show this error to our user. For that we can use alert function. Here I need to write a message, so let's write that the levels are different. And then I want to stop this function, and for that I can write the return keyword. Let's test how it works. I select the first animal, and then if I select the second pet, you see the message that the levels are different. But then you see that both animals preserve the selected state, so we need to reset it. Actually, I can copy an entire reset block, and then I can add it to our validation. Now let's make the same situation. So you see the message that levels are different, and then you see that the selected state have been removed. Our function works correctly, but there are still several edge cases. We check only that the levels of our animals are the same. We don't check that the indexes are different. So it means that I can merge the animal to itself. So we want to prevent this logic, and for that let's add a new validation. If merge cell indexes are the same, let's write the message that you can't merge a pet to itself. And after that, let's add our reset block. Now let's test it. So if I click the merge button 2 times, I see the message that you can't merge a pet to itself. And then I see that the selected state is gone. Currently, the last level of our animals is 10, and this is a unicorn. And the problem is that we can't merge the animals of the last level because we don't have the animal of the next level. So let's also check that if there is no animal of the next level, you can't merge these animals. We have a formula for the next pet index. This is equal to our pet.level, and then we pass this index to the pets array, and this pets array returns an object. Actually, if there is no animal, it will return undefined. Let's check that if the next level pet is equal to undefined, it means that we are trying to merge the animals of the maximum level. And then I add a reset block. So now it means that the next level pet will always be an object. So let's remove this comment. And now let's test how it works. Currently I have 2 animals of the maximum level, and if I try to merge them, you will see the message that you can't merge animals of the maximum level. Now you see that in all these validations, we are using the same reset block. So to prevent repetitions, let's create a new helper function, reset indexes. In the helper section, let's write a new function. So we don't pass any parameters to this function because we will reset the global variables. Inside of this function, I reset our indices, but all the time when we do a change with our board, we call the render function. So here, let's call our render function also. And now I can call this function instead of our reset block. In all places where I have this comment reset, I replace this block with reset indexes, but only one word that we can't remove is return, because it stops the current function. And also, we are using the same block in the end of our function. There's also one counter that we need to increase for our UI. So when we merge our animals, we want to increase the counter of the best level animal. In our global variables, you see that we have a variable best level. Every time when we create a new animal, let's increase this counter. And now let's test how it works. So I have two animals and then I want to merge them. And now you see that we have the animal of the second level, so the best level counter is set to 2. So the best level counter shows 2. But actually, we can merge many animals of the same level. But here we have the problem that if I try to merge the same animals of the first level, we will increase our counter even though that we don't have a new animal of the third level. Instead of just increasing our counter, we need to check, does the level of the next level pet is higher than the current best level? So the easiest way how to check it is by using the math.max function. So we can pass many values inside of this function and then it will return only one number that is the highest. So in our case, we will pass two parameters. The first one will be the current best level and the next parameter will be the level of the next pet. So let's test how it works. Now, if I create a new animal of the next level, you see that our counter have been increased. But then if I create this animal again, you see that our counter remains the same. So now let's create a new animal of the third level. And again, our counter have been increased. So it means that our function works correctly. Now we have a fully working game where you can merge different animals and you can create a new animal of the next level. But every time when you refresh the page, you lose all the progress that you have. But for saving our games, we need to learn a new theory about JSON files. So at first, let's discuss how our project works in the browser. We have three main files: HTML, CSS, and JavaScript. Our HTML and CSS are static, but our JavaScript adds the functionality to communicate with our game. Eventually, I can click buttons and our animals, and then on the page, you see how our currency counter changes. On the page, you see only HTML and CSS. Even though that now you see another counter, our initial HTML file stays the same. And eventually, when I refresh this page, you see a new state of this game that was created from our initial files. Our files are connected to the browser, and our browser can ask these files again. Actually, we might have many users. So each user is a separate session that shares the same initial files. And then this user can communicate with our game to change the state of this game. So if we want to save this state, we can't save it inside of our initial files because it will influence other players of our game. So for example, I have this initial game, and when I buy a new animal, you see that the state of this game have been changed. And if then I save this state inside of our initial files, other users will see the same change on their pages. And this is the reason why we can't save our changes directly inside of our initial files. If we can't save it inside of these files, let's think, what is another place where we can save these changes? I added icons of other browsers to give you a clue. Actually, each user has its own browser. Even though that I showed 3 different browsers can be of the same instance. For example, all our users can use only Chrome browser. But the most important here is that each user downloads a browser directly to their device. So it means that all users have instances of their own browsers. And I can easily prove it because now I am in the Chrome browser and I can create a new tab, but you will not see this tab on your browser. So it means that I have the instance of my own browser that is saved on my computer. Actually, each browser has its own storage where we can save some data or files. Now we need to figure out what we need to save. At first you might think that we must save the copies of our initial HTML, CSS and JavaScript files. But actually it will not work because imagine if I want to create a new update for my initial files. Then it means that this user that stores the copies of my old application will always use the old application. Let's think what we change when we interact with our game. So all changes happens because of our script.js file. So actually when users interact with our page, they change only the game data, and then our JavaScript file recreates the HTML based on this game data. So it means that it would be enough for us to save only this data inside inside of the browser. So it means that I can store only my variables, but actually I can't store my variables directly. I need some kind of format for storing our data, and this format is called JSON. So at first, let's create a JSON file. For that, I create a new file with the name storage and with the type JSON. Initially, this file is empty, and now let's add some data that we want to store. So for example, let's store the counter of our currency. Let's call this variable poop, but if I write it, I will see the error that expected a JSON object. The JSON stands for JavaScript object notation. So it means that it uses the same syntax as objects in JavaScript. So this is an object in JavaScript, so we need to use the same syntax. So we need to start from the curly braces. So and then we know that JavaScript objects contain key value pairs. So let's write a pair poop that is equal to 10. If I just write poop, I will have the error that property keys must be double quoted. So this is the first difference between objects in JavaScript and JSON. In JSON, I always must put quotes for keys, and then I can write column 10. In the same way as in JavaScript, we are using column instead of the equal sign for showing that 10 is the value of the key poop. So and this is the easiest JSON file where we stored only one key value pair. So let's add another property, for example, best level. If I start typing a new key, you will see the error that expected comma. So it means that all my key value pairs must be separated with comma. So the value of the best level is 1. Also, if I try to put the trailing comma, you will see the error. Also, we can store other data types like arrays and objects. For example, I wrote board, which is equal to array of nulls. In our game, we have 16 cells, but here I wrote only 2. And then, for example, let's store a pet, which is equal to a new object. Now I can expand this object, and here I can write new key value pairs. So for example, I can write name level and reward. There are also some data that we can store. For example, we can store undefined. Inside of the board, if I try to write undefined instead of the null, you will see an error. So JSON can store only nulls, but can't store undefined. Also, we can store or call any functions. And this is because JSON is not like a JavaScript. This is similar to text files. So for example, I can open a notepad and here I can write console.log. So, and nothing will happen, and this is because all lines that we write inside of the txt file are just strings. So this is the same as writing console.log in JavaScript with quotes. The main difference between JSON and text files is that JSON has a specific structure, so this is easy to extract the data from the JSON. So now you know the basic syntax of JSON, so let's look how to work with it in the browser. At first, I have a simple web page with index.html, with style.css, and with empty script.js files. And then I connect to the browser by using the live server extension. So now here I see our web page that contains nothing, and let's open the console. So now let's write the first console log to see that our JavaScript is connected to the browser. So I see the response in the console, so it means that our application is connected. We connect all our files to our HTML file. And here, as you see, only our style.css and script.js files are connected. So we don't connect our JSON file. And this is because we don't have any initial JSON that we share with all the users, and we store JSON directly inside of each browser. So let's find the place where our JSON is located. For that, in the browser, you need to find this double arrow icon, and then you need to find the application option. So I opened my application, and here on the left side, you can see the storage. So we need to find the local storage. Now we can expand it, and then we will find a local storage for our local host. So this is the place where we will store our variables. As you see, we have a small table with key and value. So this is the representation of our JSON. So now inside of the JavaScript, let's write our first variable that we will store. So let's store our currency, but currently this currency is just a variable in JavaScript. At first we need to create a JSON string. For that, let's create a new variable poop.json, and then we have the built-in JSON object, and if you write dot, you will see two methods that this object has. So we will use the stringify method, and here I can pass the value that I want to stringify. So let's write the name of our variable poop. And also let's log to the console both these variables to see the difference. I return back to my console and here I see two variables. So our poop is equal to a number 10 and our poop JSON is equal to string of the 10. So simply it means that JSON.stringify converts all the data types into the strings. So no matter how complex our structure is, it will anyway convert our variable. Until your variable doesn't contain undefined or functions, the JSON.stringify will be able to convert it. And now let's save it in our local storage. So for that we have an object local storage. And this object has several methods, so you need to find the set item. Now this method expects two parameters, key and value. If you look to our JSON, you will find that this is the key of our variable poop and this is the value of the same variable. So let's pass them. And now let's open our application tab, and here you can see that in the table we have our first variable poop, which is equal to 10. Actually we created this simple JSON file. So and now let's do the opposite steps to get our variable from the local storage. So at first I need to write local storage and then I need to find the getItem method. This method expects only one parameter, which is the key. So let's write poop. This line will return the poop JSON. So let's store it inside of this variable. And now let's convert it back to our initial variable. For that, I will use the json.parse function. And now let's log to the console this variable. So in the console, you can see that we have the 10 and the type of this 10 is a number. So it means that we successfully load the data from our storage. Now let's also wrap this code into the save and load functions. I also found that inside of the save function, we use the hard-coded value 10, but actually I want to provide the poop JSON variable. And let's also write the load function. Now I wrapped our code inside of the functions. So let's also change these functions a little bit. So let's create a global variable poop. And then let's create the global variable poop.json, which is equal to null. And now inside of our functions, we just reassign our values. Inside of our local storage, we have the pair poop, which is equal to 10. And no matter how much I refresh this page, this value will be here until the user manually deletes it. But if you want to manually delete some pairs from the local storage, you can click on your pair and then you can press delete button, or you have a button clear all. So now you see that we have no values, and at first let's save our initial value. So for that, I call the save function. Now let's imagine that our user earns the currency. So a new value of our currency is 100. So let's store a new value of our currency. So as you see, in the local storage we have poop, which is equal to 100. And now let's imagine that our user refreshes the page. So we return back to the initial value, which is 10. But at this point, we can call the load function. And as you see in the console, no matter that the initial value of the poop is equal to 10, we loaded the previous state of our game. And in the same way, you can store complex data like arrays and objects. We learned about JSON and how to store our data in the browser. Now let's use this knowledge for implementing save load and reset buttons. So at first, in our HTML, where you see the div with the ID grid, let's remove all these manually created divs. You will not see any changes on this board, just we created them to better understand which divs we need to generate with JavaScript. And now let's go to our script.js file. As I said before, if we want to store the state of our game, we need to store the game data. Actually, we will store only these variables because our array pets is a constant, so user can't change it. So let's go through each section and let's think how to write the function for saving our data. I don't think that we need to add something to the game data, so let's go to the next section. Then I see HTML elements section. So here we access our HTML elements. Let's access our save button. Now I need to pass the ID of the save button HTML element. In the index.html file, I can find the button element with the ID save button. So let's copy this ID and now let's pass it into our function. So the next section is helpers. Currently I don't think that we will write any helpers. So let's go to the next section, core actions. And here in the end of this section, so before the rendering section, let's add a new function save. So this function will save all our game data in the local storage of our browser. In the local storage, we store JSON files which are converted into the strings. The JSON has the same format as JavaScript objects, so let's convert all our game data into the object. I create an empty object data, and now I need to write all these variables inside of this object. I put quotes before each key, even though that this is not mandatory in JavaScript. I put it so we can understand that this is the name of our key and this is the variable, so the data that we store inside of this key. So actually this is what we will store. So this is an array with a lot of nulls, or sometimes we have objects of our pets. So after we converted it into the object, let's convert it into the JSON string. For that, I create a new variable data.json, and now I can use the json.stringify method where I need to pass our data. So this function just converts our object into the string so we can store it inside of our local storage, and then we can easily convert it back with the json.parse function. So now let's store it inside of the local storage. Here we see several methods and we will use setItem. So this function expects two parameters. The first is the key, how our saving will be called. And the second is the value, so what we actually save. So the key is just a string. So let's write something like merge pet key. Actually, I know that we will use the same key in the load function. So instead of copying and pasting it all the time, let's extract it into a separate constant. So inside of our game data, let's add a new constant saving key. So I write it with capital letters because the keyword const in JavaScript doesn't always mean that this is a constant variable. So for example, here we declared our board with the const keyword, but actually this const just prevents the container, which is array, to be changed, but the user can change the data inside of this container. So this is the reason why this is not a constant, but here we want to prevent any mutation of the saving key. So only the developer can change the string. And I extract it because when we change our string, all the remaining functions should work. So instead of passing the hard-coded string, we pass the variable. So instead of the merge pet key, let's use our variable. So now we need to write the second parameter, which is the data that we want to store. So this is very important to write data.json. If you pass the variable data instead of the data.json, you will store the result object. This is a useless result. Just you need to know that when you see it in the local storage, it means that you saved the object, not a string. So now this function saves our data inside of the local storage. And now let's show a message to our user that the game is saved. So we finished our save function, and now let's go to the next section. In the rendering section, we update our UI and board. So actually when we store our game, we don't want to update any UI elements. So it means that we can skip this section. And then we have the trigger section. So here we can write our trigger. So when the user clicks the button save, we will execute the save function. And now we can test how it works. So currently I have 1000 currency, and let's click the save button. Now you see the message that game is saved. So I can click OK, and now let's open our local storage and see what we have saved. For that, you need to inspect the page. And then on the right top side, you will find two arrows icon. So here you need to choose the application option. So now inside of the storage section, you can find the local storage. You need to expand it. and then you will find the local storage for the local host that we have. So here you can find the key, merge pet key, and the value. So this is our JSON string that we saved. If I click it, you can see what this string contains. Here you see the best level, currency counter. Also you see our board. If we expand our board, you can find that on one cell, in this case on the cell with ID 13, we have our pet data. Now if I refresh the page, you see that our counter have been decreased, but if we check our local storage again, you will see that here we store 1000 currency. So it means that currently we can write the function for loading this data, and then we will be able to restore our state. So for the load function, let's go through all the sections again. In the game data, we will not write anything. Then we have the HTML elements. So here, let's access our load button. Now let's find this ID in the HTML. Here I can find the button with ID load button. Let's copy and paste it inside of our function. Then in the helper section, we will not add anything. Let's go to our core action section. Here, right after our save function, let's write a new function load. Now we need to do the same steps in the reverse order. So at first, let's access the data from the local storage. For that, I will use the method getItem. So this method expects one parameter, which is the key. So let's pass the saving key. And now this line will return our data JSON. So let's store it in the variable. And now we need to get our data from the data JSON. For that, we will use the json.parse function. Now we extracted the same data as in our save function. And now we need to use it to rewrite the global variables. So these variables we will rewrite, but we have one problem with the variable board. I can't rewrite it because we are using the const keyword. The proper way is when you remain the const keyword and then you write a for loop for replacing all the data inside of the board. But we will use the easiest way. So let's change the const keyword to the let keyword. And now it means that we can reassign our board. So inside of the load function, let's reassign all our global variables. And after we updated our global variables, we actually want to see these changes on our page. So it means that we need to call the update UI and the render functions. And after that, let's add a new alert message that the game is loaded. So now let's go to the trigger section, and here let's add a new trigger to our load button. So now let's test how it works. In the local storage, you have the previous saving with 1000 currency. So let's click the load button. Now I see the message that the game is loaded, and if I click OK, you see that we restored our game state. But actually, the load function is a little bit more tricky, because what if user clicks load button before it made any changes? So let's go to our local storage, and here let's delete this saving. And now let's try to load our game state. If I click this button, you don't see any changes on our page, but also you don't see the message that the game is loaded. So it means that we have some kind of error. Let's open our console, and here you can see that we have the type error because we can't read the property board of the null. So actually what happens? The data JSON is trying to access the item with the saving key, but we don't have this item in the local storage. So it means that the value of this line will be null or undefined. Then we are trying to parse the null value. In this case, we will anyway get the null or undefined. So json.parse can parse other data types, not only strings, but in this case, it will return the initial state. And then we have the line where we reassign our board to data.board. So this is the same as writing null.board, but null doesn't contain any board. So this is the reason why we have this error. So let's write a new validation that if our data is equal to null or undefined, it means that we don't have any savings yet. So it means that we shouldn't execute our load function. And now let's test how it works. I don't have any savings in the local storage. Let's click the load button. And now you see the message that no savings yet. And then nothing changed. Now I can say that our function works correctly. So now let's write the last function for the reset. Let's go through all the sections again. So in the game data, we don't need to change anything. Then we have the HTML elements. Let's access our reset button. In the index.html, I can find this ID reset button. So let's copy and paste it. So then I have the helper section. I don't need to add any functions there. Let's go inside of our core action section. And here, right after our load function, let's add a new function reset. So actually, this function does the same as when we refresh our page, but also I want to delete our saving when we click the reset button, because currently we don't have any way for deleting our saving. So the proper way would be to reassign all these variables to the initial value. But actually, there is one trick that we can use. So there is a function location.reload, and if you read the description of this function, you will see that this function like refresh button. So this is kind of tricky way how we can reset our game without reassigning our variables. And then after that, let's also delete our local storage saving. So inside of the local storage object, I have two methods that we can use. So the first method is clear. So this method clears all the keys that we store in the local storage. So currently we use only one key, and this perfectly suits for our case. But there is one problem. If in the future you will add more keys, you can forget that in the reset button, you use clear function that removes all of them. So and this is the reason why I prefer another function. Local storage object also has the function remove item. So in here we need to pass our key, and then this function will remove this key value pair from our local storage. So let's pass our saving key here. And now we know that reset function will delete only our key. So it means that if in the future I will add more keys, I will not have unexpected behavior. Also, we can write the message that the game is reset. Then I don't even need to add update UI or render functions, and this is because we have the section game start where we call all these functions. So when we use location.reload, we refresh the page, and it means that we recreate all this code from the beginning. So we call the game start functions also. So I think that the reset function is finished. Now let's add a new trigger to the reset button. And now let's test how it works. So at first, let's save our game state. I see the message that the game is saved. Now let's buy many animals. Now let's load our game state. I see the message that game is loaded, and now I see that we have our game state. Now let's reset our game. I see the message that game is reset, and now let's try to load our game again, and I see the message that no savings yet. So it means that all these functions work correctly. There is one problem with save and load functions that you need to be aware of. Currently, we recreate our data object based on all the global variables that we have. But what happens when we add a new global variable? So for example, I add a new global variable clicks. Now, to save my clicks, I need to change the save and load functions. So inside of the save function, I need to manually add a new global variable. And then I also need to go to the load function, and here I need to add a new variable to reassign. So actually, when we add new variables, we don't want to rewrite our functions. So and we have this problem because initially we chose the wrong way of saving our data. So let's remove these changes. And here in the save function, you see, we recreate this data object. So actually, from the beginning, we can save all the data inside of this object. So it means that in the game data section, instead of saving all our data into separate variables, we can create one variable data. And now we can store all our data inside of this variable. So for example, I store our board and poop. Actually, we can store all the data here, and then we can use only this variable data inside of all other functions. So for example, we have the function increase poop inside of the helper section. And here, instead of increasing the poop directly, we increase the poop inside of the data object. So currently I undo these changes, and this is because we have a long project with more than 200 JavaScript lines. So it means that if we recreate our global variables inside of the one object, we will need to refactor very a lot of lines. I don't want to spend your time on this. I consciously used the way of storing all the data in separate variables because this is a natural way how you store your variables. But currently, this is important that you know the problem that many functions needs to access these global variables, and it means that if you add a new variable, you will need to rewrite your functions. For preventing this logical error, in your future projects, store all your global data inside of the object. So now let's implement the autoclicker. At first, let's think what autoclicker should do. In the description of this feature, I wrote that autoclicker earns poopy currency every second based on your best pet level. Under our currency counter, we have the counter for the best pet level on the board. So currently, the best level that I have is the first one. So it means that autoclicker should click any of the first level pet each second. For example, if I merge these animals, now you see that I have an animal of the second level, so it means that our autoclicker should click this animal every second. In our code, let's go through each section and let's think what we need to add. The first section is the game data. We already stored the best level, so let's return to this section later. The next section is HTML elements, and here we can access our autoclicker button. So let's go to the HTML to find the ID of this button. In the index.html, I see that we have a button with the label enabled for 16 poopy currency. So this is the button that we have on our page, and the ID of this button is auto button. So let's copy this ID, and now let's paste it inside of the getElementById method. So now let's go to the next section. In the helper section, I see the increasePoop function, and we even can pass the reward directly to this function. So we can use this function for our autoclicker. And now let's go directly to the trigger section, and here let's add a new trigger. So for example here, I can add the event listener that will call our increasePoop function on the click. Now let's test how it works. If I click the enable button, you will see that nothing happens, and this is because increasePoop function expects one parameter. So for passing this parameter, we put the parenthesis, but parenthesis executes this function immediately. So actually it means that we need to use the anonymous function to pass our increasePoop as a variable. So now let's test it again. I can click the autoclicker, and now you see that our currency counter increases by 1. But actually we want to enable this autoclicker, and then we want to set interval that will click our pets automatically each second. So at first, let's expand our anonymous function. So for that, I need to add curly braces, and then I can expand them. And now I can write multiple lines inside of this anonymous function. So at first, inside of the increasePoop function, we pass the hard-coded value 1, but actually we want to pass the reward of the best level animal. If you go to the game data section, you'll find that we store the best level, but actually the best level is not always equal to the reward. As you see in our constant pets, we have two different columns, one for the level and one for the reward, and they are not always equal to each other. So let's write a small helper function that will find the reward based on the best level. So inside of the helper section, right after the reset indexes, let's write a new function. So I call this function getBestReward, and now we need to get this reward from the pet's constant. So at first we need to find the index of the animal that we want to access. If you look to the pets constant, you will find that our levels are from 1 to 10, so they are 1 based. But actually we store them inside of the array, which is a 0 based. So it means that the pet index is equal to the level of this pet minus 1. And now we can find the animal by using this index. So this code will give us a pet object, so let's store it inside of the pet variable. And now you see that inside of this object, we have the reward. So let's access it. And now we can return the reward. Let's use this function instead of the hard-coded value 1. So inside of the trigger section, I call the getBestReward function. Now let's test how it works. The best level on the map is 1, and if I click the autoclicker, you see that my counter increases by 1. Now I have the animal of the second level, so this animal has the reward 2, and if I click our autoclicker, you see that our counter increases by 2. So it means that our function works correctly, but we still don't have our autoclicker. Currently we need to click this button manually. Let's add the interval that will increase poop each second. For that, I have the function setInterval. This function expects two parameters. So the first parameter is the function that we want to call. So in our case, we want to call increasePoop function. So let's put it inside of the setInterval. And the second parameter is the amount of seconds, how often we should call this function. So we want to call it after each second, but this function expects milliseconds, so I can write 1000 milliseconds. And now let's test how it works. If I click the enable button, you will see that we again increased our counter by 1, but then our autoclicker doesn't work. And this is because we wrote increase poop function with parentheses. So again, this function executes immediately, but actually we need to pass this function as a variable. So for that, let's wrap it inside of the anonymous function. And now let's test how it works. If I click the auto clicker, now you see that our currency counter increases by 1 each second. Let's buy a new animal and let's merge them. Now I have the animal of the second level and you see that our counter increases by 2. So it means that our function works correctly. Actually, we have one severe problem. We can click our enable button several times. And now you will see that our counter increases much faster because each time when you click this button, you add a new interval. So we want to prevent this behavior, and for that, let's check that if we already have our set interval, it means that we need to do nothing. For validating do we have the set interval or not, we need to add a new global variable. Let's add a new variable autoclick enabled. This will be a boolean and initially it will be equal to false. So it means that our autoclicker is not enabled. Now let's return back to our trigger and here let's check that if our autoclicker is enabled, it means that we need to do nothing. So we can finish this function. For that we can write if autoclicker enabled and only if this value is equal to true, we will go to the body of this if statement and we will call the return keyword. So return keyword will finish our function. But now we need to enable our autoclicker. At this point, I know that our autoclicker enabled is equal to false. So let's set it to true. Now we can test how it works. I click the autoclicker button and now we see that autoclicker is enabled. And if I click several times, nothing happens. We still see that our counter increases with the same speed. Actually, our autoclicker has a cost, which is 60 rupee currency. Let's also validate that our player has enough currency. So before we enable our autoclicker, let's add a small validation. So I check that if the currency counter is less than 60, it means that our user doesn't have enough resources. So I show the message that you don't have enough poop and then I finish this function. But if our user has enough currency, let's update our counter. Also, let's update the label so our user will see that the autoclicker is enabled. So I changed the text content of the autoclicker button and now let's test how it works. If I click the autoclicker, you see that our button changes the label to the enabled and now you see that our autoclicker works. I can't buy more than one autoclicker, but we also need to think about our save, load and reset buttons. So currently, when I save our game, I don't save the state of our autoclicker. So let's test how it works. At first, I save our game. And then I load the game. In this case, our autoclicker is still enabled, but if we refresh the page and then load our game, you will see that our autoclicker doesn't work anymore. Let's save our autoclicker enabled variable. Inside of the save function, I will add a new key value pair. And now let's go to our load function, and here let's also update our global variable. Now let's test how it works. At first, I buy our autoclicker. Now let's save this game. Then I refresh the page. And now I load our game again. And as you see, nothing happens. And this is because when we refresh the page, all the intervals that we had on our page disappear. So this is just how the refresh button works. So it means that we can just store our variable. We also need to start a new interval. For that, let's copy these 3 lines. And now inside of the load function, after we updated our global variables, let's start the autoclicker. Now let's test how it works. I buy a new auto clicker, then I refresh the page, and then I load the auto clicker again. And now you see that our auto clicker is enabled and we again earn our currency. But now we still have several problems. Currently, I start a new game. Now let's save a game without the auto clicker, and then let's load our game. You'll see that our auto clicker enabled, and this is because in the load function, I don't check the auto clicker enabled variable. So let's wrap these 3 lines inside of the if statement. Now it means that I will set a new interval only if the auto clicker enabled is equal to true. Also, I can remove this line because we already have checked that this variable is equal to true. But we still have one severe bug. Let's start the auto clicker. Then let's save it, and now let's load our game several times. Now you see that our counter increases much faster than once per second, and this is because every time when we call the setInterval function, we create a new interval on top of the previous one. So all the time when you create a new interval, you must think where you clear this interval. Currently, the only one way how we remove our intervals is the refresh button, but I want to show you a proper way how you need to finish your intervals. For that, you have a function clearInterval which expects one parameter. This is ID, and the type of this ID is number or undefined. So this is the ID of the previous interval that we want to stop. When we call our interval, we actually can store the value of this interval inside of the variable ID. And then we can pass this variable inside of the function clearInterval. And this is because every time when we create a new interval, this function returns a unique ID that we can use for the clear interval. So actually, we don't want to call our clear interval right after the set interval, because it means that we start our interval and then we finish it in the same function. So for implementing this logic, let's create a new global variable autoIntervalID, and then let's write 2 functions, start autoClickerInterval and stop autoClickerInterval. Instead of declaring the autoInterval ID inside of the trigger, let's declare it inside of the game data section. So the initial value of the autoInterval ID is null, and let's also change the const keyword to the let. So now we can reassign this variable. So let's copy it and paste inside of our trigger. Now I reassign our autoInterval ID after I call our interval. Then let's remove our clearInterval function. And now let's write the function start autoClickerInterval. So inside of the helper section, after the getBestReward function, let's write this function. We will not pass anything inside of this function because we store the data about the intervals inside of the global variables. Now let's copy this line from the triggers and let's paste it inside of the start autoInterval. We will also use this function when we load our game. Here we also can write a small validation that if our autoInterval ID is not equal to null, we need to return our function. Now I'm sure that autoInterval ID creates a new interval only if this variable is equal to null. And then let's write a new function stop autoInterval. And here let's clear our interval using the autoInterval ID. Also, we have the second global variable, which is autoClicker is enabled. So inside of the start autoClicker, let's set this variable to true. And inside of the stop autoInterval, let's set it to false. Also, when we start a new interval, we want to change the label of the enable button. So let's add it inside of the start autoInterval. And now let's go to our trigger section. So here, instead of these 3 lines, we can use the start autoInterval function. And now let's go to the load function. So here, at first we need to stop the previous interval. I call the stop autoInterval function, and I don't even need to add any validation, because if the setInterval ID is equal to null, our stop autoInterval will do nothing. And then inside of the if statement, let's call the start autoClicker function. And now let's test how it works. I enable a new auto-clicker, then I save this game, and then I load this game again. Now you see that our auto-clicker doesn't work, and this is because in the stop auto interval, we reassign our auto-clicker enable to false. And then I check that if this is equal to true, I start a new auto interval. So actually, inside of the stop auto interval, I shouldn't change the auto-clicker enabled. Instead of it, I can reassign auto interval ID to null. So now, if you test how it works, you will see that everything works as expected. My congratulations, you have finished this game. There is still a lot of space for the improvements, so if you want, you can improve this game your own. But we will learn a new theory, and after that, we will work on a new project. Error handling in JavaScript. Sometimes we can type something wrong, and JavaScript will throw an error to show that we have a mistake in our code. So for example, let's create a new variable num. Now in the console, you can see that the value of num is 0. But now let's remove the equal sign. In this case, we have uncaught syntax error with the message that unexpected number. So this is how JavaScript shows that we did something wrong. But what is the problem? After the point when JavaScript found our error, it will not execute the rest of our code. So and this is the reason why I don't see the result of my log in the console. Let's return our equal sign back, and now let's change the let keyword to the const. And then let's reassign our num to 1. We know that we can't reassign the constant variables, so it means that this line should throw an error, but after that, let's log to the console the num. Now in the console you can see that we have the result of the first console log, but then we have our error. In this time, this is a type error with the message that assignment to constant variable. And then you see that we don't have the result of the second console log. Sometimes you don't want to stop the execution of an entire program just because one line fails. And for solving this problem, we have a try-catch block. So every time when you write a code that might throw an error, you can wrap it into the try and catch block. I add our reassignment to the try block, and then I need to write the catch block. And now inside of the parentheses of the catch block, you will see a name, something like error. Actually, for this attribute, you can give any name that you want, but the real value will be the error object. And then we can display this error object into the console. So and now, if I save this file, you will see that we still have the value from the first console log. Then we have our type error, but this doesn't have the error styles anymore. And then you can see that we have the value of the second console log. And as you see, this number is still equal to 0. So it means that the num equal to 1 haven't influenced our variable. So every time when you add a code inside of the try block, if this code throws an error, JavaScript returns back to the previous state that we had before the try block, and then it passes the error object inside of the catch block. Also, if you want to change the styles of this error, instead of writing console.log, you can write console.error. And now you see that our message looks like an error, but this doesn't prevent our further code from the execution. Also, instead of the console.error, you can write console.warn. It doesn't change the code behavior, it just changes the styles of this message that you see in the console. But I will return back to the console.error. So there are many different built-in errors that we can catch by using try and catch block. But sometimes we want to add custom errors. So for example, if we have an input from a user and then we want to validate it. For example, I can type the built-in function prompt, and if I save this file, in our browser, you will see a pop-up with the message that please type your age. And then I can type whatever I want. So if you hover over the variable age, you will see that the type of age is equal to string or equal to null. So it means that no matter what kind of text we type inside of our prompt, if we click the button OK, it will be converted into the string. And if we click cancel, this function will return null. Currently I click cancel, and now let's validate this input. So let's write an if statement. And inside of this if statement, I control that if our age is equal to null, and then let's throw a new custom error. So for that, I type the keyword throw, and then I need to write new error. This will create a new error object, and this object expects only one parameter, which is a message. So now I can type something like age cannot be equal to null. If I save this file, you will see the pop-up again, and if I click cancel, you will see the error in the console that age cannot be null. And now let's check that if our age is not equal to number. At first, I want to show you how to convert our string into the number. I write a new variable result that is equal to 30, and then I log to the console the result. Now we can see 30 in the console, but we also see these white styles, which means that the type of result is equal to string. So the easiest way to convert it is by wrapping the result to the number object. Now you see that the styles of the result have been changed. But what happens when we try to convert a random string? In this case, we convert it into the none. This stands for not a number. Now let's return back to our previous code. So at here, let's write that if our age is equal to none, so at first, I wrap our age inside of the number object. Actually, if you try to check it in this way, this statement will always be equal to false. And this is because not a number is always unique. So it means that this is not equal to any another not a number. And for checking it, we have a built-in function is none. So let's rewrite this validation in the way that it will work. So now this function is none will give us a boolean, so it means that it will be equal to true or false. Now this if statement will execute if the function is none gives the true. I also can explicitly write if this function is equal to true, but this code is the same as the previous one. So now let's throw a new error. And inside of this error, we can type the message that age must be a number. Let's test how it works. So I see my pop-up, and this time I will type a random string, and then I press OK. And now you see the error that age must be a number. But at this point, we show our errors in the console. So let's show these errors to a user using the alert function. I can wrap our validation into the try-catch block. And now, instead of showing this error inside of the console, let's use the alert function. So this time let's close our console, and now let's refresh our page to see how our code works. So at first you see a pop-up with the message that please type your age. So I will provide a random string. And in this case, you see a message that error, age must be a number. Actually, try and catch block is not a final. It also has the third part, which is finally. So this part will be executed no matter do we have an error or not. So actually, this is the same as writing our code outside of the try catch block, but the finally block has a specific semantical meaning. So very often inside of the try block, we open some files or we get the data from the internet. In this case, inside of the finally block, you can close these files or close the connection to the internet. The code inside of the finally block is a part of our try and catch block. So you just need it for separating your code into logical groups. How to get the data from internet in JavaScript. Today we will be talking about fetch, promise, and async await. All these topics are large, and actually on the YouTube you can learn them independently. So I remember when I learned them independently, I really had a lot of problems with combining them together. And now I think that you actually should learn them together to understand how modern programming works. So we will learn a lot of new theory. It will be difficult, so you need to practice a lot to actually understand these topics. But I will try to explain it as simple as possible. So at first, let's start with some console logs. I wrote 3 console logs, and now we see the action 1, action 2, and action 3. So the data is not important. I want to show that these functions have a specific order, and this is how we used to write in our programming. So if I change the order of these logs in my code, I will see the result with the changed order, so I can control it easily. Then I want to get the list of users. So it will be similar to pets that we had in our game. So this is a list of objects. Here I want to get the same result, just instead of writing this list in our code myself, we have this URL, and if I connect to this URL, it will return me a list of users. So for that I have a built-in function fetch. And now let's log to the console our users to see the result. So, and instead of the list of users, you see a promise with a status pending. function fetch needs some time before it returns the real data. So for example, console.log with the hard-coded string takes around 1 millisecond. Actually, even less, just let's say that it takes 1 millisecond. So it means that all these functions take 1 millisecond for execution. When our JavaScript starts the execution of the first console log, it sees that after 1 millisecond we have the result. So and then we can go to the next console log until we get to the fetch function. So this function connects to the internet and it takes around 200 milliseconds before the data really arrive to our computer. So we know that JavaScript waits for 1 millisecond, and it means that when JavaScript wants to execute this line and set the result to the user's variable, it sees that, okay, after 1 millisecond I don't have any response, so let's just go to the next line. And on the next line we want to access the users, but we know that the user's value is still unknown. So instead of throwing an error, fetch function returns a promise with the status pending. So eventually in our console log we see this promise. So it works in this way that this function takes around 200 milliseconds, and after 1 millisecond JavaScript wants to go to the next line. And to avoid the undefined value for our users, we have a promise object. It just means that the value will be somewhere in the future. Promises can have 3 different states. In the first state we have the pending. It means that the data will be somewhere in the future. Then we might have the fulfilled state. It means that the data have been arrived on your computer successfully. And we also have rejected, which means that we had some problem in the internet, so the data have not been arrived. Now let's write a simple timeout function that waits 1000 milliseconds, and after it logged to the console the same variable users. Now in the console you can see that we have the promise with the status fulfilled. So it means that if we access the same variable after 1 second, the data will be arrived on our computer and we can use it. But anyway, promises are just objects. They just show the state, like the data is arriving or the data have been arrived. The real data is inside of the promise, so we need to parse it. So at first, let's comment out our timeout and then let's wrap our users into the function. I wrote a new function fetch users and then I called it in our code. Again, you see that our promise is in the pending state. And now we know that this is because fetch takes time before the data will be arrived. So, but we actually want to wait until the data will be arrived and then we want to extract it. And for solving this problem, we have async await. So at first I need to write a sync keyword before the function. It will make my function asynchronous. And then inside of the async functions, I can call the keyword await. So and this keyword says to JavaScript that you must wait until the data will be arrived and then you must extract this data. And now in our console you see that we actually have some kind of response. So this is an object that actually contains our data. So if you expand it, you will see that our body is a readable stream. So this is still not an array of users, and this is because the data from the internet is coming in small parts. So we will not talk a lot about it, just you need to know that it takes time before all the data will be arrived. And then you might think that readable stream is just a data type, the same as an array or a number, a string, and there is a specific algorithm how to get the JSON from the readable stream. We need to convert our readable stream into a string, and then we will be able to convert it into a JSON. So as you remember, JSON is just an object. So this is the same kind of object as we had in our game, just it has several limitations. For example, the values cannot be undefined. But for the simplicity, we can just say that JSON is a JavaScript object. So the JSON is a real data that we want to get, and this algorithm is always the same. So this is the reason why we have a built-in function to convert our readable stream directly to the JSON. For that I can write users.json and it will do exactly these 2 steps. So it will convert our stream into the string and then into the JSON. Here is still one problem. If you log it to the console, you will see that again we have a promise. So it means that parsing of our stream takes some time that is longer than 1 millisecond. And this is the reason why we need to write the await keyword. And now, if you look to the console, you will see that we have an array of objects. And if you expand it, you will see that this is an array of people. So we have the information like ID, name, then username, and so on. Now, the structure of this data is actually the same as we had in our game. And now there is no difference of working with this data that we manually write inside of our JavaScript file or this data that we fetched from the internet. For example, now I can write a for loop and then I can log to the console each person individually. So at first, let's declare a new user. So I see that my user JSON is an array, so it means that I can use square brackets with a specific index. For example, it can be 0, or I can write a dynamical value like I, and then I can log to the console each user. I also found that I forgot to write the length, so here I need to write the length. And now, if I save this file, you see that we have 10 individual users in our console. And as you see, they keep the order. So we see the user with ID 1, then the user with ID 2, and so on. So they keep the order. You might also ask why I haven't written the await keyword before the user JSON. Actually, you may write this keyword. So if you save this file, you will not see any changes, but await keyword affects only on promises. We know that our user's JSON is an array. When we access a specific index, this is an object. So this is not a promise, and this is the reason why we don't need to add this await keyword. We also can say that it takes 1 millisecond for JavaScript to access an individual user. So with experience, you will understand much better when you need to write await keywords, just a simple rule. So let's remove the await keyword from the user's JSON, and then let's log to the console this variable. So every time when you see promise, especially with the status of pending, it means that somewhere you needed to write await keyword. I returned our await keyword back, and now let's also talk about the difference between synchronous and asynchronous functions. I want to take these console logs and then I will put them after the fetch user's call. And now if I save this function, you will see that even though that I wrote our console logs after the user's fetch, in the console you see action 1, action 2, action 3, and only after that you see our users. And this is because console.log is a function that is synchronous. So it takes 1 millisecond, or let's just say very few time, to be executed. So JavaScript can do it immediately. The same with the rest of the logs. But the function fetch users is asynchronous. So it means that it takes some time before JavaScript can execute this function. And this is the reason why this is difficult to keep the order of asynchronous functions. I can say you a simple rule that works in 99%. If you call several functions, at first JavaScript executes the synchronous functions and only then it executes asynchronous functions. This is not a strict rule because actually it depends on the time of execution. So here we assume that this function takes 1 millisecond, but this function takes 300 milliseconds. And actually the time of execution is not fixed. So for example, in our fetch users function, in the first fetch it can be 200 milliseconds, but then in the second fetch it can be 210 milliseconds. And this is because internet a little bit random, so we don't know the exact path how our data is going to our computer. So and this is the reason why we can't say the exact fixed time. We can just calculate some kind of average. But a very simple rule that works in 99% is that at first the synchronous functions will be executed and then the async functions will be executed. And for keeping the order inside of async functions, you have the await keyword that actually waits until the data will be arrived and then it extracts the data, and only after that the next line that relies on this data will be executed. Now you learned a lot of theory about asynchronous functions, and actually you need to practice a lot to deepen your understanding of this topic. Today you will be solving two different API challenges, where you will practice fetch promise and async await JavaScript functionality. About the structure of this video, at first I will show you the description of a task, and then you can try solving it your own. If you will stuck on any step, I will be solving the same challenge line by line, so you can stop on any point and then you can continue your own. So in the first challenge, you need to find a product with the maximum price. You need to use this URL, https://dummyjson.com/products. Then you need to fetch this list of products, so each product will have several properties and one of them will be price. And eventually you need to find a product with the maximum price and finally log the price to the console. So now you can stop this video and solve this challenge yourself. But now let's solve it together. I connected to the browser by using live server extension, and now let's call this function. So in the console you will see an empty line, and this is because our function logs to the console an empty string. So we can change this parameter. For example, we can write hi. So it means that our function works, and now we can see in the console the result. So now let's start solving this challenge. So at first I would connect to this URL. For that, in JavaScript we have a function fetch. But the function fetch takes time before the data will be arrived, so it means that we need to use async await. So now we get the response, but as we remember, if I expand the response, you will see that the body is a readable stream. So it means that we need to parse the data to the JSON form. For that, I will use the method .json. Again, we see a promise in the console, so it means that this function also takes time and we need to write await before this function. So now we have our JSON, so the next step would be to determine the structure of this JSON. So JSON always starts from the curly braces because this is a JavaScript object. Then let's expand it and we see 4 different parameters. We see limit, products, skip and total. So we need to get the products. And then I see that products contains an array of objects. So let's expand it. And now I see many objects. So then let's expand one of these objects. And here we need to find the property price. So we can find the price inside of this object. And the type of the price is a number. So this is exactly what we want to get from this object. So now when we know the structure, we need to think how to get the price. At first, you might think that we need to iterate through all the objects, but the first item is an object. So this is not an array, and it means that we can just store it in a separate variable. But inside of this object, I see the property product, which is an array. Let's store this product into a separate variable. So I call this variable products array, so we can clearly see that this is an array, and then I logged it to the console, and now we see that this is an array of objects. So now we can write a for loop. Inside of the for loop, we want to access each item individually. So for that, let's write a new variable product. I access each product with the dynamical value I, and also I shouldn't write await keywords because await keyword affects only promises. So when you see your data in the console, it means that the data has already been arrived and you don't need to wait it anymore. Now in the console, we can clearly see all our products, but we still need to access the price. Let's write a new variable price. Now we access the price of this product. So how to determine the maximum? I think that the easiest way is to create a new variable outside of the loop, and then we will call it max price. I also declare it by using the let keyword because we will change it later. And then I can give a default value, for example 0, because we want to start from the minimum price and then we'll compare it to the actual price that we have. So for that, let's write an if statement. So I check that if the current price is higher than the maximum price, it means that we need to reassign the maximum to the current price. And then we can log to the console the maximum price, but we need to do it after the for loop. So when we have iterated through all the objects, and here I see that 2499. Actually, in the example log, I wrote a different number. Let's change it because this result is actually the right. Also, don't worry if you have a different answer. We fetch the data from the internet, so we don't actually know when this URL will change the data. So there is still a small chance that after some time, the data will be different. So now let's continue with the second challenge. In this challenge, you will fetch a random user's data several times. So for that, you need to use this URL, and your goal is to collect the countries of randomly generated users into an array and then log it to the console. So here I can't say you the right answer because this URL always generates a random person. One important note, even though that I wrote that you need to get the countries of free users, it doesn't mean that you can hardcode them like user 1, user 2, user 3. You need to write this code in the way that even if I change this number, for example to 10, you will not even need to change your code, you will need to change only one number. So now let's try solving this code yourself, but then we will solve it together. So at first, I also call this function to see any results in the console. So now in the console, I see the result, so it means that I am connected to the console. Then let's think how to solve this challenge. So as I said, this URL generates a random person. So we need to call it at least 3 times. But how to call it without making a new variable? Actually, we can use a for loop, and then inside of the for loop, we can call this URL. Just right now, in the for loop, I hardcode this number. So then, if we want to get 10 countries of the users, we can just change this number. Now let's fetch to the URL. We see promises in the console, so it means that we need to use async await. Now I can see the results, but if I expand them, you see that this is a readable stream. So we need to convert it into the JSON. So I remembered that this function JSON also takes time, and this is the reason why I wrote await keyword. Now we can clearly see 3 results in the console. I want to see only one user right now, so I will change this number to 1. And now let's determine the structure of this JSON. It starts from the JavaScript object, then I see 2 parameters, info and results. If you expand the info, you will see different metadata that we will not use. So it means that we need to get the result. And then I see that the result is equal to an array of object. Let's expand this result. This is an array that contains only one object, so we can access it with the index 0. Then let's expand this object. So you will have the same structure of this object, but the data will be different. And this is because this URL generates a random user. Now we need to find the location, and this is equal to object. So let's expand this location. And here we need to find the country. So here I see United States. So this is a string. So now I know the structure of this JSON. And when I refresh the page, I see a new data, but the structure is the same. The initial type is an object. And here we want to access the results. Let's write a new variable. Now in the console you see that the result is an array and it contains only one object. So we don't even need a for loop, we can just access it by the index 0. And now I see that our user is an object. So and here we want to find the property location. The location is also an object, and here we want to find the country. So and this is the actual data that we need to access. So now we need to store them into an array. So for that, before the for loop, let's create a new variable. I create the variable countries, which is equal to an empty array. And now instead of logging this country, let's push it to our array. And then let's log the countries to the console. Now I see only one country, so let's return this number back to 3. And now, after some time, I see 3 countries in the console. So if we want, we can even change this number to 10. and then as the result we will see an array with 10 country names. My congratulations! Now you have solved these two challenges, and it means that you can work with basic APIs. So why we call these challenges API challenges? API is a data that you get from another source. So for example, from the internet or from another application. So in this challenge, we have been accessing the data by using the JavaScript fetch, promise, and async await functionalities. I remember when I only have started to learn about map, reduce, and filter, it was really difficult for me to understand when I need to use each of them. But now, based on this experience, I know how to explain it as easy as possible. Let's start from the for each function. I have a simple array of ages. And now imagine that you have a new business rule. Valid ages for your company are only from 18 until 100. And now your task is to filter the valid ages from this array. So at first, let's solve this problem with a common for loop. And now inside of this for loop, let's initialize our variable. So for filtering these ages, I write a new if statement. So and inside of this if statement, we will check that the age is valid. Let's say that both numbers are included. So the first statement is if our age is higher or equal to 18. Then I write and if our age is less or equal to 100. So in this statement, we create a range from 18 to 100. Now it means that at this point the age is valid and we need to add it to some kind of array. So let's create a new array. And now let's push the current age into this array. So let's log to the console the valid ages. And now we see two numbers, 35 and 37. So if you look to this array, you will find that only two numbers are valid. So this is a pretty common task that you need to do, and for that you can use a common for loop. But now let's solve the same problem with the method for loop. So at first, let's declare a new array, valid ages. I put 2 at the end of this array because I want to initialize an array with keyword const. And now let's write our method for each. So this is a method that we can attach to any array. The idea of this method is the same as in the for loop. So we go through each value of your array. Then we typically write anonymous function and curly braces if we want multiple lines. Let's expand this curly braces. And inside of the parentheses, let's write a name that will have a value of each our item in one iteration. So basically we write the same thing as we declared on this line. So and this is the reason why I write age. So now let's write the same if statement as we have in our for loop. Then let's log to the console the valid ages too. And now you see the same result in the console. So this function does the same thing as a common for loop. And initially you might think that this is a little bit more complex, so why we need two different for loops? So actually you might write with a common for loop, but if you start to learn some frameworks like React, you will find that most of the for loops are written in this way. So this is just a convention of this framework. Also, this method has its own advantages, because if you look to this code, you will see that we don't have the index. Like in our common for loop, we must declare I. So here we don't have this index, and we can directly access the variable just by writing this name age. So basically it removes all the unnecessary code that is inside of the for loop. But this function has several limitations. So at first we don't have the index, and it means that we can't access the values based on the index. So basically the same as in the while loop, you actually can create your index if you want, but typically if you need an index, you will use a traditional for loop. So then, if you understand the for each, it will be much easier to understand the remaining functions. So now let's talk about map, and the first thing that you need to understand that this is also a for loop. We attach this method to an array in the same way as we did with for each, and this function has a specific semantic. So it takes each element from our initial array and then it maps, so it converts them to a new array with the same length. So for example, we have an array data that contains several numbers and some of them are invalid. So we can convert them into the numbers, and then we can convert all invalid numbers to the 0. And this is actually the task that suits very well for map. So we take each item from this array and then we modify it into a new item. And one of the important constraints that you have, the output array is fixed and it has the same length as the initial array. So let's start coding it and I will show based on the examples what happens. We start from the anonymous function and with the curly braces. So now we can expand them. And then as before, here I can write a name that will take a value of each item in our array. So here, because our array data is just an abstract array, we can write something like item or element. And this will be equal to each value from this array, because we remember that map works in the same way as a for loop. Then we need to create an array where we will store these items. So because the output is an array and map always returns an array, we can declare this array on the same line with the map. And now I will not do anything, let's just log to the console the map data. Now in the console, you can see that we have an array with the length 4 and with the values of undefined. And this is because map always returns an array with the same length as our initial array. Then to push our item into an array, we need to write the keyword return. And then let's write the value of what we want to return. So if we just write the item, it would mean that we return the initial array because we go through each item of the initial array and then we just return it. Now let's convert it into a number. For that, I can call an object number. Now we see that we have an array of numbers and the last number is none because 4s can't be converted to a valid number. And for example, instead of the none, we want to see 0. So let's add a new if statement. I check that if I convert the item into a number and then if this is equal to none, for that I can't control it with free equal sign, I must use a function isNone. So now we wrote that if the converted item into a number is equal to none, it means that we need to return a default value which is 0. And now you can see that in the console we have 1, 2, 3 and then 0. Now let's talk about the method filter. We have the same initial array and now we want to remove the invalid parts. So this task perfectly suits for filter method because the semantics of this method is to go through each item of our array and then to remove the unnecessary ones. Now we will not convert our strings into the numbers because filter shouldn't modify the data. It should only remove the unnecessary ones. As always, we start from the same anonymous function and then inside of this function we pass a name. Now this name will have a value of each item from our array. And then let's think about the output. We want to return an array that contains elements from the initial array. So as the function map, filter also returns an array, but at this point the length is not fixed. So we start from an empty array. Let's write a new variable filter data on the same line. And now let's log it to the console. So as you see, initially method filter returns an empty array. So now we can start writing our condition. For that, let's write a new if statement. Now inside of this if statement, let's convert our item into a number. And now let's check that if this number is not equal to none, it means that this is a valid item and we can push it into our array. So for that we write return item. So now in the console, I see 3 numbers, 1, 2 and 3. And you see that the types of these numbers are the string. Now let's talk about the most complex method, reduce. So we have the same initial data and now we want to sum all valid elements to one number, which is a total sum. And this will be equal to 6 because 1 plus 2 plus 3 is equal to 6. So we don't count invalid elements. And this is exactly the work that reduce method does. So this is the same for loop that goes through each item from an array, but then it converts all these values into just one result. As always, we start from the anonymous function. Then inside of it, we will not pass only one name, we will pass 2 different names. So the first one is a total. So this is what we will return. Eventually, it should be equal to 6. And the second element is the item. So it will have a value of each element from our array. But now we also need to write a default value. So for that, I will expand curly braces. And then between curly brace and parentheses, I will add the default value for total. So let's start from the 0. So this can be a little bit tricky, but you need to understand that this is actually the same as writing let total is equal to 0. So the name is the first parameter of anonymous function and the value is what we have before the parenthesis. But now let's declare a variable total sum on the same line. And let's log to the console the total sum. So you see that if I don't return anything, it is equal to undefined. So this is the default value that all functions have if they don't have any return value. But now let's return the total. And you can see that this is equal to 0. So then our idea is to take each item and at first to convert it into a number, then to validate it, and then to add it to the total. So at first, let's convert it into a number. Then let's validate that this is not equal to none. And now it means that we can add it to the total. If I save this file, you can see in the console that the total sum is equal to 6. So it means that we took the first 3 values from this array, we converted them into the number, and then we summed them together. And also, we have tried to convert the last number of the initial array, but then we found that this is equal to none, and we just ignored it. I understand that without practice, all these functions might feel very complex. But the most important that you need to remember that all these functions are just for loops that complete a specific job. You can write all of this code without these functions with just a for loop, but in many cases, the for loop solution will be much more unreadable. Today we will be practicing map filter and reduce. We will be solving several code challenges, so at first I will read you the description of the challenge, then try solving this challenge by using map filter and reduce functions. If you can't solve it with these functions, try solving it with common loops. And finally, I will solve this challenge with you step by step, so you will be able to compare your solution against mine. So let's start from the first challenge. Here you will need to find only small balls and convert them into objects. For that you will have a function find and convert small balls that expects one parameter. So this parameter is an array, for example this kind of array, and each value of this array can be small, medium or large. And then you need to convert this array into an array of objects where each object represents a ball with a size small. Try thinking about how to solve this challenge with map, reduce and filter. You can use one or more these functions. But right now, let's solve this challenge together. So I start from the same function, find and convert small balls, and then let's think how we can convert this array into the result. As the name of our function says, at first we need to find. So it means that we have this array, and then we want to stay with an array that contains only small strings. So as you see, we had an array and we stay with array. The length of a new array is different, but the data is not modified. We just remove the unnecessary items. So this is exactly the work of the filter function. So let's convert the initial array into this one by using the filter function. And as you remember, filter function returns an array. So we can store it directly on the same line. And then inside of the parenthesis of the anonymous function, we can write the name like size. And this name will have a value of each object from the initial array. So let's expand the curly braces. And now let's write the logic. So for that, we need to check that if the current size is equal to small, it means that we want to push it into our filtered array. But inside of the filter function, instead of the method push, we can use the keyword return. Here the keyword return doesn't stop the loop, it actually pushes the result into the filtered array. Now we know that the filtered sizes array is equal to this new array, and then we want to convert it into the final result array. So the final array has the same length as the filtered array, but we take each value from the filtered array and then we modify it to the object. So this is exactly the work of the map function. And for that, I write the map method, and then I also initialize the map sizes array. So inside of the parentheses, I again write the name size. As with the filtered function, it will be equal to each value from our array. And then inside of the curly braces, let's write our logic. So we want to take the string small, and then we want to convert it into an object. So let's create a new variable, ball object. And now let's write the same object as we want to return. But instead of hardcoding the size to small, it is better to use the dynamical size value. So in this case, if we will change the business rule, so for example, instead of finding and converting small balls, we will need the medium ones. All what we need to do is to change this string to medium. And then the mapped part will be the same. So we will not even need to change it. And finally, let's return the mapped sizes array. Now let's log to the console our function to check how it works. So here I will pass the initial array, and now if you check to the console, you will see that we have an array with 2 undefined. And this is because inside of the mapped size array, we forgot to push our ball object into the array. If you will write return ball object, then you will see an array with 2 objects, and now you can expand them and you will see that each object has the name ball and the size small. So now let's continue with the second challenge. Here you will need to calculate how many swords can be crafted. So you will have the function craft maximum swords that expects one parameter, which is an array of resources. For crafting one sword, you need to take 3 stones and 5 wood. And these are the example input and output. So you have the array resources, where each resource is represented as an object. It has a name and the quantity. And then you will need to return only an object with the name sword and with the quantity of how many swords you can create from the initial array. So this challenge is a little bit more complex, and here you also can use filter map and reduce functions. If you can't solve it with these functions, think how to solve this challenge with common loops. But now let's solve this challenge together. At first, I write the function craft maximum swords. So now let's think of what kind of function we can use. The input is an array and the output is just one object. When we convert the array into just one item, we can use the reduce function. Now reduce function doesn't return an array, it returns one item. So on the same line, I can create a new variable. So for example, I can write sword, but we know that we want to return an object. So for better clarity, let's write sword object. Then we need to pass several parameters into the anonymous function. The first parameter is the value that the reduce function returns. So in our case, this is the sword. On this time, I will use a different name, just sword, so we will be able to differentiate both these variables. And then I also need to add the second parameter, which will have the value of each item from the array resources. So we can call it resource. And then between curly brace and parenthesis, we need to add comma, and now we can write the default value for the sword. So it can be the same object, but instead of the quantity 2, we will write 0. And now this is important to understand that these curly braces before the comma represent the body of our reduce function. And these curly braces represent the value, which is an object, for our variable sword. So even though that the symbols are the same, the actual meaning inside of it is different. Let's expand these empty curly braces, and now we can write the body of our reduce function. So at first, let's think what are the initial values for our sword and resource if we pass this array. No matter what kind of array we are passing, the initial value of sword will be equal to this default value. So this is the object name sword and the quantity 0. And then the variable resource will get the value of the first item in the array. So this is an object stone with quantity 6. Then if we reach the end of this function, the reduce function will update our resource variable. So on the second iteration, the resource will be equal to the second value from the array. So at first I see that the variable resource is always changing, but we actually need to store somewhere the amount of stone and the amount of wood that we have. So for that, before the reduce function, let's add 2 variables. and the initial values of these counters are 0. Now let's write the logic for the reduce function. So these two lines doesn't do anything, but I will stay with them, so it will be easier for me to show what they are equal to. So on the first iteration, the resource is equal to stone with the quantity 6. So now let's store this quantity into our variable stone. So for that, I write a new if statement where I check that if the name of this resource is equal to stone, we will reassign the variable stone to the quantity of this resource. Then let's add the same line for wood. So now let's think how it would work with two iterations. So on the first iteration, the resource is equal to stone. So it means that this if statement is true. So we reassign our stone variable to 6. So I update our variable and then we go to the second if statement and this if statement is false. So it means that we reach the end of our reduce function and then the reduce function updates the sword and resource. If we don't have any return statement, the sword will be updated to undefined. So at this point, let's just update our variable sword, but then the resource variable will be equal to the second item from the array. So this is equal to object with the name wood and quantity 10. So we go to our first if statement, which is false. Then we go to the second if statement, which is true. So let's update the variable wood. I put a new value 10, and then we reach the end of our reduce function. So if this is the end, the reduce function returns the value of our sword variable, which is equal to undefined. So at first, let's fix this problem with undefined, and for that, on the last line of the reduce function, let's add the return. So it means that after each iteration, we reassign the variable's word to the same variable. So in this case, this function will always return the object's word, but right now it means that we need to update the property quantity based on the resources that we stored in our variables. So before the return sword, let's write the logic that will increase the quantity of the sword variable. So for example, let's start from the if statement. I will start from the most natural solution, so I will just write the if statement with the condition stone more or equal to 3 and wood more or equal to 5. So this matches with the business rule that one sword takes 3 stones and 5 wood. Now let's update these variables. And then let's update the quantity of the sword. So here you can use plus equal 1 or plus plus. I would use the plus equal 1 to make this if statement consistent. So now let's reset our variables and then let's make 2 iterations again to understand how this function works. Sword is equal to the default value, resource equal to the stone. So we know that this if statement is true. So we update our stone. The second if statement is false, and then we go to this if statement with logic. The stone is more or equal to 3, but the wood is not more or equal to 5, so this if statement will be false. And then we return sword, which means that we keep this variable, and then we start the second iteration. So the sword is the same, but the resource is equal to wood with quantity 10, so we know that this if statement will be true. So we update the wood variable and then we go to the third if statement, and now we see that this if statement is true. So let's go to the body. Here we need to update the stone. So now this is equal to 3, and then we need to update the wood. So now it is equal to 5, and then we increase the sword quantity. And then I return this updated object. So it means that the reduce function will return the object with quantity 1. But here you see the problem. We still have resources and we actually can create 2 swords. So the problem here is that instead of this if statement, we need to use the while loop. So in this case, while we have both these resources, we will decrease them and we will increase the quantity of our sword. If we return one step back, after we updated our sword quantity, while loop checks the condition again. This condition is true, so it means that we execute the body again. So we update the stone. Now this is equal to 0, and then we update the wood. Now this is also equal to 0, and then we increase the quantity. So now sword has quantity of 2, and then we return the updated object. So it means that the reduce function will return the right answer. Now also after the reduce function, let's return the sword object. Now this is the return of the craft maximum swords function. So let's call this function and check how it works in the browser. Now I call this function with the same initial array, and in the console you see that we have an object with the name sword and with the quantity 2. So this is the right answer. Also, I want to show you a little bit more efficient version of this function. Now we have a while loop inside of the reduce function. So imagine if we have many resources, how many times your program should execute this body. So there is also another way how you can do it, even without if statements or while loops, just by using the math functions. So probably this version is a little bit higher than your current level, but I will try to explain you how it works. Math.min takes the minimum value from the list of values that you have. So currently we have only 2 values. Then we use math.floor to round the result to the nearest integer. So for example, in the case when we have 4 stones, this function will return 1. So this value will be equal to 1. So this is why we need to round it down, but actually the main logic is in the division. So imagine that you create swords only from stones. In this case, you need 3 stones for each sword. So it means that you can calculate how many swords you can create from your stones by dividing the stone amount by 3. So for example, we have 3 stones, and it means that we can create only 1 sword from stones. Now we have the same logic for woods. Imagine that you create swords only from woods, but this time you need 5 woods for 1 sword. So for example, you have 10 woods, then you divide it by 5, and then you will have the value 2. So it means that from 10 woods, you can create 2 swords if the recipe takes only woods. But our recipe takes both of them, and this is how we can find it by using the math.min function, because we had 3 stones, so we know that from this amount we can create only 1 sword, and then we had 10 woods. From woods we can create 2 swords, but also we can create just 1 sword. So and then the math.min will take the smallest number, in this case this is equal to 1, and it will be the right solution because from 3 stones and 10 woods we can create only 1 sword. I understand that the while loop solution might be much more natural for you, so don't worry if you don't understand the second solution, it will come with experience. So at this point the while loop solution is totally fine. So today we have solved 2 challenges with map filter and reduce functions. Today we will be learning about sort method in JavaScript. Also we will compare sort and 2 sorted methods, and I will explain you why you shouldn't use the sort method in JavaScript. So at first, let's learn how sort method works. So for that, I create a simple array numbers, and then I log to the console the numbers.sort. If we save the result, you will see that you have 1, 2, 2, and 3. You have an array of sorted numbers, and they are sorted in the ascending order, so it means that the first element is the smallest and the last element is the largest. So you might think that it sorts them in the right way, but let's add one more number. And now you see that if we have the number 10, it goes right after the number 1. So, but we would expect it to be in the end of this array. So, and this is because the default sort method converts an entire array of elements into the strings, and then it looks to each character inside of this array. So the first element is 1, but this is string, and then it uses the Unicode table that contains many characters, symbols, and numbers. But the problem with the number 10 is that this is a number. This is not just a 1 digit, so the Unicode table doesn't contain this value, and eventually sort function just takes the first digit, which is 1, and then it can find it in the Unicode table, so it uses the same value as for the number 1. So it means that no matter how many digits are after the 1, for example, we have this large number, the sort method will anyway put it right after the 1. So for the sort method, these 2 numbers are the same. But we don't want to sort the numbers as strings, we want to sort them based on their mathematical value. And for that, the sort method has one parameter, which is a function. So we can write the base for anonymous function, and then inside of the parentheses, we can write 2 values. So typically there are A and B, and then we can write on the same line, so in this case we don't even need parentheses. So I write the construction a minus b, and then in the console we can see that now our numbers are sorted correctly. So basically sort function works in the same way as map, filter or reduce. So it goes through each element from the array. Just this time, instead of one parameter, it takes two at one iteration. So it means that in the first iteration we will have values 1 and 2, then we will have values 2 and 3, then 3 and 2, and in the final iteration we will have 2 and 10. Then based on the result, the sort method understands which number is smaller and which number is larger, and then it puts them in the right order. We will not talk a lot how it works under the hood, just you need to understand that you can use this construction for sorting numbers in the ascending order. If you want to sort them in the descending order, you can change the numbers. So right now from the number b, we subtract the number a, and then in the console you see that the first number is the largest and the last number is the smallest. Now let's talk about the string sorting. So now I have an array of strings, and then let's log to the console the strings.sort. In the console we see that our strings have been sorted alphabetically, and you see that their order is the ascending. So here we are working with strings, so it means that the sort method doesn't convert them into the array of strings, and then it takes each character from this array and compares them to the Unicode value. In the Unicode table, characters are sorted alphabetically, and this is the reason why the sort function also sorts them alphabetically. So but now we have only single characters. Let's write words. So when I have words, it compares them in the same way, so it takes the first character of each word. So this is the reason why our words are also sorted alphabetically. But then if we have two words that are starting from the same letter, like banana and beer, in this case the sort function takes the second character and compares based on the second character. So we see that the second character of banana is A, which is the first character of the alphabet, and this is the reason why this word comes before the word beer. So but this order is ascending, so let's try to make the descending order. For that we need to pass one function, but on this time we can't write b minus a because b is a string and a is also a string, and we just don't have this operation like minus between two strings. If you save this sort function, you will not see any errors, but the order of the initial string will not be changed. To make the comparison between strings, we have a separate method, local compare. And now you can see in the console that we have sorted our array of strings in the descending order. So all what you need to know about the local compare is just that this is a helper method that helps two strings to be compared to each other. And then we can use the return result of this function for sorting our array of strings. Now let's compare two methods, sort and toSorted. I again use a small array of numbers, and then I sort this array by using the sort method. Now in the console you see that our numbers are sorted in the ascending order. Now I call the toSorted method on the same array numbers, and from the first point of view we don't see any changes. Actually, if you hover over each function and then read the description of them, you will see that they are very similar, and the only one thing that they are different is that the sort method mutates the array and returns a reference to the same array. So now I comment out the log with toSorted method, so let's clarify what it means. Now I changed our array numbers, so it will be easier to visually see the difference. Then I log to the console the numbers, and this is the first log that we see. So this array contains the same numbers, so the order of these numbers is the same as I wrote. And then I log to the console the numbers.sort, and now you see that this line 4 returns a new array with numbers 1, 3, 8 and 9. So from the first point of view, seems that everything works correctly, and this is a new array. But actually, let's expand the first array, and now it might be a little bit confusing why we see two different orders. If our array is collapsed, we see the order 1, 8, 3 and 9, but when we expand it, you see the order 1, 3, 8 and 9. And this is because the collapsed version shows the snapshot of the array at this point. At the line number 3, the state of our array had this order, but then on the line number 4, we changed the state of this array, so now the order of elements is different. different, but because the sort function doesn't return a new array, so it doesn't copy the array, it just mutates the array, we actually mutated our variable numbers, and when you expand your log, you see the actual state of your array after the running code. So, and now what we see is that the final state of the array is different from the state that was logged on the line number 3. And it might be a huge problem for beginners to actually debug this kind of behavior, because from the first point of view, we don't see all the necessary details. So now let's see how toSorted method works. From the first point of view, everything seems the same. But now let's expand the first array, and now you see that the state of the snapshot and the actual state are actually the same. So let's also expand the second log, and now you see that for the second log, this is also true, so the state of this array is the same as on the snapshot. So now let's hover over toSorted method. Now you can see that the description is the same, but this is the crucial line. So this method returns a copy of an array with its elemented sorted. So it means that instead of mutating the initial array, this function actually clones the array and then mutates a new array. So and finally, let's solve one code challenge where we will actually use this knowledge on practice. So at first you have an array of cars. So this array has several cars, and each car is a separate object that has brand, year and price. And then your first task is to sort this array by year in the descending order. And after that, takes the initial array cars and sort it by the brand in the descending order. And also one important constraint that you should log to the console a new array, so the original array shouldn't be mutated, and eventually we'll have two logs with two differently sorted arrays. Now try solving this challenge yourself, but right now let's solve it together. So at first, let's sort this array by year. So I start from the method toSorted because it makes a copy, it doesn't mutate the original data, and then inside of it, let's pass anonymous function. So then we need to understand what are the A and B. In the first iteration, the A parameter is the first car from our array, and then the B parameter is the second car from our array. So both these cars are objects, and it means that if I write A and then I put dot, I will see three parameters: brand, price, and year. Now let's choose the year. So this is a number, so it means that we can subtract the second number. And now this method will return us a new array, so let's declare it into a separate variable. And now let's log to the console this variable. Now in the console I see an array of objects, so let's expand it. And here I see that our cars are sorted by the year. So the first car has the youngest year and the last car has the oldest year. But we also need to write them in the descending order, so let's change the B and A. So the first car is the youngest one and the last car is the oldest one. Let's also log to the console the cars array to see that we have not modified it. So now I can see that the second log shows the initial cars and they are in the same order that we wrote them into the array cars. Now let's think about the second part. So we need to sort the initial array by brand and also in the descending order. So the beginning will be very similar. I use the toSorted array and then I have two parameters A and B. Now let's use the property brand. So and this is a string, so it means that we can't compare it by using the minus sign. We need to use the local compare method. And now let's also extract it into a separate variable and then let's log it to the console. Now I can see that our cars are sorted by the brand in the descending order. So for example, the car Audi starts from the letter A, and it means that in the descending order, it should be the last car. Also, let's log to the console the initial array. So here we can see that the initial array have not been modified, and now it means that we have solved this challenge. Now I hope that you understand the difference between sort and toSorted methods, and also you can use these methods for sorting our arrays of numbers, strings, or objects. How to organize your code in different files. So today we will be learning about modules in JavaScript. Until this moment, we wrote all our JavaScript into just one file. If our code is small, like on this example, so we have only 26 lines of code, it is easy to maintain it. But now imagine if you have thousands of lines of code, and then you see that something doesn't work. In this case, the debugging will be much more difficult, and this is the main reason why developers split our code into different files. Also later, when you will learn about different frameworks like React or Next.js, you will find that they have a very complex structure with many JavaScript files. And this is possible because of the modules. Now I have an example project. As you can see, we have only two files, index.html and script.js. So inside of my index.html, I have a small HTML file, and I also connect this file to our JavaScript. Now I have script.js file that creates two objects, hero and enemy. Then it also creates several functions like attack and isAlive. These functions are pure, what means that they only modify the data that is passed via the parameters. So for example, in the function attack, we modify the HP of the enemy that is passed to this function. And also in the function isAlive, we expect one parameter entity, so we can pass a player or an enemy, and then if this entity.hp is more than 0, we return true, what means that this entity is alive, and otherwise we return false. And then I also have a small section that logs to the console the enemy HP before the attack. Then I call the attack function, and then I log to the console the enemy HP again. So now let's look to the console what we have. I run a local server by using a live server extension. So now I see that I have an error that my enemy is not defined. I see that actually we have a const enemy, so let's use it instead of my enemy. And now I have two logs in the console. So the first log is the HP before the function attack, and the second log is the enemy HP after the function attack. Now this is not too important what this code does. Now let's think how to scale this code. Now in these files we have several responsibilities. For example, here we declare our variables, here we declare our functions, and here we call our functions and variables, and also we log them to the console. If we continue writing code in the same way, at some point it will be impossible to maintain. So let's separate this code into three different JavaScript files. At first, I go to index.html, and here in the script tag, I add a new property type which is equal to module. So now we can use the functionality of modules. So at first, it adds a keyword defer automatically. So it means that without the type module, we need to manually add this keyword if we want our JavaScript to be loaded after our HTML or CSS files. But here we don't need to do it because module adds it automatically. So the second difference is that module uses strict mode automatically. So sometimes in JavaScript, we might see this string in the beginning of the file. This string enables a strict mode, which means that it adds several limitations to JavaScript. So for example, in this mode, we can't declare variables without keywords const and let. If I write something like age equal to 30, I will see a reference error that age is not defined. So now let's remove the strict mode. I still see this error, but also let's go to our index.html, and here let's remove this type.module. And now you see that I don't have any errors, and this is because by default JavaScript allows this kind of variables, but in the modern JavaScript we should initialize our variables with let or const keywords. So, and you can enable this kind of validation by writing useStrict or by using modules type. So I stay with type module, and now let's remove this variable. And now let's talk about the main functionalities of modules. So let's create a new file. I call it entity.js, and then let's go to our javascript.js, and here let's cut our variables. And now let's use it inside of the entity.js. Let's also save this file. And now let's save the javascript.js. So we will see the reference error because enemy is not defined. So what it actually means, script.js doesn't see these variables inside of another file. So we need to explicitly show where these variables are located. So at first, inside of the entity.js, before our variables, we can write a new keyword export. So now we export these variables, and it means that from another file, we can import them. So here we can write the keyword import. Then I need to write curly braces, then the keyword from, and then I need to write a path. So this is a string that shows where our file is located. If our file is located in the same catalog, we can show it by writing /, and then you will see a list of files that you can import. So we can use the entity.js file. Now, inside of the curly braces, we need to specify what we want to import. So we want to import hero and enemy. So let's write them here. And now you see that our code works correctly. Actually, we have the same script, but now we split our code into two different files. So now entity.js is responsible for all kind of variables that we will declare. So this is also important to understand that we import only variables that we need. So for example, if we add a new variable into entity.js, even though that I wrote a keyword export, while I don't add this name into our imports, I will not be able to use it. But I still see several responsibilities in our script.js. So for example, here we declare our functions. So this is our game logic. Let's also add it into a separate file. I create a new file, gamelogic.js, and now I go to the script.js, and then I cut our functions, and then I paste them into the gamelogic.js. So now let's save both these files. And again, you see a reference error, attack is not defined. So it means that we need to import the function attack from the gamelogic.js file. So at first, let's add the export keyword. And then let's go to the script.js, and here let's import it, but now we will import it on a new line. So on the second line, I will write import. And now let's specify this path. So this file also in the same catalog. So I can write /. And now you see two files. So we need gamelogic.js. And then let's specify what we want to import. So we want to import the function attack. And if I write it inside of my import, you see that our code works correctly. Also inside of the game logic, we have a function isAlive, but currently we don't use it, so we don't import it. And now you see that we have split our code into 3 different files, and now each file has its own responsibility. Entity.js creates all our variables, then game logic defines all our functions that are related to the game logic, and then script.js import them and also call them. Also we use console.log function, but I think that this is normal for this file. Then let's talk about other features of the modules. So for example, we have a keyword default. And now if you save this file, you will see the syntax error. The requested module does not provide an export named attack. And this is because when you add the default export, you basically export it by the name default. And now on this import, you should remove curly braces, and then you will see that everything works correctly. When you have curly braces, you import the file with the same name as in our code. So here you see that I export hero and I export enemy, and then I import inside of the curly braces hero and enemy. But I also can have one default export, and in this case I don't even need to specify curly braces because I will anyway import the default from this file. But I anyway need to provide some kind of name, but here it might be anything what I want. So I will basically rename our function. For example, we can call it damage, and in this case let's change our attack function to damage. And you will see that everything works in the same way. So the name of the default import can be whatever we want, but the value will be defined after the keyword default. Also about renaming, we actually can rename our imports even if we import them directly. So for example, I import hero, but I want to call it player. So in this case, I can use this kind of construction like hero as player. And now if I save this file, we will see the reference error because hero is not defined. Now we defined it as a player. So it means that inside of the damage function, I should rename our hero to player. And again, everything works correctly. Now you know the basics about module. I know that in the beginning it might be a little bit more complex because now we have different files and it becomes more difficult to understand which code and in which order we actually execute. But I'm sure that with experience it will be much more simpler for you and you will find tons of benefit from the modules. What are sets in JavaScript and how they are different from arrays? Set is a collection of unique values. So this is similar to array, just it contains unique values. So this is a syntax for creating a new set. I store it in a variable set. And now let's log to the console the set to see how it looks like. So you see that this is a set, and then in curly braces you see the size of the set. So size shows how many elements a set contains. And also inside of the constructor set we can pass one parameter, which is an array of values. So for example, let's create a new array, and now let's add several numbers. So for example 1 and 2. And now you see that this array have been converted to the set with values 1 and 2. But for now I remove this array from the constructor set. And now let's compare the set to the array. So at first I create an empty array and then I log it to the console. And now between this array and the log, let's add new elements. So for example, for adding elements to the end of the array, we can use the push method. And now you see that our array contains values 1, 2 and 2. Now let's do the same but with the set. If you write the set then dot, you will see all the methods that we can call for set. The first method is add, and this is the same method as push for arrays, so it adds an element to the end of the set. And now you see the first difference. So you see that inside of the set we have only two values, which is 1 and 2. And this is because set contains only unique values. So if we add a repetitive value inside of the set, it will not be added. Now let's look how to remove elements from the set. So at first let's remove them from the array. For arrays we have many different methods. For example, we can remove the element from the beginning of the array. For that I can call .shift method. Then if I want to remove the element from the end of the array, I can call the pop method. And also in the array, we can remove elements from the middle of the array. So for example, let's add more different values. So now you see that I have an array with 3 values, 2, 2 and 3. And now let's remove the second value, which is 2. With arrays, we have a method splice, and one of the functions of this method is to remove elements from the middle of the array. So the first parameter that we should pass is the index of the element that we want to remove. This number 2 is on the second position, but arrays are 0 based, so it means that the index of this number is 1. And then the second parameter is the delete count. So with the method splice, we can remove more than one element. So for example, if I write 1, you will see that the only one number have been removed. For example, if I write 2, you will see that the only one number remains in the array. So but now about sets. So set contains only unique values, and it means that we can remove the elements based on the value, not based on the index. Set has a method delete where we can pass a value that we want to remove. For example, if I want to remove the number 2, I will pass this value, and now you see that we have only the number 1. And in the same way, if I want to remove the number 1, I will pass this value, so you see that this value have been removed. And for example, if I pass a value like 3, so we know that it doesn't exist in our set, you will see that this function doesn't influence our set at all. But if you hover over the delete, you will see that it contains also a return statement, and you will see that it returns true if an element in the set existed and has been removed, or false if the element does not exist. So for example, I can create a variable isDeleted, and then let's log it to the console. And now you see that if I pass the value 3, after the set, we see false. But if I pass the value 2 that exists in our set, it has been deleted successfully, and you see that isDeleted variable is equal to true. And also we have the second method that removes all items inside of the set. if I call the set.clear method, you will see that our set have been cleaned and now we have an empty set. Now what if we want to check that a certain value exists in the set or an array? So at first, let's check how it works with arrays. And for that, in the array, we have the method includes. So now you see that we have 5 elements in our array. And now we want to check that the value 3 exists in this array. So I can write array.includes, and here I can pass the value that I want to check. So let's pass 3. And now let's also store this result into a variable, and then let's log it to the console. So, and after the array, we see the value true, which means that the value 3 exists in this array. So let's also check the value 5. And now you see that this value doesn't exist in our array, so we have false in the console. So now you see that inside of the set, we have 4 values. And now let's check that if we have the value 4 in the set. So for that, I use the method has, and then I will store this value in the variable and log it to the console. And now you see that the number 4 exists in our set, so we have the value true. Let's also check the value 3. So the value 3 doesn't exist in our set, and this is the reason why we see false. So you might think that both these functions work absolutely the same, but here's one important difference. So imagine that you have an array with million elements. In the worst case, array will need 1 million iterations to find the right element with the method includes. And this is because includes methods work the same as a for loop, so it goes through each value from the array. But set.hash method can find the value immediately. So even if we have 1 million elements inside of the set, it always knows where this value is located, so it can find it immediately. But now about the main disadvantage, so why sets are not as popular as arrays. So and this is because we can't change values in the middle of the set. So as you see, we can add values only to the end of the set, and then we can remove them based on the value. But what if I want to change the values based on the index? So we can't access our elements based on the index. So for example, if I would try to get the first element from the set by using square brackets and then writing 0, which is the index of the first element, you will see undefined in the console. So you can't get elements based on the index. At the same time, in the array, if I add the same square brackets, we will get the first value from this array. Also, I can pass whatever index I want. So for example, the index 4. And now you see the 5th element from our array. So let's sum up when you can use sets instead of arrays. Set is a collection of unique values. When you need to remove repetitive values, you can easily use set. As you saw in this example, if we add the same value several times into the set, it will not affect the values inside of the set. And also, if you have many values and you want to find a specific value very fast, you can use sets, because .has method is much more efficient than includes method of arrays. But very often we want to access values by a specific index, and in this case you can use only arrays. Let's practice sets by solving this code challenge. In this challenge, you will need to implement the function unique words that expects one parameter words. So words, an array of strings. This function should return a unique array of words. So for example, we have this initial array words, and in this case, if we call the function unique words, the function unique words should return only these words. So I, he, she, and it. But at the same time, you need to filter in the case-sensitive way. So for example, here in the array words, we see 2 times the word she, but it is written in a different case. So your function should anyway understands that this is the same word and it should preserve only one word she. But at the same time, you need to preserve the original case. So back to this example, you see that we preserved the first word she because earlier than the she with the upper E letter. And the final rule is that you must use set in this solution. All challenges that you can solve with set, you also can solve with array, but in this case, the solution with array will be not as efficient as the solution with set. So this is a pretty complex challenge because we have several rules, and at first, I would recommend you to solve this challenge without case sensitivity. So it means that that instead of this array that returns only unique words, you will return all the unique words without taking into account the case. So literally, we see that both these words are different because they are written in a different case. And this is the reason why we preserve them. You need to remove duplicates only if both words are the same. So they use the same letters and they use the same case. Like for example here, we see 2 times word he in the uppercase, so we preserve only one word he. So try solving this simplified version first by using the advantage of the set. But now let's solve it together. At first I connected to the browser, so now in the console you can see the word undefined, and this is because this function returns nothing. For example, now I returned the original array words, and now you see it in the console. Then, as I said, let's solve the simplified version of this challenge. So what we know about the set? Set preserves only unique values, and set is case insensitive. So it means that if we pass our array words to the set, it will treat both these values as 2 different ones. And this is because they have different case. At this point, this is exactly what we need. So let's create a new set. And now here we can pass one parameter, which is an array. And then let's return the set. So now in the console, if I expand this set, you will see that we actually have the right answer. So you see that we preserve all these words except the duplicated he word in the uppercase. But now the problem that we return the set, but we need to return an array. So it means that we need to convert back our set into the array. So at first, you may think that you need to create a new array and then you need to iterate through all the values from the set. So let's try to do it. I declare the result array, which is equal to empty array, and finally I want to return this result array. And then let's write a common for loop and let's try to iterate through our set. At first, this is important to use the property size because set doesn't have the property length. And then I'm trying to access the word by using the dynamical index I. But as we remember, we can't access values in the set by using this numerical index. So if I will try to log to the console the word, you will see undefined 7 times. So it means that common for loop doesn't work for sets, but there is actually a different kind of for loop that we can use for sets. It is called for of loop. So at first I make the copy of this for loop, so we will be able to compare them. And then I clear the second for loop, and now let's write it in a new way. At first we need to declare the value that we want to get from our set. So we want to get the word, so let's here declare the const word. Then I need to write the keyword of, and then I can write set. And now let's log to the console this word. In the console you see 7 times undefined from the first for loop, and then you see that we have iterated through all the values by using our second for loop. So for of loop goes through all the values that we have inside of the set. So our set size is 7, and this is the reason why we have 7 iterations. Also you can use the same kind of for loop for arrays. So for example here, instead of set, I can write the initial array words. And you will see that it actually works, but in the console we see the word he 2 times. So sometimes we can use the for of loop as a shorthand instead of a common for loop. But now let's return back the set instead of words. And then instead of logging each word, let's push it to the result array. And now let's also remove the first for loop. And then you will see that this function works as expected. So now it returns only unique words, and this is case insensitive. If we write the same word in a new case, we preserve it. So, and as I said, this is a simplified version of this challenge because this kind of challenges are natural for the sets. But we actually want to filter words in the case sensitive way. So how to do it? If you need to write a code that will be case sensitive, at first you need to convert all items to just one case. For example, to the lowercase. So for example, here I write a new array words lowercase that is just a lowercase version of the array of words. And here we clearly can see where we have duplicates. So for example, here I have 2 times word she, and then I have 2 times word it, and then I have 2 times word he. So for example, if we pass this array to the set, so here instead of words, imagine that you have words lowercase array. In this case, let's think what kind of result we will have. So you will find that the result array will contain only 4 words, I, he, she, it, and they all will be in the lowercase. So let's look again on what we want to get. From the initial array words, we want to get only 4 words, I, he, she, it, and they should preserve the original case. So the problem, if we pass the words lowercase to the set, that the result will also be in the lowercase. But how to preserve the original case? Now let's combine both these techniques. So we will store the words array in the lowercase and we will use it for filtering, but for storing the results, we will use the original array. So let's go through an entire array words to understand how it should work. So the first word that I see is I, and then I want to convert it to the lowercase. But I don't want to mutate the original array words, I want to store it in a separate variable. So for that, I create a new variable word lowercase, and now it temporarily contains the lowercase value from the array. So then I will use this lowercase value and I will go to our words lowercase array, but instead of array, we will use set. And this is because set can automatically detect duplicates. Then we will ask from the set, do you have this lowercase value? Right now we see that set doesn't have any values, so then we will add the lowercase value to the set. And also, we'll go to the original array words, we will copy the original word, and then we will push it to the result array. Then let's go to the next word. So now I see the word he, I convert it to the lowercase, and then I go to our set, and now I see that we don't have this word in our set, so I can add it to our set. Then I can return back to the original array words. I will copy the original word and now I will push it to the result array. Let's go to the next word. So now we see the word she. I convert it to the lowercase. Again, I see that we don't have this word, so let's add it. Then let's add the original word to the results array. And now let's go to the next word. Now I see the same word she, but in a different case. But when I convert it to the lowercase, you see that this is the same as the previous word. But here, this variable doesn't preserve the history. So we need to go to our set and ask, have you seen this word before? Set answers that yes, we had this word before, so then we will skip this word. We will not add it to our array and we will not update the result array. So let's go to the next word. This is the word it, then I convert it to the lowercase, and then I see that we don't have this word in the set, so let's add this word to the set, and then we add the original word to the result. Then we go to the next value. This is again the word it, but in a different case. So the lowercase value is the same. And then we see that we have duplicate in our set. So we just keep this word. Then we go to the word he. Now we convert it to the lowercase, but then we ask this word from the set. And you see that set preserves an entire history. So the second word was he, and set anyway says that yes, we have this word in the set. So we can go to the next word. And then you see that we have the same word. So we'll skip it as well. And this is how the result array will give us the exact result that we want. So now when you understand the logic, let's try to implement the unique words function. But now let's implement it together. So at first, I will not pass the words lowercase to the set. Let's stay with an empty set. So in this case, you see that the result array is also empty. And now we will not iterate through an empty set. We will iterate through the original words. So the next step is to create a new variable word lowercase. But because this is a new cycle, instead of the keyword let, we can use the keyword const. And for converting it to the lowercase, we have a built-in function to lowercase. So then, instead of pushing it to the array, we need to check the set. Because if the word is in the set, we need to skip this value. So for checking it, we can use the set.has method. So .has method is much more efficient than includes method of the arrays. So, and as you remember, set always knows where this value contains. So it can immediately answer the question when we use the function has. And then I will ask the word in the lowercase. And if the set has this value, so if the result is true, in this case, we need to skip this word. And if the result is false, in this case, we need to add this word. So I will add the exclamation mark here, which means that let's go to the body of this if statement if this value is equal to false. You also can write in this way, but I will stay with a not operator. And then if we don't have this word, we need to add it to our set. and then we need to take the original word and add it to the result array. And then if you save this file, you will see that it returns the right answer. So today we learned how to actually use the set. Also, you know that you can iterate through a set by using the for of loop, and then we can use the .has method that immediately can find this value in the set. My huge congratulations on completing this course. Now you know a lot more about JavaScript and you are ready to use it in your own projects. You can continue practicing by creating your own applications, or you can move to my next game project course and continue improving your skills. Good luck with your programming journey!